All attendees, please take your seats. Our program is about to begin. Please welcome to the stage Jim Zemlin, CEO of the Linux Foundation.
Good morning, everyone. That's quite the intro and build-up there. Good morning, everyone. I realize it's the second day of the conference. People were probably out late last night. I see a ton of people out there. If you could file on in. Hopefully, you will all be energized by our speakers today. We have a heck of a lineup. It's going to be a really good morning. How many people here enjoyed the first day? All right. Most importantly, how many people here learned something yesterday that you're going to take back to the work you're doing, building MCP servers and whatnot? All right, that's what I like to see. That's what I like to see. So this is one of the first Linux Foundation hosted MCP Dev Summits, but we are doing a whole series, as I mentioned yesterday. You might recall that I introduced Mazen Gilbert, who's our new executive director of the Agentic AI Foundation. But today I want to introduce Angie Jones, who's the brand new head of developer experience at the Linux Foundation and the Agentic AI Foundation. And I'm going to take a moment to drop the mic and hand it over to Angie, who will MC from now on. You'll see both of us all over the world at our MCP Dev Summit events, but from here on out, Angie's going to host. So Angie, come on out. I'm going to do a sort of virtual mic drop because I've been told these are very expensive. So please welcome Angie Jones.
Hello, everyone. Hello. So good to see you all. I'm so excited to have joined the Agentic AI Foundation. If any of you know me, you know that I have been an OG MCP fangirl. I may have been the first blog writer of MCP. I don't know. Ask your agents, you know. But before we go any further, man, it's so good to see you all. It really is. I was at the very first MCP Dev Summit in San Francisco. How many of you were there? Okay, only a few. That's right, because it was about 300 of us. Shout out to Shannon. But we were so excited that 300 people came together to talk about a protocol, you know? So now to see so many of you, it really, really is exciting. Okay. Now, before we get into the keynotes, I want to remind you all that we do have an after party tomorrow. I mean, tonight, not tomorrow, tonight. It's tonight at 6 o'clock. It's at Lucky Strike, Times Square, 2-minute walk from here. You gonna meet me there? Yeah. All right, y'all don't sound confident. You gonna meet me there? I'll have food, I'll have drinks, games. We'll have a good time, okay? All right. So I'm going to introduce the first keynote speakers. These two guys are two of my favorite innovators in the MCP community. They are builders. They're always putting out bangers. And their latest one was MCP UI. Anybody heard of MCP UI? Right? Okay, so that was the initial work that they did to bring rich user interfaces into our agents, and that work has grown into MCP apps, which they'll come up and tell us more about. Please welcome to the stage Liad and Ido. Welcome.
Okay, hello everyone. So we built this talk yesterday, literally, but it might already be out of date. Hi, I'm Ido Salomon. I'm the creator of MCP UI and the co-creator and maintainer of MCP apps.
I'm Liad Youssef. I work with Ido on MCP UI, and together we also lead the work group on MCP apps in the MCP committee.
So MCP apps are already everywhere. Claude, ChatGPT, VS Code, all of these already replaced walls of text with rich, interactive user experiences. The really cool thing here is that it revolutionizes the way that we interact not only with agents, but the entire web. And it feels like it's been here forever, but in reality, it's only been 4 months. In those 4 months, like, I don't know how many of you have been in the previous Dev Summit in London, but just 6 months ago, we really had to sell this idea. Everyone thought no one needed this, and we had this really huge chicken and egg problem. Luckily, just 4 days later, we got our chicken. OpenAI released Apps SDK, and suddenly the most widely used host in the world had interactive applications. We took advantage of this momentum. The community joined together, and Anthropic, OpenAI, and MCP UI joined forces to create a new spec to finally bring this into the official MCP specification. A draft was born just a month later. And as you can see, MCP apps extending MCP with interactive UI. It was very popular very quickly. People were very emotional about it. And with really hard work from the community over the past 2 months, we improved it. We really brought it to a place where it's ready to get dozens of new applications like Canva, and we officially launched both in Claude and VS Code.
And that was the starting point, because in the past 3 months, there was a rapid adoption across the ecosystem. And not just the community, but multi-host support. In just 3 months, we saw, these were the early adopters of MCP UI, so shout out for these companies. These companies adopted MCP UI when no one knew what MCP UI was. But now, we have VS Code, and we have Cursor, and we have Copilot, and we have GitHub, and we have ChatGPT, which adopted MCP apps as the recommended way of building ChatGPT apps. We have obviously Postman and Goose, and Claude was with Claude apps, adopted MCP apps. And all those hosts adopted MCP apps in less than 4 months, which is amazing. This is exactly what we try to do with this spec, with this standard, to have a unified spec across the industry. But not just hosts, not just big companies. We had huge community adoption. We had a lot of extensions and additions to MCP apps. We had Pi, the engine behind OpenClaw, that recently announced support in MCP apps, which is amazing. And we have a lot of advocates and champions across the community, talking, speaking, building things with MCP apps. In the official MCP apps repo, we have a lot of PRs opened by the community, and there's a lot of discussion going on there. And that's a good time to remind that MCP apps is an open standard. It's for us, for everyone. We're looking at it as the foundation of the new web. So everyone is welcome to join the discourse, to join the conversation. We have a public work group meetings once every 3 weeks, where we discuss additions to the spec, where we discuss changes to the spec, where we discuss input from the community, from host builders, from server builders, and we advance MCP apps to be this unified standard. But let's take a step back. MCP apps, like we said, started with the concepts of MCP UI. And the idea of MCP UI is that text is not an ideal interface, right? I mean, everyone here tried to ask the chat question, definitely a year ago, and got a wall of text, right? But what if the apps, the connectors that are being connected to this chat, could actually send their own UI to the chat instead of just text? Because that was a big blocker for companies to adopt MCP. They didn't want to lose their brand. They didn't want to lose their identity. They didn't want to be reduced to a database, right? But what if they can just send their identity? What if instead of this, we could have just have this? I mean, this looks much nicer. This looks more natural to us. And this actually keeps the identity of each of those companies, of each of those tools that are being connected to this chat. And these are not just presentational. They can also be interactive.
So a year ago, when I first released MCP UI, the concept was fairly simple. How do we create an open protocol to send UI over MCP, and also standardize the way that this UI interacts with the host? Obviously, we also had to encourage adoption, so we needed to put out community SDKs for easy adoption. So let's look at the core concepts behind MCP apps. The first one is, an obvious one, is how do we even take UI and pass it over MCP? So if we take this example, let's say that we want to get the best playlist in the world. So the agent would usually just put a tool call out to the MCP server, and in the old world, we'd get back a textual response. This is obviously suboptimal, but with MCP, with existing primitives, we didn't have to invent anything new. You could, instead of return text, point to a different resource, an HTML resource, and once the host already supports these resources, it can take the HTML and turn it into an interactive component.
And like we said, this component needs to be interactive. And for it to be interactive, it needs to communicate the view, the UI needs to communicate with its backend somehow. But we don't want the UI to communicate directly to its backend. Why? Because then the model would know what happened. So if a user clicked something in the UI, MCP apps actually standardizes the way this UI makes the change, takes the action. Instead of communicating to the backend, it just sends a message back to the host, for example, a tool call, a request for a tool call. The host gets this message and decides what to do with it. In this case, it decides to actually call the tool of favoriting this song, and thus closing the loop between the UI and its backend through the model. And the interaction doesn't stop only on tool calls. The UI can also send notifications or prompt requests to the host.
OK, so seeing is believing. Let's see an example. So let's say that I'm developing an app, and I want to understand how the funnel works. So I send a message, and it sends out a recall to, let's say, PostHog, and I get this textual response. It's factually correct, it's very informative, but it doesn't really help me to understand what's going on in a glance. But because Claude supports MCP apps and PostHog supports MCP apps, I can just say, show me. And now, instead of this wall of text, I get this interactive component that was actually created by PostHog, so it maintains their branding, it maintains their identity and user experience, and I can see what happens with my funnel in a glance. It doesn't just stop there. MCP apps doesn't only allow you to get pre-made UI from afar. You can also augment the agentic experience. So for example, let's say that I don't know what a funnel is, so I can just ask, tell me what a funnel is visually. And now again, instead of a long wall of text, I can get this generated UI, generated on the fly by the Claude team, where I can actually understand visually what's going on. The really cool thing is that, like we said earlier, it's not just presentational, it's also interactive. So not only can I see what's going on, I can also click on it. And what happens now is that we didn't have to type something out and hope that the prompt does what we want. The agent, or it can also be the app, curated an experience for us where I can just click on something. It would auto-prompt, send a prompt to the host and to the model to continue the flow and explain it to us. So how does it work in really 2 seconds? So the architecture is pretty simple. What happened here is that we prompted, that sent out a tool call. As we said, the tool actually points to a resource that might have already been prefetched and kept in the host. So the rendering is instant. We instantly see that there's an app there. That app is then rendered inside a sandbox. And because it's not only presentational, we can click on it, as we saw earlier. And what happens there is that an event is being sent out from this sandbox through post messages all the way back to the model, and we can continue the interaction without prompting. So in those examples, I could say, show me vision. I could click and get the next step of the funnel, and would just send out a tool call. It would prompt the model, call a new resource, etc.
And the amazing thing is that it's not just technical. It's not just the architecture change or the technical change that MCP apps bring. It's a new philosophy. It's something that ushers what we think of as the new web. So for example, imagine that you want to do something. You want to plan an event. Today, you have to open a bunch of tabs in your browser, and you have to browse between them, and you have to adapt yourself to a lot different a lot of different UI and UX, and learn those interfaces just to convey your intent to plan an event, to plan an anniversary or something like that. We don't need all of this, right? If we have agents, if we have AI, we can just take those interfaces and we can just break them into atoms and have our agent, our assistant, compose these atoms for us, right? So instead of having this multi-tab experience like we saw before, I can just ask my assistant to do something. It can then query Google Calendar, and get the UI chunk, the small view of Google Calendar that I know, that I recognize as Google Calendar, and Google maintains their identity. And then I can continue and ask something from Amazon, and instead of just getting the data from Amazon, it can actually get the small UI chunk from Amazon. And this streamlines my experience. This keeps the brand's identity. And that's also good for the assistant because they don't need to generate all of this from scratch. And my experience, instead of being multi-tabbed, can be something like that. So with the agent, with my assistant, I can plan my event using all those tools with the interfaces that I already know, and have it all in one context. And this is the real philosophy of MCP apps. This is what we're trying to bring. And we plan on continue pushing this spec, and we want to turn 2026 to the year where MCP apps is the global standard for UI, not just something that's adopted by some hosts or some parts of the community. The spec is evolving rapidly. In only 3 months, we managed to add all of these additions and more to the spec. We got inputs from hosts that said, hey, we want to be able to theme the small UI in Claude's theme or in ChatGPT theme, and then we added it to the spec. We added the sampling. We had a lot of cool things, and I really encourage everyone to come to the public meetings. But the spec is evolving. We have an official SDK for developing MCP apps. It's called Axt Apps. And the nice thing about having an official SDK is that you build it once and it runs everywhere. Like you saw, all the hosts support it. And also, all the spec changes are immediately reflected in the SDK. So the community and the hosts immediately adopting them. For example, here, Goose adopted the theming that we discussed earlier. Like we said, the repo has a place for the community to actually open issues and discuss issues, not just PRs. And let's talk about what's next.
Yeah, so what's next? MCP apps already supports a bunch of use cases. There are already hundreds of different apps and probably dozens of different hosts that support it. There are a few stuff that we are working on in the work group, so you are very much encouraged to join the work group meetings and use GitHub. First one is reusable views. We get that quite a lot. In the MVP, we decided consciously to simplify things. And whenever we send out a new tool call to render an UI, it replaces the old one. That works fairly well for most use cases. But if we look at this example from Autodesk, they have a really heavy application. Re-rendering it all the time doesn't make sense for the user experience. So we are looking at ways to update or bring new information into existing UIs. Now, one of the ways to do it is, let's say that each one of these has its own session ID, and we can just reference to it and push information in. But the second way to do it is to flip the script. If we look at this new proposal, which is app tools, the idea there is that instead of the tool injecting, references to update a specific widget, why not let the model or the agent use that application as if it was a human? So the idea there is that every app would have their tools, and instead of us interacting with the app, it would do stuff like fill out forms in our behalf. So the UI would be updated in place instead of updating in the server and then somehow making its way to the UI. Another thing that we are looking at, but it's not yet, I think, in consensus, is the idea that maybe HTML isn't enough. Maybe we need something like a native experience for mobile. Currently, we don't have a real use case for it yet. HTML seems to do a pretty good job with iframes. But if you do have a use case, then we'd be happy to hear about it.
Yeah, and the big elephant in the room, the question that we keep getting asked is how MCP apps relates to other generative UI methods. Because if we have this spectrum of how UI, how chunks, how the views can be generated, then we have predefined UIs, right? Which is the UI that the app decided to render. For example, the Airbnb UI or the Canva UI. And then you have things that are a little bit more flexible, like declarative UIs, like JSON render, where the app doesn't really render the UI, but just defines a structure. And then on the other hand of the spectrum, you have like the fully generative UI, where the model just decides to generate from thin air the UI. And the nice thing about MCP apps is that it supports all of them, because MCP apps are actually agnostic to the way the UI is being generated. It only standardizes how this UI gets to the model and how this model interacts with this UI. And a good example for that is a feature that Claude released only a few weeks ago, which is generative UI in Claude, right? Probably saw that. And that is using MCP apps under the hood. So this is generated on the fly, but it's wrapped in an MCP app. And that shows you the power, because MCP app can handle third-party UI or first-party UI at the same time. We're also working on interoperability with other UI protocols, because like we said, we want to have a complete stack of how to do agentic UI, whether it's MCP apps, AGUI, WebMCP. We're working on connecting with all of them.
So MCP apps isn't just a technology. It's really a new way to distribute your apps. If we look even just a few months back in October, ChatGPT had 800 million users, which is 10% of the entire world population using it weekly. The internet took 13 years to get to that, and that's, now it's actually 1 billion or something. That's over 160 times the market that the Apple App Store had when it launched. So you might ask yourself, how do you tap into that? Like, how do you get to all of these people? How do you get to all of these devices? So if you are developing an MCP server, or if you have an app, all you need to do is visit the official MCP app site. There's this QR code if you want to use it. And you can use the official MCP app skills to have your favorite engine to just code it for you. And if you are a host developer and you want to open your platform to this new technology and give this new experience to your users, instead of walls of text, interactive UI, you can either go to XTAPS to get like the granular capabilities, or you can visit MCP UI, which is the recommended client SDK used by Postman and Goose and others, and simply hook it up and get started.
And if you want to be a part of this new future, if you want to help us build that and plan for that, and if you're sitting here, you're already one step ahead, but this is going to be the future of the web. So if everyone here wants to get involved, visit the MCP apps repo, leave an issue, or take an issue, open a PR, help us build MCP apps from the spec side and from the SDK side. And I think more importantly, join the conversation. Join the working group Discord, where we have good conversations there with the community, with the host builders. For example, here there's a survey that we posted on how to call these small UI chunks. Everybody had different ideas. Eventually, we landed on Vue. We thought about applets, but Java stole that from us. Join the working group Discord, where a lot of good conversations are happening, and also join the community Discord, where people from across the community ask questions, give tips, and helping together to build this future of the new web.
So I hope when you heard this, you actually got a little bit excited. We have this unique opportunity to kind of take our apps, take the very way that our users interact with it, break it apart, and try and build it not as just one single app, not just one monolith, but actually just a part of a huge web of a lot of different apps, all connected through a model, and not only use it, but also shape it. You can actually be a part of how this happens, how this protocol is actually coming to life. And with MCP apps, you can really write your application once, and even this early, run it everywhere. Run it in Claude, in VS Code, in Cursor, in ChatGPT, anywhere. So what does the future look like? We're not quite at Jarvis yet, but with MCP in general and MCP apps in particular, we can bring new, rich experiences that would have seemed impossible just a few months ago to every host in the world. You can do whatever you want. So thank you.
Thank you very much. Yeah.
Thank you so much. Pop quiz. How many agents were mentioned in that talk? Yell them out. No, which one? 17? Anybody else? 16? Okay, I don't know the answer. But it was a lot of agents, right? The point is, this is what it's all about. This is what Agentic AI Foundation, we're a neutral home for these key primitives to ensure that they work across multiple tools. We don't want key technologies like this locked inside of a single vendor. So that was great. Thank you so much, Ido and Liad. Next up, we're going to have Ryan Cook, who is an engineering lead at WorkOS. Anyone here from the Bay Area? Okay, okay. If you live there, you know that WorkOS throws the best MCP parties in San Francisco. And so we're always excited to see what they're up to. They're a big supporter of MCP. And Ryan is going to come and talk about the role of context engineering and how that helps with the performance of large language models. Come on up, Ryan. Welcome.
Wow, what an intro. Good morning. Happy Friday. I'm Ryan. I'm one of the engineering leads at WorkOS. As you heard, WorkOS has been involved in MCP since the start. We do host MCP night. If you've been around San Francisco, you might have seen the flyers. It's where we bring hundreds of engineers and enthusiasts together to talk about all things MCP and have a little bit of fun. We also ship auth infrastructure that our customers use to secure their MCP servers in production. But today I don't want to talk about authentication specifically. Instead, I want to share how we are using MCP, the concepts and primitives in the protocol, internally to make agents within our company really successful. So tools are awesome. I think we all like tools that give models and LLMs power to touch the real world. They can create linear issues, query Snowflake, send Slack messages, doodle in Excalidraw. But we also know they don't necessarily scale well. You've already heard a lot of talks about running hundreds of tools within an agent. How do we give oversight? Where are the registries for all of these tools? And if you're using AI for productivity or coding work, you're also very aware of how important your context window is and managing what is in that context window. If you have too much context, your agent can just go on random side quests you don't expect. If there's too little context, the agent spins in circles. And so if context is really important for tool access to be successful, then the question becomes, well, how do I manage this context? How can I assemble it to ensure good outcomes? So our answer to this has been to build what we call a context engine. And this is a pipeline that injects task-specific context that the agent can use before it calls an LLM. We call it a pre-reasoning pipeline. So what does this mean? Well, if you're taking a tool-first approach, you're giving the model this big menu of tools, and it has to kind of choose the right tool for the job. Maybe it gets it right. Maybe there's a progressive discovery. Maybe this is also happening within your harness. But you're really kind of leaving open the door to uncertainty. For a context-first architecture, the pipeline executes and can do things like resolve identity to understand who's the person behind the agent that's trying to accomplish this task. It can use that identity to understand what are the resources that they have access to, and then based on those specific resources and that identity, inject semantic information about those tools so that when the agent actually goes to make that LLM call, it is providing very specific context to the model. Sounds great. Okay, what does this actually look like? So we've built this in a few layers. The first layer is identity. We use OAuth. We want to understand who the person is that this agent is working on behalf of. We've also kind of built session scoping so that we can give authorization to agents, but in a very short time frame. Then we're also resolving per integration information. And this is static knowledge about particular tools, like how we like to use those tools. It's part of the system prompt. And then it's also dynamic context. That is, when you're invoking this tool, what is the context about the organization and the identity that's relevant to that? And then finally, we build a semantic layer that is definitions, information that is specific to WorkOS that can be used across a lot of agents that they're speaking the same language. So the first layer is identity. We build on top of a lot of our products. Why is this important? Obviously, not every person has the same access to tools. Their entitlements are based on their role. Developers can access databases. Support folks can see customer chat logs, not necessarily vice versa. And then auditability is very important to us. We want to understand what actions the agent are taking and who's behind those. And so we need to flow that human identity through the agent's actions. But we're also concerned about duration of access. What we're kind of building towards is this idea that these agents are long-running, they're self-reasoning, and they're taking a series of actions on behalf of a user trying to accomplish a task. And so certain tool calls, we actually only want to grant authorization to that agent for a very short duration, usually around mutations, like making changes in other systems. OAuth on its own is kind of long-lived. You get a token, you can refresh it. We want to kind of scope that down into a short period of time. Here's an example of this in Claude Code. The Claude Code is trying to create a project in linear. This is recognized as a mutation action. And so this creates a link that then is given to a human to approve this action. And then this is scoped within a session. So this authority only lasts for a few minutes. If the agent were going to try to do this later on, that would fail. Now this is where it starts to get really interesting. We are injecting per integration instructions into the context window. Some of these are static. They are related to like how we want the agent to use these tools. Like here's an example of how it should call linear, use pagination, use this identifier format. This is kind of just baked into our system prompt, so it can survive compaction. It's used across agent sessions. We also construct dynamic context, and this is when the agent decides to actually invoke that tool. It's a free text instruction per integration, per identity in the context window. So this is an example of, I have an identity that is trying to access a data warehouse. Here's how the LLM can resolve relationships within that data warehouse using a join path in SQL. And this accompanies the tool invocation. So it's very task specific. And it's fetched lazily, so it doesn't bloat the context window. As soon as the task is done, we dispose of these instructions. And then we're taking this even further. Outside of MCP, across all of our systems of record, we're starting to create this semantic understanding layer. So an example of this is a semantic view in Snowflake. What does a sales transaction mean in WorkOS? Well, this is the key metrics or columns, data columns that is used to compute a sales transaction. Here's some other ways we might talk about sales transactions in our vernacular. And we need these to be really consistent. We provide this as an MCP resource. And this allows agents that might be communicating with each other to use the same language and the same definitions. So these are the three layers in our context engine. We've really embraced MCP and using the primitives of MCP and the protocol there to serve this context engine to agents. And what really excites us about MCP is that there are these primitives that go beyond tools that allow us to create these building blocks. And we're moving towards a place where agents are starting to coordinate themselves. And so this becomes a big orchestration problem, especially if agents have different contexts and different understandings. What this actually looks like is this is an internal app that we've built. And it's used by our support team and sales team to get real-time information about what's happening across the company or what's happening with our customers. And this isn't just answering questions with text. What this app actually does is generate miniature applications that live inside here, much like MCP apps. These are interactive. They can make changes in other systems. They can be shared. They can be mutated. It sits somewhere between like a dashboard and an internal tool system. But these apps are also only relevant for a short period of time. You know, they're trying to answer a point-in-time question or accomplish a point-in-time task. When that's not relevant anymore, we just dispose of those apps. And we really couldn't build a system like this if these agents didn't have rich task-specific context that they're using to generate other applications. Really powerful. This is an internal application right now, but we are going to be releasing something around this idea. So look for a launch in a few weeks. So that's kind of what I want to leave with, is like we talk about tools a lot with MCP, but I think what's interesting is there are these other primitives, and you can compose those in really interesting ways, specifically around context, so that when we start to enter this world where we have swarms of agents all communicating and coordinating with each other, they can stay really grounded, relevant, and ultimately successful. Thank you.
Thank you so much, Ryan. All right, so next up we have Nick Cooper. Nick Cooper is a member of the technical staff. I love that title. Jim, we should change my title to member of the technical staff. It just sounds really nice. All right, so Nick works at OpenAI. He was influential. He's always been influential in the MCP community and also in standing up the Agentic AI Foundation. He is one of the few people that is both on the governing board of AAIF as well as the technical committee. And so Nick is going to come up and talk about how multiple MCP systems can be layered to connect cohesive architecture. Come on up, Nick. Give him a... Come on, y'all.
Thank you, Angie. So yeah, as Angie said, I'm Nick Cooper. Have a weird-sounding title of member of technical staff, and a lot of weird responsibilities across this whole Agentic AI Foundation and MCP thing. I wouldn't necessarily consider myself as influential in it, though. Today, the talk, unlike a lot of what else you've heard, is very exploratory, very like thought-provoking is what I'm aiming for, very not concrete. If you're around last year, it's basically the same sort of style as last year's presentation, where it was just more about what we could do. So last year was a much, much smaller audience, much smaller space, room, significantly dimmer lighting. But what I talked about then was transformation and composition and these ideas of emergent properties of MCP. And what do I mean by emergent? I mean that like by combining these simple building blocks, we get much more complicated interactions, much more valuable experiences to users or businesses or even server providers. And I think actually the two talks before me demonstrate this really well. Like transformation was taking one layer and transforming it into another one, as we saw from WorkOS. And composition was this idea of maybe we don't just need one wall of text or one giant application. Maybe we need an environment that merges multiple UIs together in some way that's meaningful and understanding. Now, over the past year, we've seen a lot of this. There's a lot of composition, a lot of transformation. There's a lot of MCP. There's a lot of gateways, communication systems. The protocols are improving dramatically with new features like tasks, as well as MCP UI, the latest and so far only extension to MCP. But then, of course, we've heard the other news that obviously to everyone in this room, MCP is dead. So how do I think about this? I think about it sort of mostly at a high level in that protocols, like I have a sort of background where I used to like teach high school kids and that in like computer science, and protocol is a very confronting word. It sounds technical, it sounds confusing, it sounds unapproachable. They're just languages. And when you speak a language, like to another person, it's very similar to how a computer system speaks to another system. And then once you have that dialogue going, you want it to be efficient, and then you start to wonder, what can you do with it moving forward? Now, so just as I said, protocols, just another form of communication, and what can we layer upon this and transform it? So in the case of computers, we start with, well, these days, electrical or light. Then we build layers on top of this. We get to TCP, we get to HTTP. Every layer up, we're constraining and specializing and building new layers that add new functionality. We get to REST, we get to Open API. Every layer added new verbs, more structure. And MCP is just an extremely high layer compared to this, but it also touches on lower layers. Like we see MCP servers, but we also still use standard I/O MCP servers. These layers of abstraction, these layers of standardization, create standard patterns for observability, authentication, just the general structure and security of such things. Like for example, do you trust your agent with a private key? Maybe. I sometimes do, as with a lot of people here I expect have done as well. But I probably shouldn't. And these specializations and standard layers create injection points. Like one of the active discussions for an upcoming feature for MCP is interceptors. And that's recognizing that we need places to inject standard policy controls, security controls, or just telemetry. Now, with all these layers, it's a common lesson in computer languages that's sort of a bit past now, that if you really want to be efficient, you need to be low level. Like it used to be that oh, if you actually want to get performance out of the system, I have to know assembly, or then I have to use C++, or then I have to be on device. And the layers themselves get higher. Like the computers today use obnoxiously large amounts of memory and RAM and compute compared to the standards that we had, say, 30 years ago. When it comes to efficiency of a protocol, a reasonable way to refer to it is very similar to language itself, which is symbols per second, or just concepts per second. Efficient communication means you can express a complex idea. So it means you can use fewer symbols, fewer words, fewer sounds, or fewer tokens. They are essentially the most expensive symbols we have today. They cost money, but they also cost time. And when a model's running to a task, these tokens are also asymmetric. Like the model's output costs more than the input. Now, there's a function of this that's like billing and inference and GPUs and this sort of thing, but also time. Like it takes a long time to wait for something, be it a person or an agent or a model, to think of your input and generate a response. So there's always this asymmetry in communication. Now, since output is more expensive and time is precious, we always want to be very efficient and get as much value from this output per round of input as we can. And we're seeing this in MCP. So early exploration of MCP, as many talks today have demonstrated in ways, was MCP was function calling tools. Like it's just, for most people, yet another way to get more tools to the model. And then that comes with the inevitable problem of we've seen an explosion of MCPs. I don't have statistics at hand, but I'm confident there are thousands upon thousands of them. And then if you want to expose some reasonably large amount of these to a single model, a single turn, you'll quickly run out of context. You'll spend more time explaining schema than explaining the problem that you have. So we see two sort of patterns evolving that are very common for this. There's shell file system-like invocation. I personally am very Plan 9 pilled, if you will. And this is where everything's a file system, resources are just files, tools are in some way executable. The other pattern is very similar, but it's code-like, where your tools become functions. Typically these days in TypeScript or Python, but strictly speaking in any language. Both of these things, to me, are just another layer up. They're exploration of code mode. Like shells are just, we don't usually think of it as a programming language, but Bash is one. It's surprisingly capable. If you've ever investigated it, I don't recommend it, but it's amazing what you can do in Bash. Like asynchronous programming exists in Bash. Now, how do we handle this layer? It's just another layer in this stack of things. Like we went from electrical to open APIs. We've added more expressiveness, more specification. We're now subject to, say, typing in a language or the expectations of a file system. And we're doing this because at this higher layer, we can be much more efficient in token efficiency. By giving the model code, it can give us concise code that can filter output, reduce it down, just optimize how much context we're doing. And then also by combining commands together, sometimes the model knows that we need to do A, then B, then C. It doesn't necessarily need to hold our hands for this. It can write a program that expresses the same action. And then related to this, and I'm sort of working into the obvious question that's in a lot of people's minds of CLIs versus MCPs. Unless you're doing something compute-bound, your chances are your model needs to interact with the outside world. It needs to use resources it finds there, tools it finds there. Perhaps it takes input prompts from elsewhere. Really, it needs a context for the model, i.e. MCP. MCP, however, is a specialization. MCP is ultimately over HTTP or standard I/O. It's another layer in this stack. There's code mode potentially above it, raw communication primitives below it. And those raw primitives always work. We could just use bytes. The model actually is probably quite capable of generating abstract binary output. It would be an interesting experience. So we don't do that. We use libraries such as HTTP. We layer on top of it, as I mentioned, like REST or OpenAPI. And then we layer on top of that MCP. So we have these bidirectional primitives, a simpler landscape of tools, and also it brings us, pulls us forward to the latest standard. The biggest thing for me about MCP has been true for the full past year, which is the intent that it brings people to focus on. MCP is more than just an API. Computers have had APIs forever. MCP is an API for AI. So when you're starting an MCP project, you're thinking about how will a model use these tools? And also, you're thinking about how do I make sure it's secure? What is the best practices here? How do I make sure it's observable? How do I do the right thing, as it were? And MCP describes that foundation. There are millions of authentication protocols online. MCP says, let's use OAuth 2.1. There are lots of ways to express functions, like transformations of input to output. MCP has a standard schema. It specifies their JSON encodable. It also does this very subtle thing that it tells you, you're building this for an AI model. You're not building it necessarily for another developer. You're building it for this thing that has vaguely known properties. It's continuing to get better. And that's what you should target. So the example to me is always for gateways that transform OpenAPI specs. If you consider an email system, it has, when you think of it and draw it on a whiteboard or something, it will be send email, receive email, maybe list emails. It's very easy to come up with a few verbs. But then when you actually think in depth about it, you get huge amounts of functionality. You add drafts, you add labeling, you add folders, you add categorization, you have contact management. Your simple API is actually potentially by itself hundreds of tools. And that's great, it's very functional, but it can be confusing for a model. And so in building an MCP server, you think, what does the user want? The user wants to create a draft or send an email. So you build a very high-level API that makes it simpler for the person, and that's the intent you bring to API design. Now, this, I sort of missed a slide, sorry. With this API design, this is then my answer to a lot of the thoughts on CLIs versus MCPs, which is, if you have nothing, then you can build anything to make it available to the model. You can build a CLI, you can build an MCP. If you have an existing API, you could just transform it, pick it up, and ship it to a model. I would advise not that. I would advise writing a CLI around it or writing an MCP around it to bring that intent to what you're doing. As for whether or not one is better than the other, I actually sort of feel it's not a decision between one or the other. It's actually you clearly want both. There's a big history of CLIs that exist on the proverbial shelf out there. And there's MCP servers that are people bringing AI intent, and the most powerful systems will really combine both of them. Now, towards the end, I wanted to touch upon this looking forward. So last year, I spoke a lot about like crazy transformative things, and we've seen some of them, and a lot of them didn't work. But what else is there? And MCP for agents. So the agent word comes up a lot. It's possibly the most ill-defined term in computer science. MCPs, it's M and C on P. So it's tool protocols, it's context protocols, but at a high level, it really is sort of like an agent-to-agent protocol. Like tools are sort of abilities, tasks now are delegated work. Messages, inputs and outputs are structured and explicit, but no one really treats it like this yet. So I'm quite excited to see like MCP is the basis for agentic communication, because this is the next level of intent, which is you need a simple, detailed API to express the intent to an email server. But if the other end is also an AI-capable company or product or service, it's as good as the client at interpreting intent. And so you should really open it up and let it be a truly agentic communication. And then the last sort of thing is actually not so much a thought, but more of a call for input. So like participate on MCP Discords, like look me up on LinkedIn or whatever and just directly message me. Because the biggest problem that I think we're shortly going to run into is this discovery of identity, which is we've all built these layers. We've all built complex compositions of these things. It's extremely difficult to discover what is best. Like MCP has been so wonderful in creating this beautiful landscape of options of servers and clients and experiences, but there's so many of them that itself is a difficult thing to digest across many providers, many clients, many hosts. And so we need to try to work together to discover what is a robust form of identity that we can use everywhere and that it makes things discoverable and easy to find. And that's it. Thanks, everyone.
Thank you so much, Nick. All right. Next up, we are going to welcome Cecilia Liu, who is a senior product manager at Docker. Docker has been a very early player in the MCP ecosystem, and Cecilia is going to break down how they balance moving fast with also maintaining control, which I think is something that all of us are experiencing. Please welcome Cecilia to the stage.
Hello, everyone. Thanks, Angie. I'm Cecilia. I'm a product manager at Docker. I don't have a fancy technical title like anyone else in the room. So instead of talking architectural diagrams or sharing like different concepts, today I'm going to talk through some horror stories. So again, I'm Cecilia. I'm a product manager working on MCP Gateway. So because of that, I spent a lot of time thinking about what happens when agents go wrong. And actually, Docker has published a series of blogs on it. We call it MCP Horror Stories. And I'm going to share 2 today. The first horror story is about an unauthorized server. So it starts with an intern at a startup. The intern just joins the company and really wanted to get productive quickly. Naturally, like they just go to the AI agent and go online to find MCP servers, anything that could help with their productivity. The intern just searches with Google and finds an MCP server that seems pretty legit. It has all the readmes and everything, so then it just install it and start using it. Everything seems pretty smooth, but in the process, there's no review, no one approved it, no one knows it even exists. So what happens in 3 weeks? The security team discovers a data leak. Code base, APIs, secrets, everything at risk. So the data team just discovers this data leak, but it doesn't know what happens exactly because there was never an audit log, nothing to investigate. Nobody knows. The second story starts in a much safer place. So this is about a larger company. They already know that MCP server needs to be regulated, and so they have a list of approved MCP server. So we have an experienced developer, and it's using an approved MCP server, say like GitHub, and it tells the agent to clean up the repo for them. However, this developer is a strong believer of a fully autonomous agent. So it lets the agent execute everything without confirming. So the agent just gets a list of approved tools and start to plan its execution. They merge all the open PRs, delete branches, close issues, and in like a few minutes, the dev go check out the results of the agent and realize everything is gone. The work in progress PR that was in the local, never push it, never save it in the cloud, disappeared, and branches deleted. Nothing malicious really happened with the agent's execution. Everything was permitted, but it doesn't mean that everything is intended. So I didn't tell these horror stories just to scare everyone this early in the morning for people coming from the West Coast. I'm telling this because this is actually happening at scale. How many developers today in an organization is using AI? The answer is no longer like dozens. It's going to be hundreds and thousands or even more, and the number keeps growing. So the question is not if this security leak will happen. The question is really when this will happen, and when this happens, if you will know about it. But the good news is all of these are preventable. So you just have to answer 4 questions for your organization. What is allowed? So which MCP servers, which tools are allowed? Who is doing what? Which user is calling what MCP server, what tool from what client at what time? What is flowing through? So whether a credential is leaking or flowing through your model context. And then lastly, what happened? Whether you have a track record of everything that we just described. And a lot of organizations doesn't have answers to those 4 questions, and that's the gap. And if you want to resolve this gap, close the gap, it's also very easy. So I just pointed out 3 essentials: a control layer, a sandbox, and a very easy way to deploy the 2 of them. I'm going to talk through these 3 things one by one. So first, you will need to have a control layer. That's what we call MCP gateway. MCP gateway is a layer that sits between your AI agents and your MCP servers. Everything has to flow through it. So that makes governance really possible. Remember the horror story number 1, that unauthorized server? This can be easily solved if you have a curated catalog for your organization. So if you look to the right-hand side, your organization defines your curated catalog, picks the servers. This includes your custom tools that's only available in your organization. You can also mix match with the available tools that you can find in the market, but the trusted one, third-party ones. Docker also provides a curated catalog for organizations to choose and mix match. So once you have a curated catalog, you combine it with the MCP gateway. Any MCP server that doesn't exist in the catalog, the MCP gateway just blocks it. So the random server the intern finds, it just stops at step 0. It will never happen because the gateway blocks it. It's just as simple as that. And having a curated catalog is just a first step. It's just an entry point to the gateway. The MCP gateway does way more than that. So it handles authentication for you. For all your secrets flowing through, it will never reach the MCP server. Everything stays within your perimeter. It also handles policy management and access control. Those 2 things come hand in hand. If your organization has a curated catalog, it only is a blanket statement saying your developer has this list of tools. But what you can do with policy management and access control is that you can provide fine-grained control and saying that you can give this set of tools to your developers and that set of tools to, say, like your HR department and any other user groups. You can even define policies on specific agents or sessions. And lastly, you will need, the gateway handles audit logging, so that includes everything, a track record of who did what policies get triggered, what are allowed or what is flowing through. So that is the gateway. It controls visibility. It provides controls and visibility. A lot of people stops at this step and thinking that with the gateway, everything is safe. But I will tell you it's not. Because the gateway controls what the agent is allowed to call, but it doesn't control is what the agent will do. We all know that agents is kind of like have their own mind. It's like a different person. It's pretty non-deterministic in one way or another. I'm not going to solve the non-deterministic problem for you, but I think we can ground the agents in a way that with sandboxes. So Docker sandboxes, or in general, sandboxes, is a capability ceiling that defines what the agent can do, the maximum of what the agents can do. How it works is that a sandbox defines, controls file systems and network access. It's not at a policy level, but at an OS level, below application layer. So if a sandbox say, I don't want write access for my file system at this directory, the MCP server just cannot access it. The agent just cannot access it, cannot delete the file. So that's what makes a double layer sandbox plus MCP server gateway really reliable. So in practice, this means two hard walls. One is that we're running agents in different containers. So each agent will have its own container, own file system. Each agent will have no access to other sessions, no access to other hosts, to the host. And then there is a Docker sandbox running in a micro VM, contains all the containers, and the micro VM has its own kernel, has its own hypervisor isolation. This is also what our partner NanoClaw, which is a personal AI framework that is designed security as the first principle, uses Docker to implement their security principle. So as the founder of NanoClaw said, security has to be enforced outside of the agentic surface, not depending on the agent behaving correctly. And then lastly, what I just described needs to be very easily to deploy and operationalize. So for a lot of organizations, the governance stops if you want to throw away your existing tech stack or do everything from scratch. This is not the solution that you'll be looking for. The solution you've been looking for is not asking you to adapt to that solution. The solution is to adapt to your environment. So you'll be looking for something that works in your environment, whether you want to run it local or run it at a remote environment, it should work. It also would work with your tech stack. For MCP, you'll be thinking about identity provider like Azure AD or Okta. You'll be thinking about Secret Manager, AWS Secret Manager, and whatever that you're using. You'll be thinking about your observability stack, your dashboard. Is that Splunk or Datadog should still work if you want to integrate with MCP audit logging. And lastly, it works in your cloud. It works with your workload. So if you want to bring your own cloud, you want to do it on-prem, air-gap, with one Helm install, you should be able to install everything, whether single cloud, multi-cloud, your infrastructure, your choice. So that's what I wanted to cover. Just to recap, 3 essentials. You need MCP gateway, you need a sandbox, and then an easy way to deploy it. If any of these resonate and you want to solve all your horror stories, come find us at Docker's booth. I'm happy to talk to you in more detail. Thank you.
Thank you so much, Cecilia. Did y'all see that swag? Cecilia, show them your shirt. Amazing. For those who are old heads like me, that's the Doom. Yeah, Doom-themed Docker hoodie. Very cool. All right, so next up, we are going to have Ola Hungerford and Sandeep Bhatt, who are engineers at Nordstrom, and they're going to come up and share Nordstrom's journey in integrating natural language interfaces into enterprise systems using MCP. All right, please welcome Ola and Sandeep.
Hi, so I'm Ola Hungerford, and this is my colleague from Nordstrom, Sandeep. You might also have seen me around the MCP contributor Discord, GitHub, a few other places. But today we're going to talk about what we do at Nordstrom on the AI enablement team. So our talk isn't really about MCP. It's more, I don't even know if we say like agent or agentic in our presentation. But it's more about kind of the organizational and architectural discipline and the platform teams that we work with at Nordstrom. So kind of the three things I want to share today is that the first thing is we didn't start from scratch with integrating MCP. It really landed on foundations that already existed. The second thing is that we really encourage people to start simple and start with what they're already experimenting with. So I think for a lot of people that want to build agents, they want to do a lot of things, and they start very complex. Sometimes they start with a lot of kind of ideas. And what we really want is to narrow down on what they're trying to accomplish and make sure that they find all the right ingredients to make that happen. And the third thing that I really want to emphasize is that a lot of kind of the more boring work, the more kind of fundamentals are really what is most important for us to make this all happen. So like I mentioned, when MCP showed up, really we had a lot of foundations. We had engineering standards, sample applications, deployment pipelines, composable build system. And it might sound like we got really lucky, like we already had all these things, but obviously we've been investing in them for quite a while. And we really think that the organizations that do best are the ones that are going to absorb these new technologies well, are going to be the ones that focus on those foundations. So this includes like the platform components I mentioned, but it also includes like a whole range of community groups that we have at Nordstrom that do a lot of direct contribution to our ecosystem. And the other thing is that we invest a lot in our documentation. So really, the documentation plays a big part in supporting the agents that we do deploy at Nordstrom. And I think if you really focus on a lot of these building blocks, whenever a new technology shows up, it makes it a lot easier to make that an extension instead of like a total reinvention of what you're doing. So a few concrete examples of where this paid off early on is our first MCP servers are pretty basic, but we're very popular, basically connecting to our project tracker, internal wikis, and we deployed all this using our existing container platform, which was really convenient. We could have started with something that was very AI specific, but I think it actually was more convenient for us to just use our existing platform, and it worked out really well. And independently, our MLOps team also did the same thing for some ML workflow templates that they deployed using MCP. So I think if you're thinking about what to invest in, you really want to think about bridging the gaps in your standard tooling, but also creating paths for your community, like your expert community today, to contribute directly to your platform. Oh, and now I'm going to hand things off to Sandeep to talk more in depth about how we think about the full spectrum, all those different ingredients we kind of, provide for people to build with today.
Hi, everyone. So when it comes to AI solutions, there's a spectrum. So I'll start from the far end. We have complex agent orchestration, so multi-step workflows, multiple tools, agents working with one another. And then in the middle, we have dedicated MCP servers, so shared infrastructure that's connected to internal systems. And then finally, skills and local experiments also includes local MCP servers. And most use cases land here. And that's not a compromise, that's by design. We also want teams to be experimenting out in the open and not in silos. And that's where the registry comes in. So every MCP server, skill, or agent gets captured here. So who owns it, what data it touches, and its compliance status, whether it's been reviewed and approved, or if it's not ready yet. But we don't want governance to get in the way of experimentation or creativity. So we run an inner source model. Anybody is welcome to contribute a pull request. And when something gets traction, that's our signal to standardize. If we find that someone is doing something creative, we know that we have a gap that we need to fix. Now, we think that this is a good problem to have because it means that we have a community of co-enablers helping us find those gaps. Here's what a registry entry looks like. We use the open source registry schema as our source of truth. As applications build support for this, the registry can become the central authority for what's available and what's allowed. We also pull in enterprise application metadata, so things like support team, compliance status, data classification, because this isn't just about managing risk, it's also about knowing who's on the hook for when things go wrong. Now, to get to production, there's a process that teams have to follow. Initially, when the server is in an experimental state, it's only configurable as a developer tool in your MCP client. Then, as things take shape, it's available in a sandbox non-prod account, and then finally it gets deployed to prod. The governance in each of these environments is proportional to the risk and maturity. But none of this really matters if teams still have to figure out standards compliance and connections to internal tools by themselves. So we built an internal SDK, which is a lightweight wrapper around the MCP SDK, and any application using it gets things like auth and tool call observability for free. So the message here to teams is you focus on the business logic and the platform handles the rest. The SDK itself is built using the same building blocks that Ola talked about earlier. There's one more piece I wanted to cover. MCP is only as good as the data behind it. If your tools return bad information, the protocol doesn't help. The other question we asked ourselves is, if our agent disappeared tomorrow, would the knowledge survive? So we built a system that monitors our support conversations in Slack, and it waits for a thread to cool off and then determines what happened. So was something missing from the docs, or was someone correcting an answer from a bot? And then it finds the most appropriate documentation to update and then creates a pull request. So this way, knowledge that's trapped in your collaboration tool can now become part of documentation and then serve as better agent context for the next interaction. I'll now hand it back to Ola to talk about the human side of all of this.
All right, so yeah, everything Sandeep talked about it's really necessary, but it's really not the whole story because the other half is the whole human feedback loop. And I want to say that's really, I think, one of the hardest parts because when you're working on kind of platforms, platform enablement, sometimes you're moving really fast, but in a way that looks really slow depending on where you're standing. So it kind of depends on people who want to use certain features. It's the teams building on the platform might see everything that they don't have, and at the same time, when you're on the platform team, you see a lot of the day-to-day progression and experiments that really add up over time. So one thing that helped us scale with communication is having regular office hours. So it's really turned into this human feedback loop. So all the things that we create, the standards, a lot of guides, a lot of sample applications, they're only good if people know about them, if they know how to use them. But it also helps expose where multiple teams are building very similar projects. So for example, we've had multiple teams experimenting with operational agents for incident response. And that kind of duplication, it's not always a bad thing. I actually think kind of duplication can be good data. But the office hours helps reduce the duplication that's happening in isolation. And this isn't some kind of top-down mandate that everyone has to follow. It's more a way for people to come in, compare notes, and understand, for us, what we need to refine and standardize. So the other thing we want to be really honest about is that committing to the full lifecycle for a new type of service can be really hard. It's one reason why we haven't actually gone out and set up MCP servers for literally everything yet is because standing things up is getting easier every day, but maintaining it is what makes the exciting parts sustainable over time. So we really want to be patient. We want to be thoughtful about what we're actually deploying and making resilient, even while things are changing. And I want to say, it always feels like we should always be enabling more and more things, but we also feel like that kind of patience and discipline makes things a lot more sustainable in the long term. And it's also why we try to make things more visible through things like the office hours, through different channels, forums, really helps kind of establish that culture. So everything we've talked about today, doing registries, SDKs, standard pipelines, feedback loops, are kind of the same engineering fundamentals we had before, but just applied to a new capability. So, MCP, it's new, it deserves the same engineering rigor as everything else we support and build. And we kind of think about, agents are applications, if you want to oversimplify it. MCP servers are services. So if you're thinking about where to put your energy, based on our experience, we think it's really good to invest in those common paths between AI and your existing systems. And so even if you can't build the perfect platform solution yet, it's experimenting in the open is another big part of what we encourage. So we talked about how we have kind of this more sandbox environment, kind of this graduation path. Lets us draw a clear line kind of around what's an experiment and what we actually need to enable, or in some instances, refine. And I think by focusing on those fundamentals, you can really direct your attention to the right place. Because we only have so much human attention we can spend on the things that we really want to enable, and so that helps us really kind of funnel it in the right places. And the other part is kind of that whole concept of feedback loops. We said that phrase a lot, but I think it's both that feedback loops in terms of our documentation, our data, but then also having people come in and help us kind of evolve and learn what we need to improve. And it also helps us stay kind of more honest, right? Because a lot of times, maybe something isn't working, and we also need to know that as soon as possible. So it all feeds back into that platform. So we hope that some of what we shared today is useful. We'll be around to talk about platform, a lot of the things that we didn't get to today. So yeah, thank you.
Thank you so much, Ola and Sandeep. Okay, so next up we are going to have Jacob Wilson, who is a principal in PwC's advisory analytics practice. And he is focused on business-driven generative AI. So he's going to come and break down how MCP enables skills orchestration in enterprise. How many of you work in enterprise companies? Lots, right, right. And so, the demos that we see online, they're really cute, but we need to know how to bring this stuff back inside of our company. So Jacob, please welcome Jacob, who's going to come up and tell us more. Good luck.
All right, how we doing? Good. All right. So I think a lot of different talks this morning. We talked a lot about the technical capabilities, the art of the possible, how all this stuff is coming together. So wanted to bring this to life a little bit more for you all and how this is working with true enterprises today. So quick introduction. So Jake Wilson, I'm a partner in our analytics practice at PwC. I have the privilege of consulting some AI companies who are leading the latest and greatest frontier state-of-the-art models, as well as working with utility energy companies who are building and fueling the next generation AI data centers, and working with other clients across kind of industry and function. So I came from a kind of traditional software engineering background, fell into the world of AI about 9 years ago. At that point in time, we were doing some things in emerging tech, PwC, and then I was like, hey, being in software engineering is great, but in order to really lead teams in AI, I got to understand the details. Went back, got my master's in data science at UC Berkeley, which is, oddly enough, right when I completed that was the launch of ChatGPT. So it was like perfect timing. So been living in the world of generative AI for the past 3 years. it has been the most exhausting thing I've ever done. So what we're going to talk to you about today is how many of you all kind of think that your procurement function could be a little bit more efficient and optimal within your organizations? Okay, see a number of hands going up. So what we're going to talk about is how MCP comes together with skills orchestration and integrating with enterprise applications. So as part of this, the context and the background is this particular client and clients we see kind of across the board, especially as we're getting into manufacturing, who might be building the latest, robotics and other type of capabilities, is, if you look at these organizations, whether they're newer startups or legacy kind of enterprises, the challenge you're dealing with is I've got a lot of different buyers, right? These buyers could be people sitting in the research division who are, working on the latest AI models. They could be sitting in a robotics lab, building out the next state-of-the-art robotics. So the problem is, none of these people want to go into these complex systems like your traditional ERPs and procurement systems to figure out how to actually go procure GPUs, to go buy materials for, robotics, and to do all these things. So in this particular example, what we've created is a GPT app. That GPT app works with a MCP orchestrator. That MCP orchestrator is using the latest agent skills kind of format, which was published by Anthropic, and you see a number of people kind of converging around today to help determine, when a buyer comes in to make a request, is this related to direct procurement, versus indirect? So direct being more of like the robotics arms, the GPUs, indirect being like, hey, I need to get the CEO an ergonomic chair, right? So regardless of who's coming in, we just need a simplified experience, and then we do all the complex orchestration on the back end using techniques with MCP and agents to kind of do all that together. So that's kind of the backdrop in terms of GPT app communicating with MCP orchestrator, and that is then working with the back-end systems for the ERP and indirect procurement system. So here's kind of a little bit more of a detailed architecture view of what this looks like. So what you'll see on the left there is the MCP app and then kind of that widgets box. Think that widgets box is a standalone React application. So the way this works is if I'm a buyer, I come in and say, hey, I want to buy 10 robotic arms or 1,000 GPUs. Essentially what will happen is that GPT app will do an MCP tool call to the MCP orchestrator. That MCP orchestrator has skills built into it to where it then understands the user's intent and basically kind of trying to classify the request as direct or indirect procurement. Because if it's direct procurement, it goes back to one system. If it's indirect, it goes back to another system, and that whole experience looks different on the back end. And the types of things you need to provide on supplier, purchase amounts, purchase prices, and all these things to actually satisfy the purchase requisition. So that MCP orchestrator is doing that kind of initial intent classification and figuring out what it is that the user is trying to do. And then based upon whether it's direct, indirect, it will then say, hey, do I have enough information I need to then make the downstream call to like the direct MCP server or the indirect MCP server to then actually raise the purchase requisition for the robotics arms, the GPUs, or what have you. So is part of this, so let's say in this case of the direct flow, right? So we get the classification through the MCP orchestrator. That is then going to trigger the direct procurement agent. That direct procurement agent will make the MCP tool call back to that system. We'll get the necessary information to help, for example, validate the supplier that they're requesting is the correct supplier, and also can do some more advanced things over time in terms of just, is there a more optimal supplier based upon what you're trying to do, or the timelines you're trying to get all these materials satisfied by. So that kind of comes back through. What then happens through the MCP orchestrator, so I get my data back. Let's say I go ahead and raise the purchase requisition, goes back to that system. That information comes back. But now what I need to do is say, OK, yes, here's the data, here's the confirmation from raising the purchase requisition, that backend system. I now need to tell the GPT app essentially what UI resource to now load in with the data I got back from that backend system, along with the response from the direct procurement agent. So in that case, that's where the MCP orchestrator, again, kind of helps in terms of saying, OK, here's the information I got back. Now here's the UI resource that kind of goes along with that, so that now the GPT app can point to the correct view within the React application, and then start to load in the structured content that we got back from the MCP orchestrator, which was a result of triggering the direct procurement agent. So I think all that's interesting too, because in the end too, like if you look at the backend systems, like in this particular example, one of the backend procurement systems supports OAuth and direct flow of the user identity. The other system does not. And unfortunately, the only way you can interact with that system is through an API key. So not the most secure. So I think you heard in the previous talk too, this is where like MCP gateways are kind of helpful in the sense of, yes, I can secure and put RBAC in front of that GPT app up front. But ultimately, like if I want more protection, as it relates to how, like, who can actually invoke these MCP servers on the back end through the GPT app and have a little bit more fine-grained control, that's where those gateways come in place, where you can define additional policies to also restrict, like in certain scenarios, like, for our utility energy client, where we're doing transformation of kind of their operations of their data centers. There's very specific tools within the MCP server that you only want to invoke in certain scenarios. So that's where the MCP gateway can kind of help add another level of kind of granularity in terms of like security for how you invoke even the different tools or functions within the MCP servers. So it's kind of interesting to see all this come together just in the sense of not only can I use MCP to integrate with backend applications, but in this example too, you kind of see another pattern where you get things like ChatGPT, where the only thing you can expose to it is an MCP. But I don't, and in those cases, you can have one MCP, and you need a little bit more control over how things get routed on the back end. So it's kind of a pattern of using an MCP to help orchestrate, invoke agents, which then also invoke other MCP servers. So I find this one interesting just in terms of the pattern, and then also kind of using the latest agent skill standard that you see Anthropic and everyone converging on, which is all the skills and markdown files. What's funny about that too is it's just like another pattern of like tool calling in the sense of I'm exposing an array of a list of, in this case, skills with the name and description versus tools, name and description. But in this case, we've got the MCP orchestrator helping enumerate through that, invoking the right skills, which in turn invokes agents, which then invoke skills, which invoke MCPs. So hopefully that was helpful. Just kind of gives you a context of a real-world example as you think about how to use MCP in terms of enterprise transformation, where, again, this is really simplifying, in this case, the experience for all the buyers across the research divisions, robotics divisions, et cetera, just to where they can come into a very simple app, make a request. MCP does, the orchestrator does all the complex routing and all the back-end integration so that, those people working on these complex systems and robots don't have to go into these legacy applications to try and figure out how they work. So that's it. So we're out of time. Appreciate that. And yeah, if you have any questions down here up front, but thank you for your time.
Thank you so much, Jacob. That was quite impressive. All right. How y'all feeling? Good, good. Okay, we have one more keynote for you today. This is Anya Musio from, oh, hold on. Let me get myself together, y'all. All right, so we have Anya Musio, who is the head of AI platforms product in the office of the CTO at Bloomberg, okay? So Anya is going to come and talk about some of the challenges, some of the solutions in building AI infrastructure at Bloomberg. I love hearing these stories from big companies about how they're solving this. We're all trying to figure this stuff out. Everyone is just like coming up with their own solutions based on their context, but hopefully you're able to take bits and pieces from each of these talks and apply it to your situation, okay? So please help me welcome Anya.
Good morning. Just 10 more minutes and you get coffee. Cool. So thank you for the introduction, Angie. My name's Anya. I have a product group at Bloomberg where we focus on the infrastructure, the developer tooling, and the systems that really power our AI applications at Bloomberg. I also have the pleasure of serving as a board member on the AIF, so thank you for having me. And as you can tell, I'm the odd duck out. I'm actually like one of the finance bros. So I will take at least a minute to show kind of what we're doing and just kind of talk about my problems. So pop quiz. Who here has seen one of these Bloomberg terminals before? Okay, at least 5, 6. Okay, great. So contrary to what you may have read on the internet recently, it's not something that you can just vibe code in a weekend. Joke? Okay, good. So with the remaining 9 minutes and 30 seconds, I hope to convince you at least like a tiny bit that, you know, while interoperability is lovely and connects our systems, it's really building this trustworthy infrastructure that helps it be viable for us in production. Okay, quick history lesson. For more than 40 years now, Bloomberg has been serving leaders in the global financial industry to really have trusted sources of information that they can use to make really critical financial decisions. So you see our clients over here. We have folks on the buy side, like asset managers, portfolio managers, hedge funds, you know, those people who are really advising clients on investment ideas and opportunities. We have folks on the sell side, so those who are like traders or research analysts, investment bankers, and corporations who are really like managing these types of investor relations and helping facilitate transactions between buyers and sellers. So across all of these participants, the common thread is really that these financial decisions they're making are really in high stakes and very highly regulated environments, right? Which means that across the industry, there are significant expectations around transparency, accuracy, and market integrity. Now, for the past 15 years or so, AI is really incorporated into multiple Bloomberg products and has really become an important part about how we deliver insights to these kind of participants and help them navigate markets and turn this type of information into action, right? And with Agentic AI, we've obviously entered a new phase. Okay, so what do we mean by trustworthy AI? Well, back in January, we released our flagship Agentic AI application, announced AskB, and it's really transformed how these kind of customers might discover insights and interact with them on the Bloomberg terminal. So previously, they were using like hundreds or thousands of applications to find these things, and now they have a conversational interface to interact with it. This has really transformed or really helped us shape how we understand what it means to build trustworthy infrastructure for AI. So for us, this means 3 guiding principles. Number 1, we have to derive answers from trusted sources of information, so like real things down to the data point. We have to provide transparent attribution so that financial professionals can independently verify that what we're telling them is correct. And we have to, most importantly, build features that solve real user problems. So maybe not your problems or my problems, but those investment professional problems. And none of this isn't possible without the right infrastructure and the right open source projects underneath. So inside this network, there are gateways, there are models, there are tools, there are agents, and obviously there's MCP. So from an infrastructure perspective, what does this mean? Well, all those security bits that we heard earlier, we need those 9s. That's just like table stakes. But we also need to provide visibility and controls into the system behavior at runtime so that you can uphold these types of principles. And we also have to empower platform teams, like we heard earlier, to really enable continuous product improvement as the technology really evolves. So none of this is possible without MCP, obviously, but what we found is it doesn't give you the out-of-the-box the guardrails, the correctness, the governance, and that production reliability that you need in order to make something like this happen. Okay, so how are we upholding these principles when we do our product development? Well, some of it actually comes directly through engagement into MCP. So I'm going to give you a couple of examples of work that we've done, mostly through the Financial Services Interest Group as part of the contributors to that. So thanks to Sambhav, who's on the technical committee. He's really representing us there. And so two examples I can think of are interceptors and variants. So I've talked a lot about trustworthiness, which is a core tenet of responsible AI. And you can think about it through a very simple lens that I have up here. So AI systems should be both helpful to their users and harmless to the markets and to the clients. So what does harmful actually look like? Well, unlike or more so than general consumer AI, mistakes in financial AI systems can generate real reputational, legal market risk. There's a lot of money and a lot of commas on the line. So the types of risks that we're trying to avoid might include things like the disclosure of non-public information, unauthorized financial advice or transactions, market manipulation, misconduct, misleading, or dare I say, hallucinated financial narratives. And to mitigate these types of risks, we really develop a financial-specific taxonomy of safeguards that guide our systems to this happy green quadrant over here. Now, the challenge becomes integrating these types of services consistently as data is flowing between these tools and across various boundaries. So this is where something like the interceptor framework might come in. We heard that from Nick earlier. So what do interceptors do? The proposed interceptor framework enables messages to be intercepted, as you might expect, validated, and transformed at various extension points throughout the life cycle of the protocol. So you can think about that as directly imbuing controls at the protocol layer that get deterministically executed. And there are two types of interceptors. Those who like Kubernetes webhooks, this might sound a little bit familiar, but there are validators and there are mutators. So what do validators do? They allow you to question, is this safe? So you can inspect payloads. You can also block things if it makes sense per your policy. And mutators allow you to make this safe. So you can transform payloads, you can redact things, you can enrich them if you need to. What does this allow us to do? This can allow us to inject these types of controls that we have over here, call these types of guardrails, even uphold principles like making sure that we have citations. So the trustworthiness here should be fairly self-evident. We can detect these unsafe actions, we can block execution when necessary, and we can make sure that these things are verified as they're crossing boundaries. Cool. So that gives us a way to have some control over context governance. Now, what do we do with the sea of models that we have and the variability that comes with that? Sorry, I forgot that I had a thing. If you're interested in this type of topic, CEP 1763 has a good conversation about it, and my colleagues Kurt and Canis are going to be giving an in-depth talk about this later at 2:55 about the protocol. All right. So let's talk for a minute about variants. So in our environment at Bloomberg, we have many flavors of models. They could be open weight, they could be commercial, they could be homemade, grass-fed, fine-tuned for finance, the types of things that price bond valuation in real time. And in this case, we're talking about large language models, and there might come a time where you really want to provide the same type of capability or expose it to different types of interfaces or different types of models. So I have an example here. It's called Get Portfolio. If you're allergic to finance, think of it like Get File System as an example. And I want to expose the same type of capability, but in slightly different situations. So the first one might be a coding assistant. You're chugging along. You want something that's really IDE friendly for what you're working on. The second one might be something that's much more automated. You have a reduced amount of context that you can take. And the third one might be a conversational interface. An alternative might be you want to expose this to 3 different model families. Maybe one speaks JSON, the other one's really good at Markdown, the other one's optimized for XML. So naively, what you could do is build 3 of these separate MCP servers, one for each agent type. Or naively, you could create one generic tool that doesn't really serve any of these agents optimally. And that's where something like variants might come in. So variants enable an MCP server to expose multiple parallel versions of the same tools. You can optimize them for different models, for different agents, for different contexts. It also allows you to choose a default, so it just works like a default behavior. And you can also allow clients to dynamically select the right ones for the requests. You can give them a little bit of a hint. Now, what does this have to do with being trustworthy? It sounds like I've just given you some more flexibility, but arguably no. Variants actually make AI systems a bit more predictable. They make them more controllable, evolvable. You avoid duplication by bundling these different configurations of the same capability into like a single structured unit that you can now manage more efficiently. So without variants, I also find you get more noisy evaluation results and inconsistent behavior, but with variants, each model really gets the interface that's designed for it, which is quite nice. If you like this type of work, it's being formalized in SEP 2053. Okay, that was a bit of a whirlwind introduction into finance. The core idea is really simple, but I believe that the trustworthiness that we're looking for really emerges from the ground up, and it's through how we design our systems. And if this is a space that you're interested in, or this also keeps you up at night, we'd really love to have you involved. So the ideas are being shaped through the MCP community, through the Financial Services Interest Group. I look forward to the projects that we'll be joining, the AAIF, and in the broader community. So come through. Thank you.
Thank you so much, Anya, for the talk, and especially for the call for action for community members. All right, so that ends our keynotes. Did you learn something? Yes? Wonderful, wonderful. There's more in store with the track sessions. But first, we're going to take a nice long break. And this break is what I like to call the hallway track, okay? So you're going to go meet someone, connect. As important as it is to hear the talks, it's also important to network and make connections, okay? So spend this time. We're going to meet back in the various breakout rooms at 11:30. And don't forget about the party tonight, all right? Okay, y'all take care. Thanks.
Yeah? Nice. All right, cool. So, we're live? We're doing it? All right, we're back. That stream was awesome. Huge props to Anya's talk right there, and Jacob's. I like that little MCP gateway style. We're going to be walking around the hall before everyone from the keynote gets up here. We'll try and get the best swag, because I need some new socks. And I can bet you that there's some swag out there that is going to fulfill my dreams. So, as you know, we'll talk to people along the way. Let's go chat with some of these booths. Who do we have? Who do we have first? You guys want to talk real fast? I was talking to Jeremiah yesterday. What are you up to? What are you working on?
So what we're working on is just telling more folks about what we're doing with FastMCP. Of course, we have our Horizon platform. We have cookies. A bit, we're coming off.
One. Do I need to get scanned?
You don't have to get scanned, not for a cookie. Coming fresh off the funeral we hosted for MCP 2 days ago.
I saw that. Was it an open casket?
It was an open casket. If folks wanted to pay their respects, of course, when the internet says something like MCP is dead, then it truly is, and it's our responsibility to throw a funeral.
Especially, it's in your name. Yeah. So you gotta call it. All right, well, this was awesome. Thanks. We'll keep going. Maybe we find a Game Boy. Oh, I like that. All right, I like that. I'm not going to win. Can I talk to you guys real fast before the crowd comes? You're going to pass? All right, fine. Free real estate. You ready to chat?
Sure.
Docker. First of all, what kind of swag do we got here?
We have a bunch of swag. We got stickers. We have, I think it's a charging cable conversion case, so you can go from one to another.
Nice.
We have flask of water bottles.
Dude.
And
can I get one of these?
Absolutely.
Do you got to scan me?
Yeah.
Yeah. No.
Oh, okay.
Yeah.
There you go. And then we got these magnetic charging bricks, so you can put them up and then they'll wirelessly charge your phone. And then this has been the hot commodity right here.
You're giving these out? Do I got to sign up for a raffle or something?
Maybe
no?
Just you. We're gonna make just you sign up for a raffle.
And I'm gonna win.
We'll announce the numbers at the end of the day.
Nice. Yeah. So I'm pretty sure most people watching know what Docker is, but why are you here?
So Docker just launched its new MCP catalog. So you can set up an MCP toolkit. We have this video right here. But essentially, what you can do is you can select a series of MCP servers and then a client, and through an MCP gateway, it'll attach to each MCP server as it's been containerized. So you don't have to configure any of the, do any of the configurations or anything like that. It'll just run each of the MCP servers in its own container, and then the agent can talk through the gateway to each one individually. And
so each MCP server is in its own container?
Yes. And the whole idea we want with this is you're running an AI, you want to go as fast as you want to. You want to run that YOLO mode, you want to go wherever, but kind of scary, right? A little scary. So with an even more new feature, Docker Sandbox, you can put these agents in a sandbox, and they are contained, so you have these guardrails set up so you can go as fast as you want without breaking everything in the world around you.
Nice, I like it. Well, I'm going to have to play with it. I've been using Docker for sandboxes anyway, so it makes sense that you're doing that. Awesome. Tell me when I get one of these. I'll be back for the...
Absolutely.
Are you going to run out? Should I get it now?
Yeah, what do you boss?
Large for this?
We can get you large.
And how about this? I'm going to...
Oh, yeah.
Oh, dude, this is some serious swag. You guys might win the best swag of the day.
And if you want a sticker, we still...
Oh, yeah.
We
throw...
we've been sued by Game Freak yet, so you better get them while you can.
Get them while it's Can we throw it on here? Could you open it for me? Because I have no hands now.
Let me see if I can...
I'm going to be full of swag.
Which one is that? Is that the... Oh, we're putting the open one.
Yeah.
Oh, you've asked me to... There we go.
Put it there. Oh, nice.
The shovel.
Nice.
There you go.
The shovel mic. Dude, thank you. I feel anointed.
Yeah,
this is so much stuff.
You need a third set of hands there.
Yeah, I'm going to have to put it down, but we know who is in the running for the best swag competition. Check this out real fast. There's some Pac-Man here. Have a look at that while I go put this swag down. Look at this Pac-Man. People are playing Pac-Man. That's awesome. I got to put this swag down. Okay. First swag. Oh, what's up, dude? How you doing?
Good.
You ready to get interviewed on the stream yet?
I'm just waiting for the approval to come through now with the whole platinum member thing.
We're on stream though. We're live. Do you want to tell us about your favorite skill?
Yeah, the favorite skill that I have is not on the marketplace yet, and it's a one that I am designing myself. And the whole point of Claude is, it produces output and it gives you that dopamine hit that everyone is looking for. And sometimes that can be good, sometimes that can be bad. But when you're in a focus mode, you really need to reduce the output so that you can actually focus and think about what's happening rather than, pull that dopamine slot machine and get that approval that your brain so craves.
This is deep.
Yeah.
This is kind of deep right now. Okay.
Exactly. So I'm waiting for this thing. I wrote this skill called Focused Oriented Claude, FOC. It just spelled it out that way.
Not on purpose.
Not on purpose. Focus Oriented Claude, that you tell it what mode you want to work in, and if you want to work in thinking mode, it reduces the output that Claude produces, and it doesn't ask you the questions that Claude usually asks you, saying that, hey, do you also want to do this? So that way you're very, very focused on what you're doing.
Whoa. Okay, so you just bypass all of the normal features so that you can think deeper on this.
Right.
You gonna open source the skill so we can all?
Yeah. I am going to. I am trying it internally within the company. I'm trying it with my friends, and once I'm happy with what it does, I'm definitely gonna open source it.
Open source FOC. Thanks, Sid. I'll see you soon, man. All right, let's keep moving. We're gonna go over to my friends at Tailscale because I want to get a hat. Let's see if we can catch them when they are. Let's see what they got. I'm trying to get... Can I grab a hat from you all?
Absolutely.
Yes. You ready to chat? Tell me what you're doing?
Yeah.
I'm taking this.
All right.
Swag.
Well, I'm Kabir. I'm a product manager at Tailscale. We are an identity-based mesh network, so we help all of our customers secure connectivity and communications between their devices. Could be users, could be machines, could be services or resources or agents that exist within their organization. And then some of what we do is we bring all that together and help them either secure the access between users and machines and services that they're accessing, or agents and the services they're accessing, or engineers to the models and resources that they need to use in their day-to-day basis, like their day-to-day lives.
Okay.
Yeah.
And so, tell me more about the AI play and how this works.
Yeah, so what we've noticed over the past few years, and really increasingly the last few months, is that a lot of our customers are operationalizing AI use across the organization at like an incredibly rapid pace, right? And so you have like engineering teams, marketing teams, go-to-market, like forward deploy engineers. We see that a lot internally, where they're going to customer sites and they need to like help build a tiny feature for this customer. It's never going to get prioritized on the product roadmap. And so they can just go into Cloud Code and build something. But how does the IT and security team know that this is going to be compliant with everything that they need to be compliant with? Has it not used customer data somewhere along the way? Has it broken some internal policy? How much spend are they spending on this particular customer, right? So all of that is visibility that they didn't have previously. So with Aperture, which is
You're tracking spend too?
Yeah, we can track it via tokens that are consumed. So it's kind of a proxy for spend.
Yeah, makes sense.
Yeah,
Dude,
and it works with
very
any
cool.
of the like kind of major frontier models, anything you can run on Bedrock, Claude, etc.
And it's per product basis, or it's per, because if I create a product and I'm using 3 different models on it.
Yeah. It's per user or agent. So we have identity baked into the network.
Okay.
So I can track as an administrator using Tailscale's Aperture product, is the engineering group using more tokens than the marketing group, and how many did they use over some period of time? Or I can get down to like the machine itself. So I can say, hey, is the engineer on my go-to-market team using an outsized number of tokens compared to the engineer on my engiering team?
They are. What are they doing? We got to talk to them. They got to give a workshop.
What are they using? What skills are they using? All of this is like visibility that the customers need to just start with their rollout in a more safe manner.
Sweet, dude.
Yeah.
Thank you for this. Thank you for the hat. I appreciate it. I'm going to wear it now and the rest of the day. You guys got stickers? You want to throw a sticker on? Can you open it for me?
Yeah, I got you.
All right. I already grabbed one of these. The swag man.
How we doing?
Tell me about what you guys are working on.
So right now, we're a quality and security platform for developers all around the world with about 17 million lines of code, 17 billion lines of code being scanned today.
Billion?
Yeah.
With a B?
With a B.
Oh, you guys got socks.
And we got socks. So I heard Swag's in focus today.
Yes.
We have our Sonar
Look at,
socks.
I need to...
A whale stress ball, if you're really interested.
I really am.
Yeah, and then if you're really feeling fancy...
Oh,
gotta stay hydrated.
wow.
Gotta stay hydrated. Look at this. Get a little zoom in on that right there. No.
He's a natural. Uh-oh, you should take over the stream. You want to go talk to people?
You're doing great.
I like it.
Supplies limited.
Are you just gonna?
Okay. Yeah.
All right.
I'm kidding. All right, we'll give it out. We're sharing today.
Yes.
But no, the main thing that we're doing here with the MCP Dev Summit, and what we kind of want to educate everyone on, is really integrating their AI agent, whether it's Claude, Cursor, whoever they're using in Copilot, and making sure that as they're vibe coding, nowadays they're spending more time reviewing the code that they wrote versus actually writing the code. We want to make that review process a lot easier and more seamless. So we want to empower their agent through the MCP server integration, through agentic analysis, through context augmentation. So as that agent is actually writing the code itself, it's doing so within the guidelines and parameters that you've set with our tool.
Nice.
Yeah.
All right. Well, I appreciate you giving me another stress ball.
No,
My
stress
daughter's
it out,
gonna
man.
love it.
It's gonna be a good day.
I'm gonna keep rocking the floor. I'll see you guys. Thanks. Let's go. I want to talk with the mother duck, folks. Oh, we're just like a bulldozer coming through here. That lady did not look happy. Where are we going? I just lost Monica, but I want to go talk with these mother duck folks and see what's up here. Let's see what they're doing. Yeah. Where's Jordan?
Where's Jordan?
Where's Jordan?
It's Jordan today. I'm not nearly as bald.
Yeah.
He is at the Seattle Startup Summit.
Oh, nice.
I always love when people come up to me and they're like, "Where's your boss?"
Yeah.
It's like,
yeah, I got a few choice words I need to say to him.
Sam.
It looks like somebody was here. I took their spot, huh?
No, I think that's actually Garrett's.
Oh.
No, this is just.
Okay.
All right, tell me, what are you guys up to? Why are you at MCP Dev Summit?
Because we're building MCPs.
Okay.
We're fighting a good fight against the CLI.
For the folks that are uninitiated, they don't know what DuckDB is, they don't know what Mother Duck is doing. Give us the rundown.
It's a super fast in-process analytical database. DuckDB came out of research from the Netherlands.
In Amsterdam. Bunch of... No, I'm not even going to say it.
Just crazy. You know what's going on there. Databases.
Databases. And Van Gogh museums.
That's right. He would have loved DuckDB.
He would have.
So we're taking DuckDB, scaling it up to the cloud, built it to the cloud data warehouse, in-process engine is DuckDB. That's how we get super fast queries for customers.
Very light, very fast. Where's MCP come in?
MCP comes in because nobody ever really wanted to write SQL. We just did it because that was the best we could get. People want to ask questions about their data in natural language. MCP allows them to do that in a cloud client that they already know and love.
Okay. So, do you build with coding agents?
I do.
All right.
Quad code filled, I would say.
I got one question for you then.
People. Yeah, ask the question.
Favorite skill?
Front end. The built-in front-end skill.
Yeah?
I love making little disposable HTML, bringing it up on a quick local server. We built a product around that experience called Dives.
Yeah?
It's it's basically our agent native data visualization product. We actually built a tool into the MCP server that gives it all the scaffolding, all the tools, spins up a local dev server. So it's like 30 seconds to create a dashboard. You don't have to click and drag anything anymore. You just tell Claude what you want.
Nice. Do you ever play with the playground skill?
I do. It's actually a lot of where the inspiration came from. So very similar, but you need to persist that, share it with your team, connect it to live queries. Mother Duck handles that with the MCP.
Oh, so this is like multiplayer mode. It's playground skill, multiplayer in a way.
Yeah, that's probably a good way to think about it. Yeah. So you want to publish that, share with your team, right?
Okay.
So
I like it.
Mother Duck runs all that infrastructure.
All right. You guys got any good swag?
We do have good swag.
Actually, I've got so much Mother Duck swag.
You said, Jordan, you have ducks.
I've got one of these shirts. They're incredible. But do you have any socks?
Socks?
Or
that's a real
no? Can I get some? Can I get some of this for my daughter?
Yeah, you can get it. For sure.
I don't want to just go grab it. Maybe you will have it.
I will facilitate that.
All right. Let's
you want
get
a
it.
yellow one, a white one, or both?
Both. So anything that my daughter would love. Even those Lego things. What are the Lego things?
Those are fidget clickers.
Nice.
They're blues. They're MX blues.
All right. Let's see what we got.
Orange and yellow.
Oh, thank you, sir.
You sit in the keynote and everyone will hate you.
Look at this. Okay. We've got some serious competition for the best swag. Look at me. I'm full. I am full of stuff. I'm going to have to put this down. I'll let you scan the field, and then I'm going to come back in, jump into frame. Hold on. Here. This is all for you. Thank you. Who am I talking to now?
Chain guard over here.
Oh, Chain Guard. Nice. I got to talk to them because they are also Seattle-based. I want to see more. That's good. What's happening, guys? Who am I talking to? You ready to tell me more about Chain Guard?
I think we'll pass the mic over
Rich.
to Patrick for that one.
Rich. All right. Yeah? Patrick, what's going on, dude? How you doing? I'll come over here.
Yeah.
What are you guys working on?
So we are working on Chain Guard libraries. So what Chain Guard libraries is that we take upstream public repositories like PyPI, Maven Central, and we rebuild everything that has a source link from scratch. And in our own secure, we call it the Chain Guard factory. Okay, we got a lot of hard hats and everything walking around. And the idea is that if there's any kind of attack, like if you've heard of Shai Hulud, that's the big NPM attack that was named after like a sandworm from Dune or whatever. Then you are basically just drinking your coffee and sitting watching this happen to other people because you are not going to be affected by it at all because we didn't get it hacked. The upstream repository got hacked.
Actually, I just heard about how they hacked him. Did you read the GitHub issue?
I mean, with Shai-Hulud, the worm? Or I mean, there's some,
Apparently, a whole elaborate scheme, and they invited him. First, they connected with him on LinkedIn, then invited him to a Slack channel, which seemed totally legit. The LinkedIn seemed totally legit from a company. Then they had him join a Teams call, and when he joined the Teams call, it looked like a total Teams normal thing, but then it said, oh, you need to update. And then when he clicked the link to update Teams, boom.
That's some deep stuff, man.
That was it.
I mean, we got worms out there. We got like full gaslighting campaigns. Yeah. It's scary out there, guys. You know. So okay, so check out ChainGuard containers and ChainGuard libraries. Nice. So be safe out there.
And you guys are based in Seattle, right?
We're based technically in Washington, but we're everywhere. We're a remote-first company.
Nice. Well, I'll come back and talk to you because I'm going to be in Seattle soon. So I want to hear more. All right. Let's see. Wait. Oh, I want to talk. I want to go to. Oh yeah. Let's chat. Who's ready to chat? You ready?
What are you gonna chat about though?
Do you use any skills?
Are we talking about skills?
You want to?
No, I think I'm okay.
What do you want to talk about? No?
Yeah.
No conversation. All right, we'll go to the job board. All right. Got the hand in the face on that one. That was a big rejection. So, check this out. Let's get a little quick, the whole board. Can you see that? If you're hiring, if you're looking for a job, or if you're looking to fill a role, it's full. It's pretty much full. Let's zoom in on one of these. CoreWeave is hiring a software engineer. Copilot Kit is hiring a forward deployed engineer. Any of these look good?
Copilot 1 is pretty interesting.
Yeah.
I mean, forward deployed engineer is the new hot role, right? So I'm not surprised to see that on there. There's also a ton of developer relations roles, which I think is kind of like a trend on that side of the board.
It's hard to fill. I see with Agent right there.
Yeah.
It's just hard to find somebody, A, who knows about this,
technical
and B,
enough,
who wants to like talk to other developers and get on camera. And developer relations has kind of been tainted a little bit too. I don't know if you've ever seen or tried to apply for a role. It's glorified marketing for most folks.
Yeah.
So it's a tough sell.
It must be a tough sell because there's got to be 5 or 6 of those in here. So everybody's trying to buy into like the developer experience, get everybody to use their stuff.
Yeah, the product-led growth, PLG, that's it.
The ROI for that's got to be huge because this whole thing is about who's using your SDKs, who's using your platform. So anyhow,
you know what, they gotta rebrand it to agent relations. Because
you're onto something there.
Yeah, you're not convincing the developers to use it anymore. You're convincing Claude to ping to your thing and the agents to use it.
100%. It's funny at this conference the vocabulary that's forming.
Yeah.
I was talking to somebody a minute ago. They're like, "Look, it's all about the tokenomics."
Oh,
like, that's awesome,
word.
right? Like, so like agent relations, tokenomics. Like we're finding this vocabulary.
Agent experience. I've heard. Yeah. There's no UX anymore. It's AX.
I love it, man.
Yeah. What are you working on?
I'm the Chief Product Officer at Interop.
Okay.
So our goal is to have a platform SDK for banks and other large enterprises to put all their applications. Was applications, now it's going to be MCP servers and agents. So just kind of trying to keep up to speed, man.
That's
like
awesome.
all of us.
Yeah.
Right?
Anything that you have as far as favorite skills go?
Ooh. I think the key with skills is to realize it's not just a recipe. Like there's scripts that can be invoked. I mean, my developers obviously like pull requests or anything that's just like routine or high frequency. Like that's pretty solid. But I think for us, it's like tokenomics. Like AI is expensive to invoke the stuff. So having something that's deterministic and scriptable, which can be in the skills, like that's a pattern we're seeing.
Have you played around with hooks?
I haven't.
Those are giving you, they inject determinism in a little bit. So try it. Play with it because it's also a good way to trace things. That's like the quintessential use case. You can have a hook ping out when certain code is run or when certain steps happen. But you can also say like, when this happens, grab this hook and then do this. So it's like injecting determinism into your non-deterministic system.
Exactly. I think that balance is key. And then you also talk about the observability.
Yeah.
Right? Like for all of this, this is all exciting.
Yeah.
It's all autonomous. Like I was talking to some hotel guys over there. It's like, yeah, but at the end of the day, something goes off the rails, an agent or you are going to be figuring out what it was. So,
yeah, totally. Well, you guys hiring?
Not currently, but just always looking at what's out here.
All right, cool.
I appreciate it, guys.
I like it. Let's keep walking. We're going to see. Did you get a photo of that food? It's looking good. All right, we're going to talk to Apollo. Did we talk to them yesterday? We talked to them yesterday. Oh, we'll talk again, I guess. We'll keep walking, keep seeing. I wanted to talk to the Kong folks because I like that branding. You guys ready to talk? You ready on camera? You're not going to get scared, are you?
No.
I'm looking for the best swag.
Looking for the best swag?
Yeah,
I mean,
as you can see.
I mean, go nowhere else.
Hey, there we go.
King Kong gorilla right here. What do you think about that?
That is pretty sweet. You're giving those out?
Of course.
All right, I'll take it. My daughter will love this.
Go for it.
Thank you, sir. What do you guys do?
So Kong, we are focused on AI connectivity.
Yeah.
So our goal is to be that infrastructure layer to secure, govern, monitor all of your AI traffic, whether it's proxying LLMs, whether it's proxying MCP servers, whether it's agent to agent.
All right. So tell me about I'm seeing a lot of cool diagrams on there.
Yeah, so this is what's called our agent data path demo. So our focus here, like I said, is being that infrastructure layer to basically monitor, secure, govern all the traffic. So we have a Kafka event stream that we're proxying. We have a sales support agent, sales agent, a support agent, and we have an orchestrator agent. All of this workflow is running through Kong's gateway, so we're hitting different model providers like Bedrock, Gemini, Azure. We're making MCP tool calls, and what we get out of that is a lot of good data. We get to track agent token usage, agent token cost. We can even see if a support agent is going haywire, and maybe we want to rate limit that immediately and figure out what's going on.
Yeah, okay. I like that. The tracking the cost seems to be a big one.
Absolutely.
Yeah.
I think first and foremost for most customers is how do we secure and govern all of our AI traffic? And this is a great place to start.
What are you seeing the coolest stuff from your customers? Like, what's the coolest stuff they're building with AI?
Coolest stuff. Oh man, that's a tough one.
Putting you on the spot.
Yeah.
This is, don't mind the light.
I do a lot of my business in the federal government space, so some of the things I can't really talk
Classified?
about. Classified?
You're going to pull the classified card on me? If I tell you, I'd have to kill you. All right, you want to throw a sticker on here?
Absolutely.
Can you open it for me so that I can? Yeah. Talking Kong, govern MCP-powered agents. This is a fascinating one, man. There's a lot of folks that are doing this. I get the feeling, there we go, front and center. Have a lot of people asked you, why are you different than the other ones? Because it feels like I've talked to a few different gateways.
I would say yes. There's obviously a lot of great vendors here that are doing different things, but I'd say that the common theme is how do we govern and secure all this traffic? So a lot of people are saying, how are we different? Kong, if you're familiar, has been in the API management space for over 10 years. Yeah. So our background in API management, I think, translates really well to the AI and agentic era now. New MCP world.
Excellent.
Yeah.
Well, sweet dude, thank you for this. I'm going to keep rocking. Appreciate it. Whoa, there you go. Who am I talking to next? Blue Rock. All right. You ready to chat? I think did I chat with you yesterday?
I think we might have.
I did, but I don't think on stream. I learned about what you're doing, but not on camera. So tell me, and the people at home, what are you working on?
So my name is David Onkway. I'm a principal switch engineer with Blue Rock. So we're an agentic security platform for observability for your agents and your MCP servers. We also host a public trust registry, mcptrust.com, that you can go and check out and view all the different MCP servers that are public, view their vulnerabilities, findings, and risk assessment.
You scanned all the MCP servers out there?
So we have about 10,000 scanned. I wouldn't say all of them because there's over 100,000 different MCPs, but we picked the most popular ones to look at.
Wow. Okay. And you can click through and see the different vulnerabilities that it has, and
so you can go through. You can see where things are vulnerable, where things maybe match up to different common weakness enumeration scores or OAuth top 10 for MCP. So it gives you some bit of general information. We also do a tool classification. So when you're looking at MCP servers, you might want to know which tools are read-only, write, destructive access. So we actually classify that all for you. And then also can integrate directly into our platform where you can also host your MCP servers and your agents.
Awesome. Well, this is cool, man. I appreciate you doing this, getting on camera, getting on the stream. We're going to keep walking. I'll see you later. All right, where to next? Who are we going to talk to? I didn't get to chat with the Manifunct folks. I wanted to yesterday. This guy was giving me a look like he wanted to talk. Let's see if we can just grab somebody off the side of this guy in the beard. I see somebody. I don't mean to put you guys on the spot, but would you be open to chatting? Tell me, it doesn't have to be anything sensitive. I see the companies. I've chatted with some folks from Lockheed Martin before. I want to know about what skills you use on a day-to-day basis.
MCP skills?
Or Claude, human skills? Your empathy. I want to know about the empathy you have.
For me, one of the biggest skills is the ability to search through external info. So, hey, here's our internal document site. Please fetch more info from here because the model's only going to know so much. So here's our doc site. Please find up-to-date info here, bring it in, validate it, and then it'll have up-to-date info. Outside of that, I'm a horrible web designer, so I use the front-end web design skill a lot.
So good.
I start off with sketching something out. Here's what I'm thinking. Here's a sample. Please help me. Go through the plan phase and then execute on that.
Actually, I was just telling my friend about there's this great website. I think it's like components.library or something, and it's 60 or 70 different front-end components. And so you can create a skill and then just point it at that and then say recreate anything, any of these components whenever you need it, and you have it right there. Beautifully done, modern looking, and so the front-end skill is great out of the box, though. It gets you so far. You got any skills? You got any?
Same kind of thing with just getting the latest documentation on something.
Fresh data.
Yeah. Models, even the most up-to-date models are still not always up-to-date. So pulling in up-to-date docs is big.
But you're actually saying go here and find it, or are you saying just like go find new?
Go find it. Oh yeah, no, I'm not specific about anything. No, don't have to be.
Just like search the web, make sure it's up to date.
Context 7 for the generalized ones, but for a lot of our internally developed stuff, it's not going to know about it. So then it's like, this is what you should follow.
Yeah. Sometimes if you don't give it that like pointer, it will get lost, or it'll take forever, or it'll come back with something irrelevant.
You need to go this way. All of a sudden, it's going here. You go get a coffee, you come back, and you're like, start over.
You know what's also fascinating for me is I was just in a talk where they were talking about how they tested different tools, like companies who were using, or like they tested agents against different company tools, right? Not like tools like tool calls. Like this is the, let's take Jira for a horrible example because nobody wants to use that. But like, hey, Jira is very hard for an agent to sync with because all the documentation is really bad. It's not like agent readable.
Layers of API calls and hierarchy and everything.
I was in a talk yesterday, and I was talking about you're not building documentation for users, you're building documentation for agents now. And Jira is a great example. If there's a ton of documentation for people, there's not a lot of documentation.
Well, you know what the funny paradigm is that you can make documentation for people that agents can't read, but you can't do it vice versa. You can't make agent-readable documentation that a human is going to be like, what's going on here? So you should do it agent first, and then if a human reads it, cool.
Telling a human versus telling an agent to RTFM is a very different thing.
Exactly. What were some of your favorite talks?
I like the documentation one. Like you had a good point of it's like agents don't need paragraphs, they need like hierarchical lists, but I liked a lot of the gateway chats because it helped. Like we knew we had to do a gateway, so it was good to see. In some ways, I like seeing other people struggle because I know I'm not on my own and I know really what we're going to have to focus on. So that. There's another one where it was talking about the human side of how you need to teach people who, what, when, where, why, how about these tools, not just make a server. It's like no one wants a mandate. They want the curiosity.
Yeah. So more just like how to spread this throughout the organization. Oh, that's cool. Do you remember the name of that one? I want to go back and watch it.
It was individual. It was by himself. Like, he wasn't with a company.
Yeah, okay.
He used to be a teacher. He had tattoos on his arm, and he had like a flying astronaut mascot in the front of his PowerPoint. Yeah.
I'm going to look for that thumbnail when it's up on YouTube later. Well, thanks, guys. I appreciate you being here in sports. Cheers. We're going to talk with somebody. We got more. You ready to chat? Tell me about your favorite talks thus far.
I really enjoyed the MCP UI talk this morning. I think it was very enlightening in the sense that it really highlighted the capabilities of MCP and how far it can go. At Naya, we are implementing MCPs as well, and we can already think of multiple use cases for technology like that. So, yeah.
Nice.
I'm gonna piggyback off of her because we've been discussing this talk as a group this morning. So yeah, it was a great keynote.
What did it inspire? You like want to go back and put it into practice so that folks can sync with your like front end, or?
Well, I can kiss my weekend goodbye because I'm going to be busy. And I think our team is probably going to be hacking away and building some new product offerings for our customers.
And so for folks who didn't get to see the talk or don't know about MCP UI, can you explain a little bit about it?
Yeah. So if you have a product that has a very deep specialization in UI components, and that's kind of where your experience for your customers comes from, MCP UI is where you would go to solve something like that. What you think of is, how do I showcase a part of my existing product into something like Claude or Gemini or any kind of external agents that are already out there, or something that I would also build on my own.
Yeah, because this is different than MCP apps. It's not rendering like front-end components inside of the chat. It's allowing an agent to go and interact with your UI on your website, right? Or on your app. Is that, I'm understanding it correctly? Or?
No. It's
Right,
allowing
your UI to be rendered
inside of
Oh, it is?
Yeah,
I think so. It's meeting your customers where they are. Like we're working at a company focusing on health and wealth through an agentic experience, and a lot of our workflows require you to be able to kind of see our data in a structured way, and like returning just structured data and having Claude decide what to do with it is going to render inconsistent results. And so we're excited about being able to have more control over what our data looks like and how it is presented to users.
Oh, I see. So you're really able to inject in your branding, your like, hey, if I'm giving you all this data, you visualize it in this way.
Exactly.
Cool.
So meet our customers where they are, but also don't cede as much control as maybe you have had to in the past.
Yeah. So last question. Do you have a favorite Claude skill?
Claude skill?
Or just skill in general that you use?
We have someone at our company, very well-respected engineer. Shout out to Bradley Verdino.
Shout out.
He's done a really good skill that's basically replicated him as a code reviewer, of course. And everybody wants Bradley reviewing their code. I know I certainly do, so we'll put that skill as my favorite.
Nice.
Bradley bot.
Open source it.
Yeah, we should.
Yeah. All right, cool.
All right, it's nice
Thank
meeting
you. Thanks for doing this. We're going to keep moving. That's awesome. I've been seeing so many gateways. We've got the gateways here. We got more people to talk to. Look at this.
Hello, what's your name?
Demetrius.
Peter
What's your
here.
name?
Nice to meet you.
So, what are you guys doing?
We are manufacturer. Let me put this on. And we build open source dev tools and infrastructure for MCP.
Okay.
We have one of the most popular open source SDKs up there. We started really at the beginning of the protocol, and so that's what we do.
All right. So, tell me more about what you're working on, your day-to-day.
Oh, the day-to-day is very exciting because the protocol keeps giving us new gifts to play with every day. So we split our time between being a community company with our open source and being a cloud company and an infrastructure company. So that's very exciting, of course, as an engineer. We're a very technical team. So that's where I spend most of my days.
And so I see you're talking about MCP apps here. Tell me more about MCP apps.
Yeah, so at the beginning, the product was just textual, right? So you could just return text or images. But MCP apps is an extension that allows you to return UI elements. So basically now, as a company, you can retain some of your branding and create these experiences in ChatGPT and Claude. And this, of course, is a huge opportunity for companies that can get their products in front of 1 billion weekly users. This just came out, 1 billion weekly users. So we're doubling down on apps which are just an extension, again, of the base protocol, which is just so powerful.
We were just talking to a few folks 2 minutes ago, and they were saying how they want to do that and they want to use it inside of their company so that they can render data properly.
Yeah.
What's MCP use? Nate, you ready to talk with me? You want to chat for a sec? Give it a minute. I'll come find you. No. All right.
Is this live?
Yeah, this is live.
That's fun.
Yes. MCP use?
MCP use is like we let you use MCP. We have agent, client, server SDKs for you to build a full stack. Give it a star, use it. It's very, very popular. We have 7 million downloads, 10,000 stars.
Right.
So give it a shot.
7 million downloads, a big number, man.
Yeah, that's not
You guys got any socks? What kind of swag you got?
Oh, we have this kind of swag. I think we have the hardest swag out there, to be honest. I love MCP, and we have a
We'll let the internet decide that. Go ahead, give it to me. Let's see. Let's see what you got. We're having a swag contest. Vote in the chat.
You can actually choose. Make something agents want.
Yeah.
This is going to be the new,
I like that.
the new thing for I love MCP. You want one of these?
Is this an XL?
No, we don't have XL.
What is this, L?
I was going to choose this one.
What do you think? I'm not an XL, dude? Give me a break. No. All right, I'm an L. Thank you. Cheers. Oh, look who stuck around. You getting all camera ready?
Gotta get camera good.
Did you catch that?
What are we talking about?
I mean, you do a lot of stuff, dude. I know you. The people at home might not know you. What do you work on?
MCP
and
MCP gateways, developer tools.
You're on the steering committee, right?
Not on the steering committee, but I'm one of the contributors to MCP.
There you go. Tell me about it.
And on some of the working groups.
Yeah, there we go.
Currently leading a working group on fine-grained authorization, which is a very spicy topic, it turns out.
What does that even mean?
That's the problem.
Yeah.
It means like 5 things to 6 different people.
Yeah.
So one thing it means is how do we make it easier for agents that are interacting with MCP servers to understand, you asked me to delete that document. Normally I can't delete documents, but I could if you gave me a temporary authorization to do that. How would that even work? It's some platforms support that, some don't. Some have no concept of like splitting up authorization that way, but that's very much where we need to move to in the industry, because when you have, it's one thing for me to give you access to a Google Drive file and say, oh, you get read-only or comment access or whatever.
Yeah.
But when we're talking about agents, people want that to be much more customizable.
And you want to bring that all into the MCP, like the temporariness of permissions?
That's just one example, but there's even at a more basic level, just having the agent be able to understand that it can or cannot delete something, or it has permission to do X but not Y. Even just expressing that is impossible today.
Yeah? Why? I thought you could just say, don't delete something, and then pray to God that it works.
Everybody knows that if you ask OpenClaw not to do something, it never will.
Yeah. Oh, man. Well, sweet, dude. I appreciate it.
Good to see you, man.
Yeah. When's your talk?
I already had it. It was last night.
Oh. Well, we're talking later.
We are.
For the podcast?
But when?
It's on your calendar. You rejected it. You rejected it. Check. I'll send it again.
Send it again.
It should be like at 4 or 5.
Okay.
Yeah.
I think my calendar auto-rejected.
Yeah.
Sorry.
I feel bad. I feel rejected. Let's talk with the OBOT folks. See if we can find Shannon around. Connie, you want to chat on the stream? Hello. Well, so there's something really cool that we're doing with you all. The context, for anybody that is not aware, on this YouTube channel. If you're watching on the AAIF YouTube channel, we're doing weekly calls with folks who are getting to demo all of their products and all their cool stuff. Can you tell us more about it?
Yeah, for OBOT, or are you talking about the context?
The context.
The context, yeah.
For now. Later we'll talk about OBOT. Yeah, don't worry.
Yeah, so every Thursday we have a live stream where we feature anybody who wants to talk about MCP, what you're building, what you're discovering, like general MCP stuff. And if you want to talk about it, find us on social, wherever. We'd love to have you on the stream. It's every Thursday. We usually stream at 10 a.m. Pacific time. We'd love to have you join us.
Perfect. Okay, now OBOT?
Yeah.
Tell me more.
Well, we have an MCP gateway, and as you might have heard in some of the keynotes yesterday, it seems to be where everything is kind of headed. Everybody's using MCPs. Everybody needs somebody to manage them. So that's what we do.
Nice.
It's open source, so go ahead and check it out, obot.ai.
Awesome. Well, thank you. We're going to keep moving. I think we're about to send it over to the next track. See you later. Yeah. Can I get some swag before I go?
Sure.
Oh, wait, this is, oh my God. This is good.
Some little Lego figurines.
Legos. Okay,
Yeah.
I'll take it. Thank you.
right, thanks.
Cheers. So, we're going to kick it over to the next track because the talks are starting. This place is not emptying out yet, but they should be. They're going to be late for the talks. I've been having fun with you all. Let's go check out the swag, see who wins. You tell me which one was the best. I only got one pair of socks, so I'm going to keep wearing these white ones. And I think now's the time to send it over. We'll see you all later. Let us know in the chat what you thought. Bye-bye, everyone.
How about now? Better? Okay. Yeah, welcome. I want to get started. I've got a full 25 minutes, so we may have some stragglers coming in, but I want to try to get through all the material. So this is code mode without the code. I'm going to talk about MCP Graph, which is a no-code code mode solution, and hopefully that'll make a little more sense as we go through this. So you're all probably seeing this very aspirational profile image. I just think we should all aspire to be the person that our AI thinks we are, as handsome and intelligent as they say we are. My wife liked this a little too much, so I tried to step up my game and decided to wear the suit jacket today. I'm Bob Dickinson. I've been a first line of code founder. I've had several successful exits and many, many crash and burns. I've also been a CTO for hire. I was most recently at Census for a couple of years doing an engineering turnaround, and prior to that I was at OneLogin for 4.5 years through the scale up and acquisition of the company. For the past couple of years, I've been building agent frameworks and MCP security tooling through my solo startup, TeamSpark. I also do some fractional CTO and advisory work, and I'm an open source maintainer of the MCP registry and MCP inspector projects. So before we get into code mode, we'll go back a little bit into the inspiration for code mode, and that was this paper that is referred to as the Code Act paper that was published in mid-2024 on the Apple machine learning blog. And the summary of that was executable code actions elicit better LLM agents, which didn't really explain at all what that paper was about. But what the paper was about was a lot of research, a lot of academic research into this notion that LLMs are much better at building code to execute algorithms than they are at executing the algorithms themselves, which seems a little counterintuitive, but it turns out to be true. And that's kind of manifest in things like the Strawberry problem, this is sort of largely solved now because LLMs have been trained on that question. But the idea that doing a predictive answer to how many R's are in Strawberry is something agents used to struggle with, but they've always been able to write Python scripts that could do that perfectly every time. So the idea is there may be cases where having an LLM write code or create some sort of structured output would give you better results for doing certain kinds of logic. And then if we go back to the end of last year, what I call the code mode revolution with MCP, a bunch of leading companies in MCP, all within like 10 days of each other, published papers that were all advocating this similar approach, which is essentially let's have our agents build MCP servers that do orchestration of tool calls if we have any kind of workflow that we need to orchestrate. And there's a couple of reasons why they wanted to do that. So the traditional LLM tool calling is problematic for workflows. So this idea that I'm going to call maybe several tools in a row and connect them together in some way. The example from the Anthropic paper was pretty simple. They want to read a transcript from a Google Doc, and they want to add that to a Salesforce prospect. So you've got 2 MCP servers and 2 tools you have to call, and even that, the agents would sometimes struggle with doing that correctly. So the 2 issues were what I call the dynamic orchestration issue, which is just the ability for the agents to correctly execute this, to understand what tool to use, what parameters to pass, how to treat the output, that sort of thing. And the other part is context overload. And these papers all focused way more on the context overload part of the problem than they did on the actual workability part of the problem, which is fine. I tend to think the orchestration problem is the more interesting part of the working set. So there's 2, we'll dig into a little bit of the context overload because that is something that comes up a lot. So there's 2 kinds of context overload that we're worried about with tool orchestration. One is the tool catalog bloat. That's largely a solved problem. Anthropic has solved that in all their products as of a couple weeks ago, which we heard about yesterday. It's been solved by companies like StackLock and Docker for 6 months or a year, where they've had sort of tool finding approaches. It is essentially the client's job to be a little bit smarter about this, and it's solved in Agent Core, it's solved in GitHub, it's solved in a bunch of places. So you probably don't have to actually have this problem today. If you do, there are solutions for it. The other tool call, or the other bloat problem is the tool calling bloat, which is this notion that when I call the tool, that tool call and the parameters I pass it and the output that it produces are all in the context stack. And for some of these workflow cases, that can be a lot of context. That can be a whole document. It could be 100K of text. And that's almost never content that's relevant to the goal of the LLM. So you can sort of address this with subagents. With subagents, you're still going to be burning tokens, and you're still going to have some of the other issues, but at least you're not going to be polluting the top-level agent with the intermediate tool output. But these are kind of a couple of the big drivers from those papers. And while we care about context bloat, it's time and money. You're going to pay for tokens, you're going to wait for the answer, but also it distracts the agent. So you have this extra context. It's immediately above the current goal in the context stack. It's unrelated to what the LLM is trying to do, and it's generally going to cause you to have worse results even outside of the actual orchestration, but in terms of solving the main goal the agent's trying to solve. So code mode was the answer. And in all cases, in all 3 of those cases, it was essentially, I'm going to go have my agent write an MCP server that itself instantiates other MCP servers and calls their tools and does the orchestration in code. So that's creating the whole MCP server across multiple files. It's bringing in dependencies. It's like real code. But they work pretty well. So in this case, this idea that you'd make a new tool called move transcript to prospect that took one piece of data which identified the transcript and maybe one that identified the Salesforce lead and would just do that one job and return a nice concise answer. And it had a massive reduction in context in token usage, like almost all of it. So my problem with code mode, my joke is it's in the name. That's the code part. Like I understand the rationale for it, and I understand how it works and why people would want to do it, but I just disagree that source code is the correct solution, or is the only correct solution. So we're having the LLM generate and execute code. Sometimes it's ephemeral. It's bypassing the agent's ability to monitor the tool calls because this new MCP server is calling those tools directly. It's generally, I just think, sort of scary. I've spent most of my career in some version of data security, internet security, and this just sort of worried me. And sandboxing isn't really going to solve it because I think some of the primary attack vectors are going to be using the MCP servers to exfiltrate data. And so even if you sandbox and even if you have everything tightly controlled, you're still providing this generated source code with access to your Salesforce and your Google Docs MCP servers, and you can do a lot of damage just with those things. You can clearly, I can go scrape your Salesforce and exfiltrate it to a public Google Doc just through the MCP servers without relying on any corrupting of the sandbox. And the big thing, I think this inspection and detection is challenging. It's creating this artifact, sort of not clear where it is, how it's structured. It's not easy to reason about it, look at it, and understand exactly what it's doing. So I think the idea is people are just sort of going to trust them and run them, and that also kind of worries me. And it's still code. So if you're in a move fast and break things startup, you might just say, like, this is just some artifact. I don't really care. It's all magic. It works. I'll take the risk. But if you work in an industry where you have compliance and security controls and you're worried about uptime and stability of systems, this idea that code is being generated and run as part of a production agent, code that nobody ever saw, I think is problematic for a lot of enterprises. So I thought, well, we could do this. How could we do this with no code? What would be the goal? And the goal would be, I want a solution that we can orchestrate MCP, so we can orchestrate tool calls. We can transform data. We can do some conditional logic, some basic workflow. Something that's predictable and complete with respect to all those code mode papers. So it can do all the sample examples that they gave. It's fast and reliable and predictable. The big thing was it's observable, that you can inspect it and understand it and look at it and understand exactly what it does with no surprises. And that means a human can do that, or an LLM can do that, or other software can do that, can inspect and understand exactly what's going on. And something that's simple. So I do want to point out, if you're an enterprise, I don't want to ignore the fact that these enterprise workflow solutions exist. So if you do have that sort of a problem where you are trying to do workflows, whether they're dynamic or whether they're canned workflows, that things like N8N and Zapier and Workato exist. They're very mature platforms. They scale well. They have great security controls. They do all kinds of things beyond what I'm going to talk about today. Not only can they all call MCP tools, they all expose the workflows as MCP tools. They all have MCP servers that allow the agents to interact with the workflows. So these are like very MCP first-class solutions. And if you're going to do something at scale as an enterprise, it's something you should think about for solving this kind of problem. And I will say, just sort of as an aside, at OneLogin, I chose Workato as a vendor to solve sort of a different problem of doing some long-tail integration. And again, at Census, I chose Workato as a vendor for another different problem. And in both cases, I wrote them large checks, and I did not regret it. Like, they were doing work that would have been more costly for me to do, and I wouldn't have been able to do it as well. So these are good solutions if you have those problems, and they're very MCP first. Okay, so for the no-code solution that we're looking at, I wanted something that was open source, something with no embedded programming language. I didn't want to make a DSL that was like a scope-down programming language, because then you just sort of get into this sort of break out of the sandbox challenge for people to attack it. And actually, after I built it, there was an attack on N8N where that exact thing happened, where they were able to compromise it and get it to run arbitrary JavaScript code. So I didn't want there to be any coding language that was exposed that could be attacked. And I wanted something that was composable by agent. So this is a little bit of the new world we're in, where we're building software development tools and we're thinking about the agent as the primary consumer of the tool, or the primary author of the output of the tool. So I could have just built a DSL and built some bespoke thing that did exactly what I wanted, but I didn't want to have to have like a ton of skills or a ton of training or fine-tuning for the agents to be able to do it. So I picked some building blocks that already existed. JSON Ada is one of them. It's a data transformation language, essentially, that's nice and deterministic. It can really do any way that you could imagine converting one chunk of JSON to another chunk of JSON. It can do. It can filter, format, sum, extract, group, like all kinds of things. And then JSON logic for conditional logic. So these have both been around for like 15 years. So there's tons of training data on the public internet. LLMs are able to easily work with these tools, which I sort of tested before I got into deploying it. So let's talk about MCP Graph. It's a DSL, domain-specific language for MCP tool aggregation and orchestration, where the tools are implemented as directed graphs of nodes. It's a declarative configuration, so you have a YAML file, a single YAML file that defines the tool and the tools it exports and the tools that it uses and the graphs. It can do data transformation, it can do conditional routing, and it's observable. You can look at this YAML file and tell exactly what's going on. You can run it and watch it run and see exactly what's going on. So you can install it as a NPM package. You can also get it from the GitHub repo. The GitHub repo also has links to a couple of demo videos. So I'm not going to have time to do the demos here, but there are a couple of pieces of this that are sort of interesting to demo. So if you do want to go look at that, you can do that. But the MCP Graph YAML structure is pretty simple. There's a server definition, MCP servers for the imported servers, and the tools that are going to be exported by the graph. All of these are the same shapes as the MCP spec. So when we define the MCP server here that we're creating, this is exactly the same shape as in the MCP spec for defining a server. If you've ever built an MCP server, it looks exactly like this. You can have server instructions. Anything that can be in that structure you can put here. So we're going to make one called file utils. This is a super simple example. I have some more complicated ones in the repo. And then we're going to import some servers. So this is the same MCP servers, exactly the same layout you'd find in any MCP.json file for any client. It's the same way that you would install it into Cloud Code or anything else. So in this case, we're just going to install the file system, the file system MCP server, and point it at a local directory. And then we're going to have a set of tools. These again are the same exact shape of the tools object from the MCP spec. So this should look familiar if you've implemented an MCP server. So this has a simple tool called count files that's going to count the number of files in our directory. Its input is an object that has a directory property that's required, and its output is an object that has a number that's the count. So very simple. And then before we get into the graph, I think there will be more node types than this. For this simple example, we're just going to talk about the basic one. So there's the entry node, which is where you enter the graph and takes the tool parameters and puts them into the graph context. There's an MCP node that can call an MCP tool. There's a transform node that can do data transformation. There's a switch node for conditional routing. And then there's an exit node which returns the final result back to the MCP tool. And those graphs look sort of like this. So this is a pretty simple one. We have an entry node. It goes into the list directory node, which is an MCP node that's calling file system, the list directory function, tool, and it's passing this entry count files.directory, so that's the directory parameter to the graph, is getting passed into that. And that'll go to the count files node, which does a transform, and that essentially takes the output of the list directory tool, which is just a bunch of text of the files, one per line, and it just divides them by line and counts the number of lines and returns that as the count. So pretty simple. And you can do way more sophisticated stuff than this, and then it exits. The way that you run this is you install it like any other MCP server. So MCP graph is an MCP server, and it takes one parameter which points to that graph that you're going to run. And then that tool will then show up in your environment, and you can use it. There's an MCP graph UX. This is a node app that's also in the repo, and this allows you to basically visualize and run through these graphs. So you can load a graph, see the nodes of the graph, you can see the server metadata, the tool information, and the MCP servers it imports. When you select a tool, it'll give you a form that you can use to fill out whatever parameters are needed to run that tool to do a test. And then you can run it, you can set breakpoints, you can single step, you can see the context in and out of every node as it executes, the execution time, and then the final result. So you can sort of really get a feel for how these things work and debug them. It's a nice development environment. And really, I'm focusing on the workflows, but this is also kind of a virtual MCP solution. Since I'm defining a new MCP server in YAML, and I'm creating new tools, I can also do things like tool composition, so I can pull in tools from other MCP servers, some collections that make sense for me. I can reshape the tools, I can change their descriptions or parameters. I can remap how the parameters in and out work with the tools. So I have a fair amount of ability to just essentially make a virtual MCP server that does whatever I want. And an example is if I wanted to very quickly make a file system server that only had the read-only tools and that I had structured output for all the outputs. So the file system doesn't have structured output. So if, let's say I wanted to have structured output and only read-only tools, I could easily do that with 50 lines of YAML in one of these graphs. So this is where the presentation would be done. I was going to celebrate. This is where I got to when I posted the first video, and I was all proud of myself because I accomplished what I wanted. I was able to do these code mode solutions with this nice DSL. And then I started actually trying to have the agent build them, and it failed miserably. Even though I had a really good skill and I thought I had all the tooling I needed, the agents were not successful. And I had some of the same challenges that the code mode agents have, which is the agent doesn't really understand, the LLM doesn't understand what servers are installed and how they're configured in your environment. So it has to have some way to know that, to find that out. It knows the tools that those servers provide, but it doesn't know anything about the servers generally. There's some issue like how do we know how to structure this code and where to put it and where the artifacts are going to be, how does the agent test these tools once they've created them, and then how do they install those new tools into their environment, into their own environment so they can be run. So I had a bunch of these problems, which I think are all sort of problems with all these solutions. And the first batch was I have a really nice skill file that's very detailed, and as a human could read that and easily figure out how to do these things. But when we had the agents do it, they failed. So we would have to give them like the exact MCP server to use, the exact configuration of the MCP server, like very detailed instructions to get it to succeed. So I started thinking like, why am I able to build these so easily and it struggles so hard? And I realized that I had access to a bunch of context and a bunch of tools that the agent didn't have access to. So my solution, this is sort of if all you have is a hammer, everything is a nail. So this is another MCP server. So this is the third MCP server that's part of this solution. So it's MCP Graph Toolkit. So this is essentially a development environment targeted at the agent to allow them to build these graphs and run these graphs. And so I gave it the tools that I had, basically. I said, okay, we have tools, you can interact with the graph, you can inspect it, you can add and remove tools to it, you can figure out what servers you're available to use and how to configure and call those. You can test individual chunks. So if you want to call, like one of the examples is most of the sample servers don't have structured output. Most of like the default included servers don't have any structured output. So the agent doesn't have any way to reason about what the output's going to look like. So it's like, well, I'm going to call this file system tool. I'm just going to produce text. I don't know what that text is or what to do with it. So what I did is I ran it and saw what it looked like. So now I gave the agent the tool to be able to do that too. And it can also test these JSON data and JSON logic instructions sort of separately to understand how they work. Then I gave it the ability to test the graph tool, so I gave it a tool that allowed it to run through single step, look at all the input output, like basically the same debugging experience that I have as a human. And then I gave it tools to deploy that graph tool and then to call that graph tool. So now the agent basically had all of the same information that I had when I was building them. And it was much better. I rebuilt the skill file. I removed most of the information that was sort of about how the graphs work and added a lot more information about how the tools work. And I found that was way more effective. And the way I did this is I did a traditional DevRel cycle. So I basically gave Claude, I used Claude Code for most of this. I gave Claude a prompt and I said, go build me a workflow that does X. And it would fail. Or sometimes it would succeed, but it would take a lot of wrong turns and a lot of time to get there. It would take like 3 minutes of all kinds of crazy stuff. So then when I get to the end of that, I would have a conversation with Claude, with the agent, and say, hey, I see you struggle with this. Like, what could I have done to help you? What skills could I have given you? What tools could I have given you? How could I have changed the way the tools work? And I got amazing, like shockingly good feedback, like way better than I've ever gotten from a human doing this kind of thing. So then I would go back and I would tweak it. I would tweak the skills a little bit. I would change tool parameter, whatever it needed. And then the great thing about this is with humans, you'd have to get a new batch of humans to do the second pass. And you would spend 3 months doing this. With the agent, I just shut down Claude Code, started it up again, and he was like, happy birthday, like Frosty the Snowman, and we just started over. So I did that maybe half a dozen times in an hour and a half, and I had something at the end of it that worked perfectly every time. It was great. It was like being able to do this DevRel cycle and learn how to surface the right tools and the right skills so that the agent would be successful in building these things. There's a demo video of this, but if you want to do this yourself, there's a Claude Code project in the repo. It's the /test Claude. So if you go clone the repo, go into the test Claude directory, you'll have a pre-configured Claude that has the MCP Graph Toolkit skill is pre-installed and pre-approved. The MCP Graph Toolkit server is pre-installed and pre-approved. And it's got a starting graph that has the fetch and the file system MCP servers. So you basically are like with just clone the repo, go to the directory, run Claude, and you can start prompting it to build these graphs, and it should hopefully work. So this particular prompt, create an MCP graph to download a URL to a local file in the downloads directory of this project and return the file name and size. I know that one works. But yeah, you can see what they look like. You can go run them in the MCP Graph UX, play with them, and then deploy them if you want. So this is the actual conclusion now that we've got the agents to be able to do this, which is we have MCP Graph, which is an MCP server that allows you to run these workflows. We have MCP Graph UX, which is the visualization tool that you can use to inspect it. That has an API that you can also use programmatically. So if you wanted to write code, like CLI or other kinds of code to do this kind of inspection, you could also do that. And then we have MCP Graph Toolkit, which is the MCP server targeted at the agents to do the graph development. And that's all I have. I'm shocked that I have 3 minutes left. I was sure I was going to go over, so I have time for some questions. Sure, you.
Great talk. I've been working on something. I've been using a very similar pattern, and I didn't know this existed, so thank you. Quick question about: was it an easy choice between like JSON Otter and other like similar things like JQ and JSON like that?
Yeah, I mean, I looked at a few. I didn't look at a ton of things. I did look at the JQ and a couple of others. And the main thing was I just went to a couple different models and gave them homework assignments to be like, go do this. And I felt like just maybe because of the amount of training data that the JSON ATA seemed like it was better supported. I don't think it would really make a lot of difference. I just didn't want to do something bespoke where the model had to figure it out. I just wanted something it would be able to do. Sure.
I also didn't know about this and have been building the exact same thing for similar kinds problems came upon similar kinds of solutions. So I have bunch of questions on functionality you've got so far. You say graph. You showed examples of sequential. Do you actually have parallel and like full DAGs?
Yeah, you can do a fair amount of stuff just with the switch. I don't have like a map reduce or any sort of way to like spin multiple jobs out. All the orchestration examples I was sort of trying to solve were all pretty simple. They weren't like pure linear, but they weren't like super complex either. But yeah, I feel like if people wanted to do that, and that's something it would be reasonable support. It's a little bit tricky because it's not sort of the spinning out and executing. It's figuring out how you reconcile all that and get it back to a single final exit point.
Okay, so the way I did it, I hacked on Solo.io's agent gateway, their Rust runtime, and just had the runtime be there, just be the data plane that will run parallel threads. You've got the DAG, and it'll just topologically sort it, and then just run through in sequence, packing the stuff together.
Yeah, the running part is not the hard part. The tricky part is just having a model about how you then consolidate that back and convert that into like the final result. But yeah, I think I've done this talk to a bunch of people at cocktail parties for the last 3 nights, and I've gotten a lot of interesting feedback. And so things like the prefect guys were talking about, oh yeah, you should have a map reduce in there, and like a handful of other primitives that would allow you to do a lot more sophisticated stuff, which is probably a good idea. And you could imagine endless things. I could have an elicitation node that could go out and collect information from the user based on some conditional logic, and then insert that as a parameter to a subsequent tool. There's like endless things you could do.
Is there anything on the current ones that take the annotations, MCP annotations that you can get for like knowing this tool is open world access, or this tool is not idempotent, or et cetera, those things at all?
No, but that's a good idea, because part of the observability part is like a big design criteria is I want you to be able to look at the graph, either just the YAML file or in some visualizer, and be able to understand exactly what's going on. So knowing like what those individual tools say they can do is also probably a good idea. Anybody else? Sure.
Where does this fit in? I'll talk to you after.
Okay, yeah, great. Yeah, I'll be around all day today if anybody wants to chat, and if anybody wants to use the code, I'd be happy to support it, open issues. Anyway, so great, thank you.
Good afternoon, everyone. I hope everybody settled in. Cool. Imagine a situation where you have AI agents which are getting the real-time context of the real-time data, and they're getting the live feed, and you're able to use those AI agents with the real-time data, right? So compare that with the situation where you have MCPs where there is a typical request-response model, and you get to know about some of the feeds or anomalies or patterns or defects after that has passed, right? So here I am. My name is Harshit Kohli, and I'm a senior technical account manager from Amazon Web Services. In the next 15 to 20 minutes, we are going to understand how we can extend the typical MCP beyond the request-response model and use it in terms of streaming the context to the AI agents, extend the capability on top of the regular MCPs we have, and then see a demo on how that actually works for you, right? So before I jump ahead, I'll just go ahead and explain the architecture over here. So if you see the top layer, we have event sources, which is like a log simulator. So consider it like you have a producer which is producing some kind of logs or context, right? Or let's say you have an application, web application, which is producing some sort of application logs, system logs, audit logs, whatnot, right? And then you have a message bus, which is Apache Kafka, right? So it could be Apache Kafka, it could be Kinesis data streams, it could be Confluent Kafka, it could be Amazon Managed Service for Kafka. It could be anything, right? So, and then the middle block, which is the green layer, which is the streaming MCP server. That is the core backbone, right? The way it works out is you have a Kafka consumer, which is consuming or subscribing to your events. We then have anomaly detection, right? And the way it helps out is, let's say there's a spike or there's certain kind of anomalies happening within your logs. Let's say there are too many database connection issues, or let's say the app is crashing, or out-of-memory exceptions. All those kind of things are getting tracked in these anomalies. Now you have a WebSocket, and the reason why we have WebSocket in this architecture is just to ensure that you have an abstraction layer, and it helps your agents to get connected to your feed so that the feed can come in real time to your agents. And not even the feed is coming, but also you can be interactive with those feeds, right? So let's say the feed is coming to the agents, but it is just accepting the feeds. But what about if you get a capability to interact with them as well, right? And then we have a CIDR policy engine. I'll come on to that later on in detail, but just to give you a brief idea, it's kind of adding an authorization layer here. It's like a gateway which will tell, okay, who does what and what is not allowed, right? So consider it like a gateway who is managing all your authorizations here. And then we have AI agent, which is subscribing to your feed, and it is trying to find out, okay, what are real-time feeds we are getting, what are all the logs, and what are the anomalies in them, right? And then at the bottom, you have remediation and sliding window. So we'll talk about that as well in the later slides. Now, let's first discuss the stale context problem. Now, instead of me talking about the theoretical concepts, I will be more kind of a practical, scenario-based approach here. So let's say you have a financial-based application, or you have a healthcare-based application, or you have a trading-based application, right? So you understand that even seconds or milliseconds matter over there, right? So you have an application which is running fine at, let's say, 2 a.m. Your AI agent is trying to monitor those logs, and the application is doing perfectly fine. Now, the polling is there, and then the first time it polls at 2 a.m., everything is fine. The second time it polls at 2:15 a.m., it detects that at 2:05 or 2:07, there were some anomalies detected, right? Good enough. You got to know what the anomalies are. But that is the main blind spot window, right? So between 2 to 2:15, there was a blind spot window in which it detected that, okay, at 2:05 or 2:08, there were some events which were having anomalies, but then it was reporting to you at 2:15. It was not reporting to you there and then, right? So that is actually the stale problem, and that is what we are going to handle as part of this use case, right? Now, if it's a stale problem, imagine a situation, what happens if all those events directly come to those agents instead of agents subscribing to those feeds, right? If the feeds are coming directly to those agents in real time, they're able to monitor it in real time, and they're able to detect the anomalies and report the anomalies in real time, right? So it will be like a complete real-time solution, which is giving you even a second or a millisecond kind of a detection, right? So let's see what the streaming MCP architecture is. So on the top, you have a traditional architecture, and at the bottom, you have a streaming MCP kind of a architecture here. So we have a client, we have a server, and then you have a response, right? So it works typically like a request-response model. You ask for a request, you send a request, and then you are getting a response, right? Whereas over here, by introducing, by actually introducing the MCPs and the Kafkas, what's happening is whatever the messages are being generated by your application or your events, those are coming in real time. It is going to get passed to your AI agents in real time. The agents are going to detect the anomalies in real time, and they're going to report that in real time as well, right? Now, the reason why we use Kafka here is just to make sure that you have durability, you have the replay mechanism, and you can handle the back pressure as well. Now, there could be a question, okay, why not if I use some other kind of a streaming architecture? Yes, you can. If you're able to support all those three capabilities, like the back pressure, the durability, and the replay, you could use any of the streaming architectures in this particular architecture. So for this demo, I have just gone ahead with using Kafka. Now, the other important thing to note here is it's using a hybrid kind of a protocol, right? When I say hybrid protocol, what I mean is, as we were talking about sending the real-time events to the agents, that's totally fine. But if you want to query, right, let's say you go to the agent and you say, OK, give me the list of anomalies in the past 5 minutes, or show me the context, or show me the status, right? So even when the live events are coming to your agents, still you can query that agent and you can find out what's happening in real time, right? So that capability is also integrated as part of the solution. So it's like a hybrid solution. It's just not request response, but it's also interactive as well. Now, I will also discuss about some of the extensions we have, and most of the things I think people who are from Kafka world might be aware, like subscribe, unsubscribe, and then there are functions for getting anomalies, getting context. Now, the third is a very important piece, which is bounded queues, where I say 500 events handle back pressure automatically. Now, let's say you have an agent, or you have multiple agents. Like, let's say you have a Kafka streaming bus, and there are 10 to 12 agents which are consuming from various topics, right? Now, imagine a situation that some agents are super fast, some agents are slow, right? So in order to make sure that all those agents are able to cope up with the pace, we have provided a bounded queue of about 500 events. So what will happen is, and up till the time it is within this range, the agents will be fine. But as soon as it goes beyond those 500 events range, right? Let's say you have a very slow agent, which is like 1,000 events, right? It's still having a queue of 1,000, or it goes beyond 500. So the system will drop that agent. And the reason why it will drop it, because it's going to disturb your entire real-time pipeline. So when you take this solution, let's say, to production or to any other environment, the suggested solution will always be, if you have a slow kind of an agent, it's better to take out that agent from your existing pipeline, retest it, fix it, and then join it back to the real-time streaming pipeline again, right? So for this, we have used the bounded queue as 500 events. You can still scale up, scale down based on your needs, but just for the matter of this demo, we have kept it as 500. Now, there could be other possibilities as well. You can also use a dead letter queue. You can have a dead letter queue where, let's say, if the events fail or something happens, those messages go to the dead letter queue topic, and then you can replay them, and if you want, you can reread them as well. That's totally fine as well. Now, here comes the authorization part. So what we're using here is CIDR authorization for MCP, and the reason why we use CIDR here is because the authorization using CIDR works at the connection level. I mean, so let's say an agent connects, right? So for every request, it will try to verify whether it's a valid request or not. It's not at an agent level, not at a user level, not at an account level. It's at very granular level. When I say granular level, what I mean is it's for every request you are sending it through. So let's say you have one agent which is trying to find out anomalies. So for every request it is sending, it is authorizing whether it's a valid request or not. So by default, it's always deny. It will not allow you to do anything. But if you write the policies that, OK, agent 1, get anomalies allowed. So it will get the anomalies. Agent 2, only read the messages. It will do that. Agent 3, only get context. I only want to see the context using agent 3. That's fine. So you will define your CIDR policy block in a way that every agent has certain kind of authorizations allowed, right? Now, maybe a question can be here that, OK, why not if I use other kind of authorization mechanisms like IAM or something else, right? So all those authorization mechanisms work at an upper level. When I say upper level, it's more at the infra level. But CIDR is working at a very granular level. So remember, as I said, it's for every request. So every request you're getting, it's verifying whether this request has the valid sort of permissions or not, right? And default, as I said, it's always deny. If you're not giving any kind of policy, any kind of permission, it's always a deny. So you will have to explicitly provide the permissions so that it can get authorized and it can do the required set of permissions here. Now, here are some examples on how to write CIDR policy over here. You define the permit block, you tell what kind of action it is, what kind of resources it will have, and then what kind of stream it is going to use, right? So we'll also see a GitHub code base, and we'll see how we have defined the policy over there. So I'll show you that as well. Now, the part of our live demo follows this kind of a pattern. We have a log simulator, which is going to produce the log messages. Then it streams via Kafka, and it then goes to the MCP server layer where we have the block which is going to make sure that there is a connection happening between your AI agents and your Kafka layer. And it is also ensuring that it is that main layer which is controlling every behavior. When I say it is that only layer which is controlling every behavior, what I mean is, let's say in future you decide that I want to use some other kind of a streaming platform. I want to use Confluent Kafka, or I want to use Kinesis, or I want to use something else, right? So you don't have to change major blocks in your entire architecture. All you have to change is just plug and play that Kinesis or Kafka piece, whereas your AI agent code still remains the same. Because that's how your MCP server is controlling the entire piece. It's decoupling both the blocks. It's not tightly coupled over here because of this. Now, let's discuss about the anomaly detection flow. Now, what happens when the logs are getting streamed and anomalies are getting detected? Now, how and what pattern they are following as part of this demo. So we have taken a window of about 100 events. So let's say you have 100 events, and between those 100 events, let's say there are 15 failures. So if there are 15 failures, as part of this demo, we are saying, OK, there shouldn't be any spike because the threshold we have defined is 30%. So if it is above and beyond 30, it will always trigger a spike. Now, the best point or the best consideration to note over here is when you're designing applications like this in terms of production, not every message is supportive enough to be defined a rule. So let's say you have a warning, right? Or let's say you have an info message, or there is an error which is of least significance to the organization. So it doesn't make any sense to define anomalies or define rules for those anomalies for each and every error, warning, or info message. So you have to be very selective when you're deciding, OK, how many events I should frame the rules for. And the AI agent we have defined over here, what it is doing is it has predefined set of 6 to 7 rules we have followed as part of this demo. You can enhance that particular logic to include as many rules as you want. You can also include LLM model over there, because using LLM model, it can be more smart and more analytical. It can decide, OK, if error 1 comes, what actions I have to do, or it can also give you root cause analysis kind of thing as well, right? So The reason why we have used 30% over here is just to benchmark it for 30%. It's not a hard code kind of a recommendation. It just depends upon your entire organization needs. Now, as I was discussing about the production patterns and gotchas, so this is something which you want to consider. If it's a back pressure, as I was mentioning about the slow agents. Now, there could be a scenario where you have fast agents which are consuming the data very fast, super fast. There could be agents which are damn slow, right? So you will have to be very particular that your real-time streaming pipeline is not breaking because of those slow agents. So it's always advisable that if you have those kind of slow agents, detach those agents from your existing pipeline, fix them, retest them, and then make them join back your original real-time streaming pipeline. Now, hybrid protocol is, again, very much suggested because it just goes beyond that request-response model. It's also being interactive for you. Now, Kafka consumer groups. In production scenarios, it's not always one topic, one consumer. It could be multiple consumers, multiple agents, multiple topics, one consumer or one agent subscribing to multiple topics, right? So in that, the consumer group plays a very much impact over here because you have to define how many consumers are part of one consumer group and then how many consumers will read from various topics. All those things come into play. And if you consider the ordering part as well, so as we know, the ordering is within a partition. It's not across the entire Kafka topic, right? So whatever ordering is happening, it's within the specified partition of that Kafka topic. Now, the other point is exponential backoff plus context snapshot. So you'll have to always be sure that whatever backoff mechanism you're following, like as we saw in the previous slide, like we had 500 kind of a pool events, and if it is, let's say, if it's going to buffer more than 500 events, then we are saying, okay, it's kind of a slow agent, and we kind of drop that agent as part of this code. But in your real production code, what you can do is you can take out that code, fix it, and then make it join the real-time streaming pipeline again. Now, be selective. This is what I was mentioning. I have seen users or I have seen customers fix or define rules for anomalies for every kind of info messages, every kind of error messages, every kind of warning messages. I understand all the messages are super critical, but when we are trying to design this kind of a solution where it detects or peaks at the anomaly, you have to be super sure what matters for your organization. Right? So let's say database connection is super critical. Let's say out of memory is super critical. Or it could be app getting, let's say, too many connections. So you'll have to decide, okay, which error message is super critical for me, what is not. So based on that, be selective, be smart, and then define the anomalies. Because at the end of the day, you don't want to be spammed as well, right? So if you are getting too many alerts, too many info messages, your system will start spamming you. Now, what is the streaming MCP unlocking here? So the very first thing it is unlocking is it is going to do a real-time incident detection and auto remediation for you, right? So initially I was explaining you about a use case example. If you have a trading application, financial application, or a healthcare application, that is where this solution is very handy because the agent is not waiting for the response after it is requesting. It is happening in real time. The events are coming in real time. It is giving you anomalies in real time. And then you can enhance this application to fix those anomalies in real time as well, right? So everything is happening in real time fashion, and that is where it is a major impact giver in terms of critical domains like healthcare or trading or finance or other verticals which are of business, which are like business mission critical, right? And then we also talked about security. So we saw that using CIDR, we are trying to make sure that authorization is tightly restrictive here. So we need to make sure that CIDR is in place so that granular authorization can be enabled here. If it is in terms of authentication, you are open to use either MTLS or whatever authentication mechanism you want to use. But we didn't go with ACS or anything because, again, ACS is at a layer top than CIDR. CIDR is kind of very granular, and we want to make sure that the agent should have the least allowed permissions. So that is why CIDR is a better fit here. Now, here are some of the key takeaways from this. So typically, as we know, it's a request response kind of a model, MCP, right? And we are extending this beyond that model. We are making it a hybrid approach and streaming the real-time context through that model. We have used Kafka Confluent version, right? So again, you're open to use any of those things. And that is the beauty of this design, because if you are changing any of the streaming versions or streaming products here, it's not going to break the entire pipeline. You just change that product, and then pretty much everything is in place, because your AI agents are not entirely dependent upon your Kafka libraries or anything, right? So with this, I will jump on the demo part, and I'll show you how it's working in the demo piece. So for the sake of time, what I've done is I have three, sorry, I will. Is everybody able to see the screen? OK, nice. OK, so I have three screens over here. The top one is like a logs, is like an MCP streaming window. The bottom one, if you see, is like a log simulator. It is producing logs. The above is the MCP streaming one, which has the WebSocket and everything. It's making sure that it provides that abstraction to connect or feed your real-time events to your agent, and also make it interactive. And at the bottom, if you see, we have the feed going on, right? So it's continuously telling you what all events it's receiving, and in middle, it will always populate the anomalies it is seeing, right? So over here, if you want, you can do interaction as well. Like you can type, OK, what is the status, right? And we'll see if it allows me to do that. Yeah, so if I check the status, it is going to give me a status saying that, OK, these were the number of events, these many anomalies were detected. It's super fast, because the speed is too fast here. It's happening in real time. But there are certain things you can check over here, like you can check the context, you can check the status, you can check anomalies. And you can even use the help command here to find out what all it is supporting over here. So again, if you want to extend and enhance the solution, you can integrate this with an LLM agent. And what you can do over here is you can make it more smart so that it rectifies your anomalies. It does a root cause analysis on top of this. And then, if you would like to, you can also fix those errors as and when you want, right? So it's a complete pipeline from identification to fixing. So that's all I had as part of the demo and the solution. I would wait for the questions you have. Yeah.
When I think of anomalies, I think of events that are fundamentally success, and therefore are defined and how to categorize. Have you encountered this situation?
Yeah. So. Again, as I said, it depends upon your use case. So I've seen customers where, let's say they have an e-commerce website, and they trigger an anomaly based on if a bot is trying to, let's say, place orders on their website, right? So let's say they access some of the products very fast, and they add 100 items to the cart, right? So technically, for a human, it's not possible, right, to do that like in few seconds. So that kind of activities are also getting recorded. So you'll have to be smart enough to categorize, OK, what qualifies as anomaly. Anything you want can qualify as anomaly. For part of this demo, we defined some 6 rules. OK, these 6 rules are anomalies, but you can be creative as you can.
I have a question. So if I correctly understanding, in terms of utilizing AI as kind of a proactive action, I guess before even putting any query, you probably have some predefined task stuff there, and then ask LLM to figure out something, right? Yep. If there are data too big, especially you're dealing with a lot of size of data as a log, then sometimes LLM kind of ran out of the context, and then like we got bogus analysis, right? So how did you actually resolve that kind of issue?
These things can be handled at 2 layers. One is your Kafka, what I told you, you have to have enough consumer groups or partitions so that the data is streaming properly. And then at the AI level, the LLM models you are using, you have to decide, okay, this particular model is accepting how many tokens, or like how smart the model is, what's the accuracy level. So if you're using a very smart model which can have, let's say, 10K tokens or whatnot, so you can pass a huge file to that as well, and then you can expect an output out of it. So it's dependent more on testing. So what I will suggest is start small and then go big. So start with like small level agents, you test that, and then once you find some good solution out of it, then maybe scale that solution to more kind of advanced models. Yep.
Maybe I missed this, but what is the stop conditions for the agent to stop something on the compute from that?
So I gave a buffer value. The buffer value as part of this demo was 500. So if let's say it's buffering the events and it reaches 500 events, it says, okay, I'm still buffering, but I'm not passing anything to the agent, or I'm not reading anything, right? It means there is some kind of a drop at the agent side, either it's a network or some kind of an issue, because it's not able to subscribe to those events, right? So that is the situation where we are dropping as part of this demo. But in production systems, I don't think it should be an issue, because as I recommended, it's always better to remove that agent from the pipeline, fix it, and then reconnect it to the same pipeline. Because the data loss will not be there. That's the beauty of Kafka. It's holding your offsets, and whenever your agent comes back in, you can specify from which offsets to start reading it. Cool. Well, thanks, everyone. Thanks for your time. I really appreciate you taking your time and joining this session. Thank you. Thanks a lot.
developer based in Toronto, Canada, and I'm here with the WestJet Airlines. If you flew WestJet to get here, there's a non-zero chance a service my team maintains told you which gate to go. So if you're late, that might be on me. Have you ever been curious how airlines actually manage their schedule? It's a little bit more complicated than a bus schedule. Like, we have an entire team that manages the schedule and the graph database more. Today, I'll walk you through how we manage our flight network and how we use MCP to open that data up to people who are not knowledgeable in the Cypher query language. For people who don't know, Cypher is the query language for the Neo4j graph database. Let me show you how. But first, let me give you a bit of a context. The airline industry has one of the highest failure rates of any sector. The US has literally hundreds of defunct airlines. In Canada, over 260 airlines have come and gone. And here's the kicker. Every single discount airline launched in Canada since 2000 has folded. Every single one. WestJet turns 30 this year. Started in 1996 with 3 used 737s, 225 employees, and 5 destinations in Western Canada. Today, we have roughly 200 aircrafts, over 15,000 employees, and over 100 destinations across 2,300s. Canada's second largest airline, 8th in North America by frequency. If airlines were startups, and honestly they kind of are, WestJet is the one that survived the Series Z. So that's who we are, and let me tell you what I actually do there. All right, Digital APIs team. I'm on a Digital APIs team who build, test, and run a fleet of microservices powering WestJet.com, our iOS and Android applications, as well as other various internal systems. Our services cover pricing, so if you saw a WestJet ad online on the internet, the price came from us. We also cover trip information, questions like where's my flight, or you'll receive a push notification from us on your mobile phone. But today, we'll cover a particular area in more detail, which is scheduling. These are 2 screenshots from our website. The one on the left you see, so whenever you land on WestJet.com, you'll be presented with the options to choose your origin, destination, and this is one of the use cases this service covers. Another one is whenever you go into detailed view about your flight, you can actually see the various amenities that are going to be presented on the flight. And some of the routes are actually not serviceable year-round, so you will see a little disclaimer that, hey, your route is not available at this time of the year. But here's something that most people don't really think about. When you go to WestJet.com and land on this little widget, we only show you valid city pairs. You can't even type a route that we don't serve. And most airlines in North America don't really bother about this. They'll let you search whatever destination you want to and be like, nah, sorry, nothing. Well, at WestJet, we validate upfront. And here's a fun stat for you. Only 35% of our theoretical network ends up being routable. The other 65% is eliminated by business rules. Let me show you how. Yeah, so why is airline scheduling so hard? One example is cabotage rules. You want to fly Las Vegas to New York with a stop in Toronto? Sounds fine, right? Nope. That's a domestic US route. We're a Canadian carrier. Can't do that. Entire category of OD pairs gone. Minimum connection time. Are you trying to connect through Toronto? We need to satisfy minimum connection time for a domestic flight, and it's even more time for international flight with customs. If the math doesn't work out, that connection doesn't get published. Nobody wants to sprint through the terminal on a short connection, right? Another pain point is the security. If you want to fly from Toronto to Dublin via Vancouver, we technically have both flights. But you would first fly across Canada just to turn around and fly across the Atlantic. We don't show this product because really, why would you do that? And all of this changes by day of the week and the season. Thousands of flights per day, hundreds of airports. It's a combinatorial explosion of it depends. Here comes the old way. How do we manage all of this? I think you already know. It's beautiful, horrifying spreadsheets. Schedule used to be updated only twice a year for summer and winter. It was a very laborious and very expensive process. The good news, we've come up with something better. Enter the schedule publication service. First, we use the SIM file, the industry standard format airlines use to exchange schedules. Our schedule team generates this for WestJet, and we also receive them from our partner airlines. If you've never seen a SIM file before, imagine a flat file format from the 70s, and it looks exactly like you would think a flat file format from the 70s looks. It's got character positioning parsing, it's got fixed width fields, it's beautiful in this it predicates me by decades kind of way. We also receive amenities data that we receive every day. MCT, minimum connection time, we receive that information from a vendor. We also apply various business rules, security, cabotage, seasonality, and other various business rules that get baked into the system. SPS crunches all of this and outputs clean, routable OD pairs, routes, and amenities data. That's what powers WestJet.com and all our other systems. And just to give you an idea what a SIM file looks like, yeah. All right, but what is actually our problem? We end up having a very rich system that is stored in Neo4j database, but in order to, besides exposing the information on the external system, it would be great if somebody could tap into this data, but in order to access it, they would need to know the domain language, which is Cypher. All of this data lives in the Neo4j graphs. Airport as nodes, flights as edges, properties for everything. Times, distances, equipment, connection rules. Incredibly powerful for network analysis. But to query it, you need a Cypher, the query language for Neo4j. And the people who would benefit most of it, the scheduling team, network planning optimization team, they might not know Cypher. There are people who decide which cities WestJet flies to. Which connection at Calgary aren't working is a business question, not a database question. The query language shouldn't be a barrier for it. So the mission was simple. Democratize access to WestJet flight network graph. Let anyone, regardless of their technical background, ask questions in plain English and get real answers backed by real data. No Cypher, no begging a developer to run a query for you. MCP made it all possible, not as a proof of concept, not as a hack day project. It's an actual tool that people use. This is a high-level architecture of the solution. So you have your cloud desktop as a client where a person would enter query. It would go through our custom MCP proxy that sits in front of a Neo4j MCP server that exposes the tool, and it passes it and makes a request to Neo4j database. And everything runs in Kubernetes. That's not surprising. And let me do a short demo. So I'm not taking my chances on this Wi-Fi, so I'll show you a history from my Claude instance. All right. So here, I typed in an answer, a question. How many direct destination WestJet serves from Victoria, BC? Oh, my bad. All right, there we go. Should we make it bigger? So here's my Claude desktop. I entered a question, how many direct destinations WestJet serves from Victoria, BC? And this is how the flow would go. It would interpret the question, refine it, pass it. And in order to optimize the flow a little bit, I entered in the context to show the work it's doing, and especially to show what kind of queries it was using against database. So it would load the tools. That's pretty straightforward. It would ask for the Neo4j schema, do the work, and this, I would say, the most interesting piece where it actually generates the query, the Cypher query. You could see starts with a match. Oop. Does the query, it gets the response from the database, and it puts together in an answer. You'll see that WestJet serves 8 direct nonstop destinations from Victoria, BC. And then the format, you could play with it. You can type in the context how you want the data preserved, shown into you. We played around with displaying this data on the map as well. Yep. And that concludes my presentation. Thanks so much. Yes.
Can you? Thank you. That was great. How does the schedule optimization team use it?
This is a very good question. When you create a schedule, you want to make sure whenever a person makes a layover at an airport, you want to increase the number of possible connections could be happening in the cities. So that's one of the use cases that we found the schedule optimization team would be using this for. Yes.
I'm sorry if I missed this, but what does your proxy layer do that's like different from the Neo4j layer itself?
Yes, this is a very good question. I think the idea is to, right now, we had the luxury of placing this whole system internally, and we don't have to expose it to real actual customers. It's only being internally. So the idea is to implement the authentication layer in that proxy and potentially expose other tools, expose informational services that our team offers potentially using that MCP server. All right.
You're going to expose it externally?
This is a very good question. I think we don't have immediate plans to do that. As of right now, for now, it's just going to be used internally.
If you were to expose it externally, what would you add from a security standpoint?
I think we entertained that question, and I think we would need definitely a lot of filtering in terms of what kind of questions you can ask that ask this service, so we wouldn't get in the news of people asking certain questions. We definitely want to avoid a PR nightmare. Yeah. Yes.
Have you talked to Neo4j, the team here, about whether they've done anything similar general purpose? And if not, what they could learn?
Yeah, definitely came by their booth. They're one of the vendors, one of the sponsors of this event. And the question I asked them if, so with my project I use Claude, the state-of-the-art model that generates those queries, right? My question was if they're thinking about fine-tuning or optimizing LLMs for Cypher in particular, and the answer was no. They also recommended just using state-of-the-art models. But under the hood for Neo4j, they have a project called Text to Cypher. That's what LLMs use to generate those Cypher, the Cypher queries. Yes.
Did you have any challenges validating the data? So one of the interesting things is you're writing a query back to the graph database. The 8 routes that you listed, do you know that they're correct? Did you do any evaluations, or did you run into any data quality issues?
Right. Another good question about, and that's something I came to this conference is definitely wanted to pick up people's brain on how to eval, how to improve the quality of the data. So how we approached this project is we created this tool, spent as minimum resources as possible, and gave it to another team to try out. And then based on their actual use cases, we'll see if they find it useful, and if they don't, then we'll just move on to something else. Yeah. All right, thank you guys.
Where we see the most traffic is actually the MCP that are kind of doing well. So not necessarily the JGP store or the Nordstrom because it's very nowadays and people are using it very much and what's really
Actually, for Flight, because Flight is a transactional business, right? Yeah. It's on that level where you need to see pictures, it's very hard to make a decision. The Flight is a schedule, it's a price. You know.
How do you see a foundational model choosing which website to use for that? That's it. Yeah. So, and then why wouldn't the foundational model also, like if you see a lucrative business, why don't they just take that? Yeah.
They tried. We were trying and backed off from it. So I mean, you know, that you have to take
All right, welcome everybody. Thanks so much for coming. My name is Riley, and for the past maybe 2 months or so, I have been building a bunch of MCP apps. So this talk is about some of the lessons that I've learned and some patterns that have started emerging for me about how best to build these apps. I'm sure everyone more or less knows what an MCP app is. Most people saw the keynote from this morning. Just so we're on the same page, previously you were returning just text from your AI or from an MCP server. But now you actually have the ability to return a real UI. I'm going to be giving a bunch of demos, and everyone knows how good the Wi-Fi is here, so hopefully this actually works. We'll see. But yeah, so now you can actually legitimately return full UI components right in line in your AI, which is very cool. Oh, yep, did that. Okay, great. Only one thing left to do. So this is very, very cool, but when is it useful? I think these experiences are incredibly useful when you combine the power of AI, the power of MCP, and find a use case where a UI is actually significantly superior to something like text. So let's imagine that we're returning thousands of data points. You could return those just as a giant CSV. You could also return it as a graph. A graph would be much better. As they were talking about this morning, you also have the opportunity to have branded experiences. If you don't want to feel like AI is kind of erasing your brand, this is an opportunity to actually continue to have a branded experience. I would argue that if you're entering credit card information, much better to do that in a secure portal than to leak that into your context. And then anytime this is combined with MCP, I think a lot of times people think about MCP as giving the AI access to state that it might not otherwise have access to. But in addition to that, it's giving the AI access to mutate state and to actually be stateful in a way that an otherwise stateless model would not be. So when you combine these things, I think that's when you really find the sweet spot for MCP apps. I'll spend a bunch of this time talking about real-time and async concerns. I think as soon as you start to talk about a web application, real-time communication, asynchronous communication come to the forefront. So, and then of course the thing that you just saw, drag and drop. Imagine trying to drag and drop a to-do list with just the text prompt. No thanks. All right. So when I first started building these, one of the first things I thought was, okay, great. One of the first tools that I reach for when building a full-stack web app is WebSockets. I think there are very few applications that don't benefit from some sort of real-time communication from the server. So where is that in MCP apps? The lesson that I learned is there's no real-time with MCP. MCP is a fundamentally request-response protocol. What they have given us is something called the app bridge. So you create an app. The app bridge is the way that the app talks to the host, which talks to your MCP server. They have not extended that to give you any sort of real-time facility. So what do? Well, we can poll, but I don't think I really need to explain to anyone why we wouldn't want to poll if we had another facility. The other option is there is something within the spec called resource notifications. That is a way to actually push from the server to the client information that the resource has changed. I wouldn't say this is really a drop-in replacement for WebSockets, though. That's not really what it was built for. That's not how people are using it. So the lesson is leverage the iframe. When you're in an MCP app, you are in an iframe, and you can do all of the things that iframe will allow. So specifically for this real-time case, what you have is something called the Content Security Policies Connect Domains Allow list. You can absolutely have WebSockets in this allow list. You can absolutely have HTTP2. And when you do that, you get full bidirectional streaming. You get immediate information from the server when something has changed. This allows you to make really compelling real-time experiences with your web apps. I've talked to at least one maintainer who says that this may or may not be an off-label usage. If there are any maintainers in the audience, please, what I would say is either keep this around, or if you're not going to continue to let us use the Connect Domains Allow list, give us something in the app bridge that is similar to WebSockets. What the maintainer said specifically was, you can't rely on it unless it's in the spec, which I thought was very wise. Okay, cool. So another thing that I immediately think of when I'm thinking about websites is there's going to be some sort of asynchronous communication here, right? Like, that's how the entire web is run. And I think there are many MCP apps that would benefit from an async communication. But like, what does async actually mean in MCP? There is something called tasks, which is SEP 1686. But basically, you can think of it like you're making a tool call, and what you're getting back is a task ID. And then you can take that task ID and ask if the task is complete. So basically, what I'm thinking of when I think of async is like, the tool returns before the operation is actually completed. Like maybe I'm kicking off to some sort of like external workflow engine. So the real trick is how do I know that the task has completed? So I think what I would strongly urge everyone making these sorts of experiences, if you have this sort of async style communication, do not make the user refresh the browser to get the latest data, because there is no real way to refresh the browser when you're talking about MCP apps. You might have them ask, like, show me the X again. Please don't do that. That's not great. What you can do instead is let the UI be responsible for actually monitoring the completion of that task. You can either do this with polling, or in the case that I just showed you, you can do it with an outstanding WebSocket connection, and then let them know that that task is done within the UI. There also isn't really a concept of pinning UIs yet to the chat. So it's totally possible that the context or the conversation will have moved and the UI is no longer in view. If you want to tell people that something has completed, this is a little bit janky, but what you can do today is you can use something called send message, which once that task completes, you can actually send a message letting them know that that task has completed. So let's see what that actually looks like in real life. So let's say I've got a little protein folding workflow, and I want to start it for myoglobin. This is going to run much faster than it would actually in real life. Protein folding takes a long time. But something to know about this is if you use something like send message to communicate with the user, you can get very different experiences on the different clients that you're on. So great, we're chugging along here, we're folding some proteins. If I were running this in Goose, this would not be a preview of the message. It would actually just post the message to the chat as if I were the user. So this is a very powerful facility that you are given in apps, this send message facility. It's also potentially quite dangerous, and I'll talk a little bit more about that later. So yeah, just a little example of how you can get some real fun, real-time data in your apps. Okay, let's continue. So the other thing that I would say is that I think state is everywhere in these applications. A lot of people are thinking about writing stateless MCP servers. As soon as you start introducing apps into the mix, things become very stateful. So my advice is lean in from day one. You're going to want some sort of authoritative state server. And the reason for this is that you could keep state other places. There are at least 4 places where state might live in your MCP app. So there is what I would call kind of like the authoritative state server. This could be your Postgres. It could be Google or Google Calendar or GitHub or Reboot. The framework that I work for is a stateful backend. But this is not the only place that state can live. State can live inside your context. State can live in your iframe in something like React local state. And then state can also live in your messages, which is sort of like a combination of your context and your messages, but the context isn't immediately visible to the user, whereas the message state is. The facilities that you were given as a part of the app in an MCP app to mutate these different states are, in the case of mutating the context, you have something called update model context. And in the case that we just saw, you can send a message to the chat through send message, or window.postMessage is the same facility. So the lesson that I would say here is, as much as possible, invest in your authoritative state server. Keep data in your authoritative state server. The React state is not a great place to keep state. You don't have as much control over when those windows reload as you might think you have. And then if you're mutating context or send message, it is actually quite easily to get into interesting kind of split brain scenarios where your authoritative state and your user might have a different state than the model actually knows. And this is something that I ran into myself. I was creating a payments flow, and that payment flow, I was introducing an error into when we actually tried to make the payment, I would make that fail. So I had also naively written a rule that says, anytime I get an error, let's update the model context so that the model knows that we got an error. That seemed logical, but what actually happened is, so I introduced an error. We reach out to the authoritative state server. I get back an error. I let the model know that we get an error. And then in the meantime, my app actually retried to make that payment flow. And the app did so idempotently. So even if it had worked the first time and then also worked the second time, that would not have resulted in 2 payment flows. But because the model didn't actually know that something had succeeded or something was in flight about to succeed, that payment flow happened twice. And it was a completely separate flow that was, there's no real way to deduplicate that. So I think the lesson here is update model context, send message. These are incredibly powerful tools. It's very good that we have them. Be very careful when using them, because it's totally possible to get into a state where the model thinks that there's something happening that may have succeeded or may not have happened. And these can be difficult to debug because in the case of update model context, you don't actually know what the model will do until the next turn of the AI conversation. For instance, like the next time the user types a message. So these can be finicky, difficult to debug. Okay, so let's sort of put all of this together. Let's imagine kind of like a weird contrived example. Let's make sure my stuff is still running. Let's imagine like a kind of a silly contrived example where maybe I am a social media manager for something like National Geographic. And my job is to farm out to real people topics that they can research and write tweets about. So let's say I want to add something to my tweet work queue. Great, I can actually reach out and do that. And then now it's going to show me the progress, see how my agents are doing. These are real people, not agents. Okay, on this side, I can look at the tweet work queue. And for the Keen Observer, you'll notice that this is happening in Goose and ChatGPT at the same time. The last demo was in Claude, and the first demo was in VS Code. Okay, great. Let's say that this is the one that I want to work on. Cool. I can claim that. Okay, great. And now let's do some research. So, geez, what is the largest organism? Organism on Earth. So what I would really love here, maintainers, is a little button that says pin. Wouldn't that be cool? Okay, cool, Pando. So if I were actually a social media manager or a tweet writer, I probably wouldn't just copy paste this in. But I think, hopefully this is kind of getting your, idea juices flowing about the types of really rich, interactive, multiplayer, maybe even like game sorts of experiences that you can create now that we have shared state, we have real time, and we also have the ability for any client whether it be ChatGPT, Goose, Claude. Any client can use these all at the same time. OK, cool. Continuing on, so some other lessons. Descriptions and schemas are incredibly important. Here's an example of what the description looks like for that tweet workshop. So in Reboot, Reboot is a open source framework for building MCP apps and full stack apps more generally. And we lean in heavily on API schema. So it's very important for both humans and AIs that they know what the kind of the shape of your API is. And so we try to make that a first-class concern here. This is all actually Pydantic. But if you're making an MCP app, what you want to do is pay really careful attention to your descriptions. I would say pay as much attention to these as you would normal code. Especially for something like, let's see here. So for create post, it also says, after calling this, call show progress with the returned task ID to see real-time progress. So if you want any sort of like multi-turn, or your expectation is that after calling one tool, the model will be smart enough to then call a subsequent tool with the return value of that other tool in its arguments, you need to be very, very specific about that in your description. And even then, it sometimes might not get it right, depending on the model. But these are very, very important. So pay close attention to them. Yeah, the other lesson is we're very much in the user agent days of the web with these different clients. Who here is old enough to remember having to write like, if Mozilla or if, yeah. So we're still there today. And I think the most egregious area where we're still very much having to ask what sort of client we're talking to is when with regard to session. So session is a very well-defined concept within the MCP protocol. Every client implements it completely differently. So Claude, for instance, is great. It is more than happy to keep around a session ID for the length of your conversation. ChatGPT, on the other hand, wants to give you a new session ID every single tool call. Interesting. OK. I think my advice there is if you want to rely on session ID for any sort of stateful tying together of multiple tool calls into one sort of logical context, you'll need to test that on every client, make sure it works in every client, or rely on a framework that has done some of this for you. Another thing that I think you can do is maybe forego session altogether and instead lean in on auth. You probably want auth anyway as a security measure. So if you're going to have auth anyway, and you want to logically tie multiple tool calls together to one thing, that thing could just as easily be a user ID and would probably much better be a user ID than a session ID. Reboot makes this really easy. We expose, just like we expose super simple primitives for having MCP app UIs. We also have super simple primitives for user. It's just a thing called user. So this makes it all very easy. We also have anonymous auth in addition to real OAuth 2 flows. So you can think of anonymous auth also like a session for an anonymous user. So just a little bit more about Reboot. That's what all of this was used to. I used Reboot to make all of these examples. Additionally, all of these examples were vibe coded. So we expose a Claude skill. It's called I believe it's just called the Reboot skill. And you can use it to make applications. And when you do, you have something that's both quite easy for the human and the AI to understand, because these interfaces are very declarative. Some other cool things, so those real-time webhooks, these are all generated for you. You're not making any fetch calls, you're not standing up any webhook. This is a generated React hook, and the response is a very specific type. You know exactly what you're getting. Another thing that's cool is, so we talked a little bit about how these apps often become stateful. The way that state works in Reboot is you're not reaching out to a database, you're not reaching out to an ORM, you're simply setting a variable called this.state or self.state. And you might think, ooh, that looks like a local in-memory variable. But the way that it actually works is once this function returns, self.state is saved durably to disk. This makes your life very easy. So again, Reboot is all about clear schemas, clear API definitions, simple business logic that humans or AIs can implement, and types. Types are awesome. So we saw a little bit about how Reboot is reactive, how it's multiplayer. We've also talked a little bit about how it's durable. What we haven't talked about today at all is how Reboot is scalable. Reboot is incredibly scalable, but I don't have time today to go into that. So if you want to talk to me about Reboot scalability, talk to me after. You can check us out at reboot.dev, join our Discord. Thanks so much. I'm happy to take any questions. Yes?
I have a question about your multi-user example that you showed. In that example, the two users were interacting with two different UI elements. Could they work with the same UI element, right? Like imagine like reserving seats on an airplane.
Yeah, absolutely. So all of this is backed by shared state. And one of the things that I didn't talk about today is, so when you're making a Reboot API, you have to define what type of a method something is. So you can have a reader method, you can have a writer method. Readers execute concurrently, writers execute sequentially. What we also have is something called a transaction. And a transaction is atomic. It either all happens or none of it happens. And you can touch as many different data types in this transaction as you want. So in the case of booking a plane seat, if there's multiple things that you need to do that, and you want to make sure it happens all atomically, you can absolutely do that in Reboot with a transaction context. And the cool thing about it is it's a distributed transaction. It can involve as many nodes as it needs to complete. Other questions? Yes?
So if I have a Django app that's already working and I'm using, and I need to make MCP compatible, so make it available via chat, different chat agents. So would you recommend that I could do a Reboot implementation that just drafts the existing Django app, or
Yeah, so Reboot is a framework, and being a framework, it has a pretty specific syntax. I would say that it is not entirely compatible with Django. So yeah, if you want the features of Reboot, you kind of need to use the Reboot framework. It'd be nice if we could just wrap Django, but yeah, that's not possible. Yes?
I'm curious on the authorization side of things. So if you ask a question, widget gets rendered, you're not authorized, but you need auth. Like, what's that user experience like? Is there like a login button that shows up, or is there?
Yeah. So actually, all of these calls were authorized with our anonymous auth flow. And the way that works, it's a little different depending on the client that you're in. In something like ChatGPT, if you go through kind of an anonymous OAuth flow, you'll just see like a little spinner in the window for a second. If you're using something like Google or GitHub, you will get a link out to the kind of the login flow that you're used to seeing with OAuth 2, which is like, I'm granting you permission to see my email and to log in. And then it's a little different depending on what environment you're in. So I believe if you're using like Claude AI or ChatGPT, you can get a redirect URL back to the website. If you're using a desktop app, it's a good question. I think you might need to copy code that you then paste in, because I don't think a redirect URL works in that case.
Will the client then handle the cookie that gets passed, I guess?
Yes, yeah, at that point, the client has like a jot that they can use. Yeah. Anybody else? Yes, sir.
You mentioned the behavioral differences in the clients, like the message only being buffered in Claude. I'm curious if this is something that you do automated testing for, or is it something that gets noticed as people try it?
This is stuff that we have noticed, and it also changes fairly frequently, as, you know, especially as these things are fairly new. No, I think automated testing for these things is a hugely important part of making a production-ready, stable application, especially if you're going to try to ship it in multiple clients. Super important. Yes?
In some of your tool descriptions, you had things like, after you call this tool, call this other tool right after. What were the use cases where you found that you needed to put that in the description instead of making a more complex tool that triggered a workflow?
Yeah, so I think oh, and am I stepping on your time? I'm so sorry.
I started at 3:25.
Okay.
3 minutes from now.
Great, then this will be the last question. I think it's really important to think about the difference between display tools and data tools. So a data tool might just be a tool that you call to take some sort of action that updates state, and then your display tool is actually returning a UI. So in the example that I showed, it was like create a tweet. I want to be able to write that MCP server tool call without it causing a UI render sometimes. But other times, I might want to call it and then have it call another tool. Or I might want to be able to call the render tool completely separately. So in those cases, I think it does make sense to try to compose your tools. But in the description, if you want any sort of like, any of that, like call one tool, then call another tool, the description is where that needs to happen. Cool. Thanks, y'all.
Conference can be can wear on people, and people are like, oh, another talk. So I really appreciate all of you showing up. It's really, really nice of you. All right, awesome. So, and I promise this will be a little fun. I'll make you laugh, maybe. I don't know. It'll be your your call on that one. All right, I have 25 minutes to fit a 35-minute talk into, so let's go. Hello, everybody. My name is Jonathan Leitchu. I am a software engineer and software security researcher, currently packing a broken foot, wandering around here. I was the inaugural Dan Kaminsky Fellow at Human Security. I don't know how many of you know Dan Kaminsky. You can find me on Twitter at jleitchu. I don't use it really that much anymore. GitHub, my LinkedIn is probably where you can find me the most. So this is a security research talk. And you might have asked, why MCP servers? Why hack MCP servers? And the reason is, I had a boss. I'm getting a little bit of echo, so I'm going to bring this up a little bit higher here. Great, amazing. I had my boss tell me, hey, I bet you there are interesting vulnerabilities in AI systems. And as security researchers, we love chasing the new shiny thing, and so let's go hack some AI systems. So how did this research start? So I'm a security researcher. I'm a software engineer turned security researcher. I'm actually going back to my bio. I'm now a staff security engineer at Braze as of Monday. So I told them, hey, I'm flying in to speak at this conference, and they're like, hey, why don't you start your job on Monday and then be in New York? So great. So I got to double dip on New York. But yeah, so how did this research start? I have a particular fascination with locally running servers. Servers that are running locally on people's machines. And the reason that I'm fascinated with locally running servers is that locally running servers on people's developer machines tend to have access to a lot of data. A lot more access than you'd expect. And when you can attack a local server running on somebody's machine, you can get a lot of, it's kind of a party. So, okay, some context here. Let's talk about the same origin policy. So, the same origin policy is a policy that basically is attempting to block a web browser from being able to make requests from, if I'm on piratebay.com, piratebay.com should not be able to talk to mybank.com, right? Are people familiar with the same origin policy? Yes? Okay, great, amazing. And the same origin policy has a set of rules. It basically says that this website, a.com, normalwebsite.com should not be able to talk to some of these other domains based upon a set of constraints. And basically, it prevents Pirate Bay from attacking my bank. And this controls were added. So what can bypass the same origin policy? So we have two types of requests. Requests can fall into two categories: requests that are pre-flighted. So pre-flighted requests in browsers. So we're talking about browsers. Browsers attacking or connecting to other websites. Browsers have these things called pre-flighted requests, and pre-flighted requests were introduced with cores. And these are requests that are made that are post, put, or delete. Mostly post bodies with complex bodies. So if you're specifying a content type other than these content types, that's a complex request. And the browser will actually send a request with a head request and say, hey, am I allowed to make a cross-origin request? Right? So if I'm on site A.com, can this site A.com, can the JavaScript on A.com talk to B.com? And the browser will send a head request and say, hey, is this allowed? And the server is expected to respond with a header response that says, yes, this is allowed. And these are the types of requests that are pre-flighted. And then there are simple requests. And simple requests are considered safe. So these are requests that don't trigger pre-flight requests. So I can be JavaScript served from A.com, and I can make a request to B.com, and these will succeed. And so these are GET requests, head requests, options, traced, and post-based requests. So why posts? Posts are legacy reasons. This is why, I don't know how many of you work with, show of hands, how many of you are familiar with cross-site request forgery? Great, good, yes, okay, awesome, yes. This is why cross-site request forgery tokens need to exist, is because of legacy browsers trying to make sure that they don't break the internet. But what happens when a server exposes a vulnerable endpoint via GET or POST? It's like one ship attacking another, just like, flames, So, and this is even worse when that server is running locally on your machine. So let's cover some localhost and private network attack history. So the browser has and many developers don't know this, has a long history of being leveraged as an attack vector to attack local servers and private servers running on the private network. As it turns out, malicious websites can talk to localhost and private network servers. As long as you can get your request to fit into a simple request type, or you are able to leverage DNS rebinding, which we will talk more about, this works. And this is a 19-year-old vulnerability. Maybe. You might consider it a vulnerability. There's a bug tracker issue in Mozilla's bug tracker, 19 years old, saying, hey, why is it that my A.com can talk to localhost on my machine without like any prompting? And it's because browsers are old, clunky bits of technology, and if changing this stuff breaks things. And so people don't want to break things. I actually tried to get a CVE number for this particular bit of behavior, and MITRE came back and said, this behavior is acquired by the W3C standard, yada yada, many legitimate use cases, isn't a violation, yada yada. I disagree with their opinion, but like that's what MITRE's take is on why they won't assign a vulnerability, a CVE number, to this long-standing behavior. The problem is developers don't know about this behavior. And I have a lot of examples to prove it. So let's start. In 2008, there was a vulnerability, drive-by farming, where you could reconfigure a DNS server on a router. So I could get if I could get you to visit a malicious website in your browser, in your home network, all I needed to do is serve this little bit of HTML into your browser, and I could reconfigure your DNS server for your home router. That's it. There was some DNS rebinding Wi-Fi attacks in 2015. In 2016, Jordan Milne found that there was a web server running inside of the JetBrains IDE, and you could force that JetBrains IDE to load a project from an SMB drive because of that server. And if you loaded, this is before that, hey, do you trust this project pop-up dialog showed up? And so if you could get JetBrains IDE to load a project into your IDE, suddenly you had code execution on everybody's machines just by visiting a malicious website. That's the code that was required to get that to work. That's it. Trend Micro, Tavis Ormandy found that in 2016, Trend Micro had a password manager that was running a Node.js server. You could get code execution inside of that. Princeton found that a bunch of IoT devices could be hacked on a local home network via the browser using the same attack. PortSwigger in 2018 found that you could do internet port scanning via the same attack by diffing the timing between iframes load failures and JavaScript. So the JavaScript and iframe loading network stacks were different. You could time difference and figure out what ports were open on the machine. I am famous for finding a security vulnerability in Zoom in 2019 that let anybody hijack your webcam and join you to a video call without your permission. This article made international news, Forbes, Wired, TechCrunch, BBC, NPR, because Zoom didn't fix this in 90 days and I went public. And Zoom's handling of this was, it's a feature, not a bug. And then the court of public opinion said, it's a bug, we're going to fix it. I made $10,000 off that bug bounty also, too. Also, just shortly after that, AssetNote, 2 days later, disclosed that that same server that was running on the localhost machine had a remote code execution vulnerability in it. That server is no longer there, but it was installed as a daemon. There's a longer story. I gave a whole other talk about that years ago. Come talk to me if you want to hear more about that story. It's a lot of fun. In 2019, Bill Demke found that Dell's remote support assistant had a localhost server that had a remote code execution vulnerability in it. In 2020, eBay was found to be port scanning people's machines. In 2024, Avni Luminsky from the Oligo team found that browsers that were starting to put guards against this could be bypassed using 0.0.0.0, which is supposed to be an unroutable IP address, but it is routable in the browser. Most recently, in the past year, Yandex and Meta were both found to be using their Meta tracking pixel to be making requests from the browser to the Android Facebook app to de-anonymize users as you're walking across the internet. So they were running a localhost server inside of your Android app, and the Meta tracking pixel was making ping requests to it. And after this research came out, they stopped doing this. In 2025, ASUS also had a remote code execution vulnerability in it. Anthropic's MCP inspector had this remote code execution vulnerability in it. So all this to say, this mechanic of browsers is a long-standing problem, and again, most developers don't know. So that whole list, if you're curious, I have all of the articles attached to this in a GitHub issue that's right there. So if you want to look at that history and read through all the blog posts that I just referenced, have a look at that issue right there. So we've talked about we've talked a little bit about same origin policy, but let's talk about DNS share binding attacks. So you remember the same origin policy? DNS share binding allows you to bypass the same origin policy. So I can send complex requests now. I can use complex bodies. I can use complex behavior, networking behavior of JavaScript. So what is DNS rebinding? Well, DNS rebinding is an attack that works pretty uniformly against all browsers. You've got a private network with a user on it, and then you manage to phishing or malicious ad manage to get a user to connect to a malicious server that is serving subdomains via a malicious DNS server. And I thought, oh yeah, malicious DNS server, that's going to be really hard to set up. I've set one up. It's actually not that hard. I can run one. You just need to reconfigure your DNS for a little bit, and the browser will just use it. So you run a malicious DNS server. And it asks the server, what's the IP of attack.com? And the DNS server comes back with this IP address. And then this rebinding script, this JavaScript, makes this request to this remote server, but it's making these pings back and forth, waiting for the DNS record to time out. Or you can also use this thing called multiple answers, where you have the DNS server respond with multiple DNS responses. And the second one is 127.0.0.1. And then as soon as the content of the JavaScript's been loaded into the browser, you immediately set up an IP tables ban for the browser, and the browser will immediately fail over to localhost. And so suddenly, that same JavaScript that was served from this malicious server is now talking to your localhost server, or that private server, and then you're able to exfil the data back out to the attacker server. Any questions? Okay, great, awesome. So this is how DNS rebinding works. It bypasses the same origin policy. There's two strategies, as I said, first then second with cache flooding. This takes about 15 seconds to work. And then there's that multiple answers one that I said. That takes about 3 seconds in Chrome. It's very fast. So this is a fundamental vulnerability in browsers. Debatable, MITRE, yada, yada, yada. And again, developers incorrectly assume locally running means locally accessible. Weaponizing DNS rebinding. So I am not the original researcher that found DNS rebinding. This is a long-standing vulnerability. NCC Group actually developed this thing called Singularity of Origin. This is Singularity of Origin. It's the UI. You load it in the browser, and it starts making localhost requests. You can add different additional payloads. There's a bunch of payloads for a bunch of different vulnerabilities that have existed over the years. Docker's API was vulnerable. The Chrome Dev Tools API was vulnerable to this at one point. Yeah, so we're at an MCP conference. I have this slide in here because I'm talking to, but we're all here for an MCP conference. So Model Context Protocol, it connects to our stuff. Yay, awesome. There's three forms of communication channels with MCP. There's standard I/O, not vulnerable to this, because you're just talking locally to locally. There's HTTP with server-side events, which is deprecated. But some SDKs still support this. And then there's streamable HTTP, which is the standard way. And if you look at any of the modern specs, they all just talk about this. And then under the hood, MCP speaks as JSON RCP. So if you're looking at communication, what you're seeing is these JSON RCP calls going back and forth. You can use tools like, well, we'll get there, MCP Inspector. And the MCP Inspector, we're going a little far, sorry. The MCP Inspector gives you the ability to run tool calls against your MCP server really, really easily and demo, or try out your MCP server in a really easy way. By show of hands, who here has used the MCP Inspector? A lot of people. Amazing. Great. Okay. So who here's read the whole MCP specification? Less hands. Okay, all right. So there's a really good line in the MCP specification. Security warning. Implementers of streaming HTTP must validate the origin header in all incoming connection requests to prevent DNS rebinding attacks. If the origin header is present and invalid, the servers must respond with an HTTP 403 forbidden. That little line right there attached to this. Without these protections, attackers could use DNS rebinding to interact with local MCP servers from remote websites. That doesn't seem great, does it? So let's look at the most popular SDK for MCP, the TypeScript SDK. So this is how it tells you how to build and set up your TypeScript SDK, or how it did. They've changed it, but this is how they did tell you to set up your. And there's this really great line right here. Does anybody spot the issue? DNS rebinding is disabled by default for backwards compatibility. If you're running this server locally, make sure you set these flags. Care to guess how many servers actually set these flags? Not many. Enter MC pwned. Let's hack all the things. So let's start with MCP protocol server everything. This is a server that is a demo server that's supposed to test clients to give you full functionality demo. It's attempted, so the intent is not to be a useful server, but rather for a test server for building MCP clients, and it implements all the tools, yada, yada, yada. Let's pull up a demo. Oh, I've got to, oh, lordy. Okay, there we go. So that was my first place that I built a demo for this, just to try it out, see how it works. So I'm spinning up a server. I added an additional environment variable because there is a tool endpoint for pulling out all the environment variables. This demo is just using singularity of origin. This is before I understood multiple answers as an attack vector. Also, multiple answers was not the default. I think I've changed that. So it takes a good amount of time, but you'll notice after a little bit, this server that's this thing that's connected to my, I've managed to connect. I think we're getting there. Yeah, there we go. It pops, and I dump out all the environment variables by making the tool call. So the browser is now able to talk to that everything server via DNS rebinding. Google OSS Fuzz is an open source project that Google uses to fuzz open source projects. They had an MCP server inside of it. They actually, I looked at this MCP server, and it actually, funnily enough, had a remote code execution vulnerability in it via their tool, their MCP tool. So I could send arbitrary shell commands to it, and it would execute him. So I spun up that server locally, and when we hit go, it should pop calculator. Hey! So, and for this, Google awarded a experimental out of scope bounty. So nothing. I made nothing off that one. But this inspired me. Do you all remember MCP Inspector? This thing we were talking about a little bit earlier? What if we did MCP Inspector over DNS rebinding? So several cursor prompts later, and I had this flashy user interface that I had bolted on top of Singularity's source code. The source code for this, I just published 15 minutes ago. And you can get there's the QR code for the pull request right there, should you so desire to find it. This is a fully working demo of getting Singularity's NCC, the inspector, to attack MCP servers. I have 5 minutes. Great. So this worked against Google Cloud. I'm going to skip that one because this also worked against Google Cloud Run. This gave me the ability to upload arbitrary files into Google Cloud Run. This one let me expose full cluster data to query logs. Oh yeah, also, yeah, Google awarded me, sorry, I'm jumping around a little bit because I'm realizing I'm out of time. Google awarded me $200 for the first one, $200 for the second one, and then, yeah, this one's interesting. So there's some people from here from the Google Toolbox for databases. This one, if I pull up the video, running Google Toolbox. This is the database toolbox that lets you connect your MCP servers to any databases. I could make arbitrary tool calls to any of those exposed databases on the local developer machine. Funny thing is, they have a patch, but the patch is you have to opt into. And there's a warning in it that says, hey, this server is vulnerable to this thing. Make sure you fix this. That's not enabled by default. I've told the Google team this as of today, and so as of today, this is an O day in Google Toolbox. So if you're running Google Toolbox right now, this is a vulnerability that exists that you can be exploited by. Congratulations, sorry. I gave Google well over 90 days to fix this, and they did not. I've given all the vendors well over 90 days to fix this, and some of them have not. Yes. So this one exposed every tool call for exposed databases. The Apollo GraphQL server, that one lets you interact with any of the attached Apollo APIs. Docker's MCP gateway, they had a whole blog post about how the MCP gateway that they publish prevents these sorts of attacks. It did not. This got a CVE for it. As you imagine a security researcher reading a blog post and being like, ooh, that's a challenge. So I've gotten, Google's paid me $200 for 3 bugs. Docker paid me a t-shirt. AWS Labs had an MCP server. This one may let you make every single AWS call via this attack vector. So if I can get you connected to my malicious server, I can make any AWS local CLI call via this. They are not assigning CVE because it requires non-standard configuration changes. So how is this fixed? Anthropic has since added a tier system for API maturity. Anything tier 1 is supposed to be guarded against by the compliance specifications. Tier 2 and tier 3 SDKs are not guaranteed to be guarded against this particular attack vector. And Anthropic, at least for the TypeScript SDK, I got this CVE assigned. There have been a couple other CVEs assigned for this. And for this, Anthropic was kind enough to award me a $1,500 bounty. So thank you, Anthropic. I appreciate that. So my total award comes to $2,100 and a free t-shirt. So, hey. So how do you test for this? Spin up your MCP server, and you can run this curl command. The critical bit is that right there, that host header. If you're able to, with that host header not present, it should work. But if you attach that host header, that's what the browser is going to send if it's going to be coming from a browser. And the host header is not going to align with the URL. The host header is not going to, basically the host header shouldn't be present because a standard MCP server is not going to be, or client is not going to be setting the host header, but a browser will be. So demo. Yeah, I threw this together real quickly just to prove that this is earlier today. This is Google's toolbox. They have that warning in there that says, hey, this is vulnerable, or enable this flag. And I was able to run that command right there, and it still works. That's the latest version, too. I pulled it earlier today. So what about browsers? How am I doing on time? How am I doing on time? I'm good? 1 minute? Oh, great. OK. Private network access was introduced to try to fix this, but unfortunately, yeah, so hopefully that would have fixed it. Unfortunately, in March 2022, they rolled that back. Attempt number 2, there's been a move to add local network access. No local network access restricts the ability of websites to send requests to servers on a user's local network without a permission prompt. So what does that permission prompt look like? This. And here's the support matrix. Chrome prompts. Edge, because it's based on Chromium prompts. Firefox does not. Safari does not. I've tested this. DNS rebinding still works in those 2 browsers. One browser fixed this back in 2023. So this is still fixed. However, Brave is only 1.63% of the market. So yeah. And also, Chrome rolled back this private network access. That got rolled back. So we can't necessarily guarantee that this will remain fixed if browsers determine this breaks too much stuff. So key takeaways, this is still a vulnerability. I thought it was actually more fixed when I gave this talk at B-Side San Francisco. I thought it was more fixed than it actually is. Turns out it's less fixed. This TypeScript SDK is fixed. But make sure you're using the TypeScript SDK correctly. And just like check your SDKs to make sure that you're doing this correctly across the board. Browsers are not going to protect you against being attacked. Just because you're running a local server locally doesn't mean the browser can't be used as an attack vector to attack your server. This applies to all dev servers too. Like if your developers are running a local server on their machines to test things, this same attack can also work. Just a friendly heads up, depending upon what access that dev server has. So I want to give some special thanks. Socket, who paid me while I was doing this research for 3 months. Avi Leminsky from Oligo, who I was collaborated with. Gerald DeSalt from NCC Group, who I collaborated with. And here's where you find me. There's that pull request. There's my LinkedIn. And I am over time by 1 minute, so you can find me out there in the hall. I would love to talk to all of you, and I'm sorry I had to rush. This is a lot. I had 128 slides in 25 minutes. Cheers. I can take, does anybody have any quick questions for me while I'm standing up here, and I'll talk to you while I'm walking off stage?
Every time I load up my giant trusted folder.
You have your coffee in hand, right? Your calendar is clear for the next 2 hours, and you'll finally have time to ship that feature you have been working on all week. So it seems like it's going to be a good day, right? Then, all of a sudden, your phone starts buzzing, and you receive an incident alert. And your day starts looking a little bit more like this. You all know the meme, right? So what's happening is you have Slack messages flying in, you have PagerDuty notifications piling up, somebody's asking you for logs in one channel, metrics in another, and you're just there like quickly opening tabs, right? You're going from your Datadog, GitHub, PagerDuty, Slack, and so many tools, and that feature that you wanted to ship is clearly not happening today, right? But this is about something much bigger than just your ruined morning. This is about how much it costs you every time you're doing context switching. So you're not only switching tabs, but you're also switching your mental model. So every time you switch, you're losing your train of thought. You forget what you had just found. And that leads to an increase on the probabilities of you making a mistake, right? It decreases focus recovery. Like, it's hard to go back to what you were doing 30 minutes and 5 tools ago, right? And this overall and consequently leads to a decrease in productivity. So if we take all of this, we started thinking like, okay, how can we solve this? How can we make it so that the engineer can have all these contexts in one place? So instead of dragging developers out of their platform, why not bring everything to them? All the context to their IDE, the alerts, the logs, the timeline, even the response workflows that you run later. And well, that's exactly what we have built. I'm Rocio, product manager of the Forward Deploy Engineering team, and I'm here with Sebastian, who is a senior Forward Deploy engineer, and he's going to show you exactly how we did this.
Okay. Thank you. Okay. Hi, everyone. Yes, I'm Sebastian. I'm a Forward Deploy engineer, and basically my job is to bring customer requests into life, into the product, or into new AI initiatives. So what we have been talking about is that we just received a customer request, and this is a real story. One customer told us, hey, I don't want to leave the IDE. I want to do the whole triage, the whole UI that you have in the IDE. So it's quite a challenge, and it gave us like some headaches, but thanks to MCP apps, we could address that specific point. So as you know, the tool calls retrieve text only, maybe the JSON that is processed by the LLM or the agent, and you get prompt back up. This is what I found, this is what you could do, and all the stuff. But when you want to collaborate and when you need to start triaging an incident, it starts to getting difficult. So right now, what we build is something that is more familiar with the PagerDuty UI, and also we can integrate the SRE agent in that specific MCP app. And the question is, what is this, the new SRE agent? Well, PagerDuty has a new subproduct that is called PagerDuty Advanced. Under that specific subproduct, we have 4 agents. The scribe agent that helps you to transcribe the meetings or the conference breaches into the incident context. The chief agents that is going to help you to organize your schedules and your overrides with your teams. Also, we have the insights agents where you can retrieve metrics. And the last one is the SRE agent that is going to pull information from some log vendors like Elasticsearch, CloudWatch, and other specific integrations that we have, and also some runbooks, like from Confluence and other runbooks that you have. We also have for ServiceNow. And any interaction will be any interaction that is performed in this MCP app will be in the audit trail. So you won't have this like, hey, somebody did this in the MCP app, but it's not recorded in the incident, or something like that. So we will have accountable responders across the incident. Well, the architecture of this is very straightforward. I know that you've been hearing about this a lot. We have an MCP server where you have the data and tools and all the stuff. But there are some discovery procedure where the tools are received, and when you initialize the MCP server, then you're going to retrieve that some of those tools are able to be called as MCP apps. So the program or the IDE in this case will know, I have 5 new MCP apps that I can use. So when you start the prompt or where you prompt the agent, they will say, do you want to call this a specific tool? Oh, yes. So what are we achieving with this is we're going to reduce the cognitive load from the responder. Well, responders, when you receive an incident, the first thing that you want to do is what happened, right? You're going to see the logs. You want to see, this is a different incident. I covering a colleague. So maybe I should check the triage process. And I go to see the runbook. And all those type of information is what are we reducing right now. The second part is the safety first, that any action that we are going to perform is going to be recorded in the incident context. And we always want to keep the human in the loop because we're going to automate so many things, thanks to MCP, thanks to the whole AI ecosystem, but we want the responder to be accountable and also to be responsible for yes, I click acknowledge, yes, I click resolve this incident, yes, we're going to initiate the post-incident review. All those type of actions are important that are performed by the responder. So what are we going to show you right now is that we are going to do all these actions in VS Code directly for this specific demo. And we're also going to keep the human in the loop, and we're going to see the SRE agent in action. So those are the 3 things that we're going to cover. So let's picture this. I'm a developer. Well, I'm kind of a developer. I'm still building stuff. Sometimes I merge some PRs. So we need to ship this feature like tomorrow. We have a release in the next week or something like that. And I get paid just as Rocio mentioned. This will be my daily task. Like I have to check this specific code, and I get my page and all the stuff, and I go to PagerDuty, right? This is the incident. Let's check it out. This is the service. I also have the conference bridge that I have to join. We have the ticket created, but the first initial step, it will be, let's add a note that I'm checking this. So let's investigate the issue. I'm investigating the issue. And well, the second part will be, this is an API timeout error. And as you can see, this is a similar incident for the past 30 days. So I will check the alert, and we will start the whole triage process, right? But what are we solving here is to avoid to go to the monitoring tool and what that I just said. So let's go back to VS Code. And this is the repository that's been affected by this incident, right? So we're going to open VS Code and VS Code chat where we have these 2 MCP servers. The PagerDuty MCP server, and we also have the PagerDuty Advanced MCP server, where we can call these 4 agents. So what we're going to do right now is, can you please list my incidents? That particular call is going to be directly to the PagerDuty MCP server, and it's going to retrieve the information, but just as text. That is the current status. But what we built is, hey, can you please show me the incident command center? That is this new MCP app. And as you can see, we have the state that is acknowledged, the high urgency, and the priority. In this specific view, we can set and retrieve some information like the alerts, the payload, and also the timeline. And now we have 2 buttons that are available. The triage locally, that will be ask the agent right here, can you use the PagerDuty current tools to triage this? But there is the second one that is going to call the SRE agent, the PagerDuty SRE agent. So it's going to use that specific prompt, and then it's going to send it to our PagerDuty SRE agent. It's going to retrieve the logs, retrieve the runbook. It's going to use the incident context and prompt us back with the with the incident triage and the suggested next steps and what is the summary for that. So as you can see, we have a summary, we have the severity and impact, and we also have some diagnostics, and we also can retrieve some information regarding to this. So in the bottom, we will see that there are some actions that we could perform. Yeah, the severity of this incident was a P1. We have some impacted services. But this is the part where we are going to rely on the agent. So, OK, we did the triage. We retrieved this information. Now let's use the agent to, hey, can you help me to resolve this issue based in these suggested steps by the SRE agent? So we started like, we're going to triage in the incident command center. Then we're going to analyze the whole incident and all this recommendation by the SRE agent, and we're going to apply the fix. In a common scenario, what we will do, it will be we have to test it locally, then we're going to deploy into load test, staging, maybe production. All that process could take several hours, several steps, maybe some regression test, and it's different for every case, right? But we're going to stick to this specific one. We just deploy the fix, everybody's happy, and the fix worked because everything works at the first time. And now we're going to, there is already push, yeah, it pushed the fix. And now we're going to go back to the incident command center, right? Because we want to resolve the incident. We want to let our stakeholders know that this incident was resolved. So we're going to add a note, hey, this incident was resolved, the timeout of this specific file was restored to 60 seconds. And after that note, we're going to resolve it. And we are going to see that no active incidents we don't have any active incidents, so we can go back to sleep and have a wonderful weekend, right? But we have another things. This specific one was only for VS Code applications and for developers that lives in VS Code all the time. So we also have, MCP Apps also announced that Cloud Desktop is supporting MCP Apps. So you will see that you can also call the incident command center from Cloud Desktop. This is the latest version of the incident command center deployed like 20 minutes ago. So we have some details there. We have some new filters. And this is practically the same, but we're going to add, in the triage, you will see something a little different. That is can you please triage this incident and search the logs. In this specific scenario, we will see that for this incident, and the SRE agent, what it does is it retrieves the context from the incident, it compares the inputs of this integration, it says, I have all the information that I need to pull this data from in this case, from Elasticsearch. There are new scenarios that are also helpful for an incident context, like the service dependencies. When you have a service like, I don't know, front end is impacting another service, you will see some dependencies. In PagerDuty, we have a concept that is called the service graph, where you will see some dependencies. And we also built this one so you can check it out during an incident. This specific is going to have 4 services, 2 services and 2 business services. So your stakeholders will see what are the impacted services for a specific incident. So with all this information, those are the 4 services that were impacted. So with all this information, we can triage the incident. We can say, oh, we have these services impacted. We also have this triage from the SRE agent and so on. Just like a sneak peek, we also built an on-call compensation report that it helps us to understand how many hours our responders are taking into the triage process. Like if we have one responder that is on call 24/7 for the last 6 months, we will see that. But because some customers also have different business hours. And okay, we have schedules for that, but there are also some customers that, but I start working like 1 p.m. to, 10 p.m. And for them, those specific are working hours, and the other ones are outside business hours. And they also ask for this one that is called, can we add some holidays? Because there are different countries, they have different holidays, they will want to understand how many times the responder have been on call in those specific days. So this is also available to use directly from Cloud Desktop. And just one point that I want to add, that all these MCP apps that you are seeing right now are in an experimental branch under the PagerDuty MCP server. So yeah, that's mainly it, how we are addressing right now the incident triage, the incident process, thanks to MCP apps. Yep, that's pretty much it. Go back to Rocio.
Can you give me back the clicker? Okay. So if we recap what we just saw, when we have human-driven operations, even if the AI is assisting us, we still have to do that manual context switch, tool switch that I was mentioning before. It'll give us tags, and we still need to kind of put the dots together among the different tools. Now, with MCP apps, just like Sebastian showed, we're solving that, and we have a rich UI in the IDE that's putting everything together in one place for us. But where it gets interesting and where we see things headed is having multi-agent workflows. So let's say my SRE agent finds a security issue, and it starts coordinating with my security agent. Or maybe it correlates the incident to a deployment, and it calls my deploy agent, to put a name on it. And this is agents talking to agents, and the human is just supervising. No micromanagement here. We're just supervising and making the critical decisions. Now, okay. If we tie this together and go back to the problem that we're solving and how this adds value, we first have a decrease in burnout. So the MCP here is solving that issue because at 2 a.m. your engineer won't be jumping among different tools. So that context switching burnout is being solved. Second of all, faster resolution. Of course, AI can do in seconds what the human can do in minutes or hours. And finally, you stay in your focus. You don't lose your flow, like we mentioned before. If we go back to the example of the Monday morning, you can solve the incident, and you can also ship your feature, right? Because you never actually completely come out of that flow. And what we want you to understand here, and what we want to say is that incidents will always happen, will keep happening. Production will surprise us. Monday mornings won't be great. But what we're trying to do is help react differently to it and changing how this actually feels, right? So we want the AI to handle the chaos, the toil, and then have the human just make the critical decisions. And that's basically what our MCP enables and what we're trying to show here. As Eva mentioned, we also have these experimental MCP apps, more to come. And finally, we want to invite you.
Yeah.
So I want to invite you to visit our, if you scan this QR code, you go to all our MCP documentation. We also have a remote MCP if you want to check it out. They'll add new information next week, right, regarding the MCP apps. And I also wanted to invite you. We have an MCP community, right? This is mainly we want you to be part of the MCP and contribute. It's not just our ideas, it's also your ideas. And we host monthly live streams. This is via Twitch and YouTube, so if you want to subscribe, you'll find us there. And also, if anyone wants to join one, I'm happy to invite any of you to join us 1 month.
So thank you. If you have any questions, thank you. So do you have any questions so far? We have time for that. If you don't want to ask here, we could have a coffee after or something like that. Oh, go ahead.
I like the multi-agent slide in the feature that you referenced. Yeah. So when an SRE agent is coordinating with, let's say, a deployment agent, how does the deployment agent know that, he's able to say, hey, fix this thing or make this change?
Yeah, that's a good one. Currently, we are working in the whole ecosystem behind like agent to agent.
Yeah.
So it's a challenge. I think currently I'm a forward deploying engineer, so the product team is taking that side and the AI team is taking that side. But I know that it will be released in the future, like in the incoming days. What I could say is that the SRE agent is working with different integrations right now. Right now, I spoke about a lot about logs, right? But it could be in the future for other type of integrations. So not only retrieving information, maybe perform some actions. Yep.
Yeah, we're enhancing it so that it can, connect to multiple different tools and your tool sets, different tool sets. And this agent-to-agent functionality is something that was, also publicly announced as a future release for this year. So in development, in the works, and if we have another conference, that's the thing we might show.
Yeah, the second man in the right.
So MCP apps is still fairly new part of the spec, and I'm curious, if there's anything that you would change about it, or things that you would want to make it so it's easier for running apps.
Yeah, I wouldn't say like in the app itself, our biggest headache was more like into the view, because like VS Code allows you to resize, maybe change the size of the window, but Cloud Desktop or Cloud uses like a fixed one, so I developed something and then the button was like moving everywhere and that crashed the whole development. But I would say that if they, in the future, like have a Canvas standard for this specific developments, but I think that for the first view, like what you saw, there are different models, different views, and that was so easy to interact with. So for the moment, I would say, yeah, the design part was kind of trickier. Obviously, with all the other parts that they are working on, like the extension for authentication and all the stuff that they discussed today here, but yeah, I always stick in this one. Yeah. Anything else? Okay, thank you guys. If you want to grab some coffee, let us know, and we could connect later if you want. Have a good day and nice weekend.
Enjoy the party if you're going afterwards.
Welcome back.
I'll try to stay here and not move.
I get your Slack now so nobody sees it.
Okay.
She got a little bit of time.
Yeah. 4:50, right?
Yeah.
Until 5:15 to give 5 minutes to the next person.
Pretty much, yeah. It's been like 20-minute presentations, leave 5 for Q&A, or if you don't want to leave time for Q&A, do the full 25, or something between that. Do you want to go full screen with this?
No, doesn't do full screen.
Okay, just gonna be
something like
bouncing.
that.
All right, no problem.
Can I do it? Let me see if I can do it full screen. Because I'll be moving
Yeah,
around.
you're gonna be moving around, right?
Yeah.
So you might as well leave it like that then. Just, it'll
Let
be
me
easy
see.
for you.
Then I can exit.
Kind
This one doesn't do it.
It's, yeah, it's all good.
Let me move my. Yeah, that sounds good. One of the last talks, or second to last. I submitted these talks and included a Kubernetes topic, so it was a long shot, and I was super surprised that it got accepted in the MCP Summit. So the idea is to talk about Kubernetes, the intersection between Kubernetes, agents, MCP, and all the assets around like skills. My name is Carlos Santana. I don't play the guitar. That's usually what I said in my talks. I play my computer keyboard with kubectl. I'm a senior specialist solutions architect for AWS, concentrating on Kubernetes and specifically working with customers and the service team in EKS on platform engineering topics around building platforms for workloads on top of Kubernetes or using Kubernetes to build platforms in terms of like building any type of workload. And that's what we're going to be talking today. Just to raise your hand if your organization is using Kubernetes. So I have a a few folks. And everyone knows what Kubernetes is. Raise your hand if you have heard about it. Okay. So this talk is about not about like using Kubernetes to run agentic workloads, but it's more of Kubernetes being used as a platform engineering control plane, where you have a management system where you can have types, you have a database, you have controllers, and you can model also like security around it. So this talk is around using CRDs to create a unified registry if you are in that system of using Kubernetes for defining your cloud infrastructure or on-premise infrastructure, and defining this type of new apps now that we're calling agents. And looking into the ecosystem on what are the initial projects that are doing something like this. So the reason end users or customers, in my case for AWS, they want to run want to use Kubernetes when they want to run agents is because they already have the skills. It's something that they use in production that already went through the phases of getting approved through security. They have people with, I mentioned, like the skills. Those are the ecosystem that they're like already working workloads. So an agentic app becomes another workload. But into respect, we can use it as a control plane. And the idea is to abstract infrastructure. It doesn't matter if it's running on the cluster or if it's running on the cloud, or maybe it's not running. It's just a storage, for example, a database. You can abstract that with CRDs. And CRDs are Kubernetes specification documents. They're based on OpenAPI v3 spec, where you define the schema of these objects that then you can apply through an API server, and then they're saved into a database called etcd. With that, the ecosystem of the API server is used by many organizations and many projects that take advantage of the RBAC access, like who have access to those objects, either to read, write, get information list, also admission policies and mutations. And today in the keynote, there was a talk about interceptors. So Kubernetes has interceptors where, like, when one of these API calls are coming in, you can intercept it and either validate that something is not allowed, or because it's maybe missing, not meeting a certain policy, or you can enforce something with a mutation. And so far, Kubernetes is, I think, 11 years old. I've been working with it 8 years. So it's very mature in terms of like lessons learned in certain organizations on deploying these objects or resources into Kubernetes. And the most common one is a deployment or a pod that has a container that basically is the code. But there's other objects like network policies, config maps, secrets that are used to make the workload work on Kubernetes. Like I mentioned, like agents is another workload. So these are the 3 projects that I'll be showing today. One of them is Agent, got created by Solo. They have a booth and they're a partner of AWS, and it's got donated to CNCF project. It has a couple of CRDs. It has a CRD that represents an agent that you can declarative put the system prompt, but also has the bring your own agent. It has something to represent a model. So an agent would need a model so you can like start seeing the composition aspect of like with these objects, being able to compose or what type of agent do you want to build. It has remote MCP servers where it's a representation of an MCP server that lives somewhere else, or it has an MCP server that actually would run a container for you and expose the MCP server through a streamable HTTP. So those are the main objects for K-agent, and then the agent itself is exposed as A2A, and that's a standard protocol to access agents. And it comes with some ecosystem tooling like a CLI and the web UI. I like the web UI. I'll be showing the web UI today. Skills, they are modeling, interesting, they're modeling as a container image. And again, the project is in sandbox. It's in relative early stage. So if you're interested to contribute or help with the architecture, that's some area to look into it. Another project is, and those, again, these are projects that are using CRDs to model either agents or agent components. The other one is Kate's Agent Sandbox. Is a Kubernetes SIG that is basically to secure agents in the context of like not allowing to exit exit to the host kernel. So there's projects like gvisor that it has a smaller subset of kernel APIs. And also there's Kata containers, and Kata containers supports multiple modes of like micro VMs, for example, Firecracker or Cloud Hypervisor. And the idea is to have, again, CRDs that you can install in Kubernetes cluster, and then you can instantiate one of those objects, either a sandbox claim. They also have CRDs that represent a warm pool. So that way, there's the startup time or putting an image, you can make an agent available from a pool. But the idea is to run it in a sandbox for those agents that today they're coming out like with continuous loop of like either writing code on the fly. So this is like to protect the environment where they run, and also to enforce network policies into it. The last one is an experimental project from a friend of mine, Alex Jones. He's the creator of CaseGPT, which is a project that was created like 2 years ago, or like an agent for Kubernetes to do troubleshoot or explanation what's wrong with the cluster. He created this one on multiple components of CRD. So he has a lot of CRDs, and basically it's to run OpenClaw as jobs. So it has a run agent CRD that is a one-time job that is ephemeral. It gets sidecards as MCP servers. It has an MCP server CRD. Also has things like a skill pack. If you want to give the agent a set of skills, it has a skill pack CRD. Also has a personal pack. So if you want to create a team of agents that run on their own loop. So for example, I would show an example of like a platform team that is like somebody doing security, another one investigating issues or observability. You can create a team like that. Or it could be developers, a development team that you have like people reviewing code, another person writing code, another person with the system prompt. So they created a personal pack. And also has policy through webhooks. I mentioned like the validation, mutation webhooks. It has webhooks in terms of like what is allowed or not allowed. And it has the channel, kind of like the same thing of OpenClaw, like Telegram, Slack, those type of things. So you can like send a message to the agent as it's running. And also persistent memory. Persistent memory is like these agents are ephemeral. So when they wake up on a schedule, like maybe once a day, or with a cron job syntax or interval, it needs that memory, like where did I left the work that I was doing or the initial work. And those also are like things that you install in the Kubernetes cluster. So if you have a large organization or a large amount of agents and components, now everything's saved in a database in a structured manner with the schema. So going a little bit down to YAML files, YAML is kind of the syntax that we use in Kubernetes. K-agent has a MCP server that this is basically you put this in a file as a YAML file and then run like a GitHub style to deploy from Git, or there's a CLI in Kubernetes called kubectl that you can say kubectl apply. And you can see here, it will take the standard IO package. There's a lot of MCP servers being packaged as standard IO, and it will like run in the agent gateway and expose it as a streamable API. And you can notice the Kagent doesn't have a status URL there. The other one is Symposium, and you can tell that it's almost identical. Maybe the Symposium was byte-coded, so maybe it knew about the other one, so it learned from the previous one. But this one has the URL MCP streamable HTTP URL, and the reason that this is important is we start composing these objects of like dependency of like the agent would need to have that access to that URL. Then the status should have it, right, and so on. And if the skill is available, it should have the location where the file is. And so you can start composing these things. So the schema is important, but since there's many projects and many organizations, when you put this all those CRDs in your Kubernetes cluster, then it's kind of like difficult to stitch them together. So I'm going to show some of the patterns on how you can like fix that or address that. So that's what I meant, that there's no consistency API across the MCP server registries, right? In this case, I'm talking on a registry in terms of like all these MCP server definitions sitting in the database of Kubernetes where you can query them. There's also registries that live outside Kubernetes, and that's okay. But today, I'm talking about for people that are deploying or trying to model their agentic platform with Kubernetes primitive. So there's no way to discover those type of things. So we have to, in your organization, you will need to put together these type of things. In this case, I show a very simple scenario where you install an MCP server, and the minimum information that you need for an MCP server is the URL. And in this case, we can see a problem of like discovering that URL. So the solution, one of the solutions is CRO. CRO stands for Kubernetes Resource Orchestrator. So this is a way of creating CRDs on the fly on the Kubernetes cluster without you having to write Go code. So typically when you create a operator or CRD, you have to write some Go controller that reconciles the desired state of the spec. So CRO is something that got invented in AWS and got donated to the CNCF, and Microsoft and Google are working with us and also SAP on the Kubernetes cloud provider SIG to on this project, and then we're soon to be V1. We also offer that as a product in EKS and as an EKS capability, but it will allow you to either compose a type on the fly, so you can like compose out of a number of resources and create your own Kubernetes CRD using cell expression, CEL expression, common expression language, which is very effective in terms of saving compute. So you can compose like a couple of things. So typical example is I compare this to Helm. Anyone familiar with Helm? Those are the raise your hand. So this is packaging things, but packaging things in a structured way that it will reconcile inside the cluster. So sometimes we need to deploy something first, get the status of it, and then deploy the next object. You cannot do that in Helm, but you can do this in CRO. But basically, it's like running inside the cluster. That Helm package is running, like a Helm package is running inside the cluster. The other thing that you can do is you can take existing CRDs and access the information and then create a wrapper or an adapter, an abstraction on top of it. So that's what we're going to be showing of like that MCP server that was missing the URL. What about if I create a new CRD without much effort and create a new MCP server, unified MCP server that it has the schema and the status that my organization is expecting when they build on top of this, they build on top of the MCP servers. So this is the syntax, how it looks like. It's called the RGD, Resource Graph Definition. So it's a DAG. So it knows in what are the dependencies between the resources. So in this case, you can see the definition on the left of an MCP server that I created with a deployment and a service. So when you deploy, you can deploy an MCP server in Kubernetes as a container. Usually you deploy a deployment and a service, but that becomes kind of the Helm way of doing it. In this way, you have a type where it says this is an MCP server, and then inside of it is the definition of the deployment and a service. And so if you give that to a developer or another organization, they don't have to know the details behind it. That's your contract. So when you go to the right side, this is how you instantiate the object. You have the MCP server, you give it the name, the image, the port, and that's the minimum information to deploy an MCP server to the Kubernetes cluster. So that becomes a little bit easier. And also you as a platform engineer, you have control of the things that people should not be changing on the deployment or the service, and then the status will give you back the URL, and also if it's ready or not, so you know if it's time to access it. So something that is prevalent in Kubernetes of the readiness, if it's true, because in Kubernetes is based on the promise theory that is eventual consistency. So you deploy things, and eventually the container will start, eventually the service will be available. So you have that status of Kubernetes native there. So this is, I will show an example, and I will not go to the YAML files and all that, but this is a composition of a curl with a simple cell expression where I am deploying a front end, which is a chat app, an agent, and then using a resource pool that it will have a couple of MCP servers, it will have a RDS database. So in this case, I'm using a project called ACK that with these YAML definitions, I can deploy to the cloud. So I can deploy a PG vector for RAG, and I can also configure the AIM workload identity, AIM identity for it. Everything from Kubernetes. I don't have to go to the console or click anything. Just for kubectl apply, I have a full agent with MCP servers, RAG, and workload identity deployed with a simple YAML file. So going back to the K agent to go deeper, the example that I have is I install the K agent Helm chart, and as you can see on the right, this is the MCP server K agent. So you can look at the line that says API version. It says K agent on the top. So this is an MCP server using the one that I think everybody uses for MCP testing is the server everything. And then if you want to deploy an agent, it just takes the bottom part, an agent that is declarative. You will put a system prompt, which is the model that you want to use. In this case, I was using Anthropic, and then the MCP server or MCP servers. You kubectl apply that, and then suddenly you have a A2A server that you can access. For Symposium, if you want to run OpenClaw, it runs as an ephemeral Kubernetes job behind the scenes. Also, it injects sidecars that becomes MCP servers. So when you have a pod, you can have multiple, you can have the main container and then sidecar containers that can communicate through network to them. So there's an MCP breach that then the agents, OpenClaw, can access the MCP servers or the tools, and also the policy of what are the things that are not allowed to be done by OpenClaw, so it's a little bit more secure. Symposium recently added Sandbox, so you can also run this in a Kata container with Firecracker or gvisor, and this is how it looks like, and just the same thing. So as you can see, a lot of projects and organizations will start doing this type of modeling if they're using Kubernetes, creating a definition of an MCP server and a definition of an agent. In this case, it's an instance in Symposium that you specify the MCP servers that are available to any OpenClaw instance. So if we look at if I want to unify that MCP server that was missing the URL, this is how I'm going to wrap that one. So if you deploy the K-Agent MCP server, it will create also a service behind the scenes. So the idea is that if you create a RAG, you can access, the syntax is external resource. So instead of creating the K-Agent MCP server, you are doing a reference. And also the MCP service, the service that is creating, so I can extract the URL and the port and then make it available. So in this case, my MCP server unified, like you can name it whatever you want in your organization, is the wrapper, is the wrapper to like any MCP server. So that protects your platform from changing in 3 months. If you're switching from Kagent to something else, or if Kagent makes modifications, make enhancements, you're not breaking the API that you're giving to the organization or your own compositions. So that's the way of like, if once you create a skill, an MCP server, a agent policy, a persona, or a skill pack, you can create these unified CRDs that then behind the scenes, you can start switching what technology I'm going to use, maybe in dev versus prod, or maybe on-premise versus the cloud, or as you make enhancements or take new projects, you can still offer the same API and not be tied into like, well, if we adopt this Kubernetes project, then we have to use their syntax. And then if we switch to another one, we have to use their syntax. So in this case, you have the choice of defining what will be the syntax of these CRDs, and then behind the scenes, you can switch them together. So these are like some of where the projects are today, and the links, the slides will be available. So let me, give me a minute to show some of the examples here. So here's an example of, let's show Kagent first. So this is a MCP server for Kagent, right? If you apply that, you will see the MCP server, and then if you apply a agent, you can see here the agent, and I'm saying that I'm going to use the default model config, that's on traffic, and then the system message. You are an agent that adds 2 numbers, and then you have the MCP server that it says, this is the everything MCP server, but only make the get zoom available to it. So this is a abstraction for the agent gateway project, which is part of the Linux Foundation. Once you deploy that, and you have Kagent running, let me see if I can start it here. This is a little UI. So I have a bunch of agents deployed already. So if I do K, I think this is very small for people to see. Make it bigger. So you do K get agents dot Kagent. I have a bunch of, they're in the namespace called Knative Kagent. So as you can see, you can have all the agents defined in a specific way that is Kubernetes. That is a standard in many organizations. You can also list the MCP servers. So now I have multiple MCP servers, so that was kind of the problem that we're trying to solve, right? I have the Kagent, I have the curl, I have the Symposium, so the Kagent will be available there. And if I want to use it, let me see if I can do it live and not have a video. This is like the home. So I have many of the agents, so this is a quick UI to test things. So you can say, this is a Kubernetes agent that has access, so you can say list the namespaces, right? And you send it, and then basically it's using one of the agents installed in the cluster. So you can see here, it's a declarative way of putting these things together. So the agent used the tool, as you can see here, Kubernetes get resources with the arguments, and I did that. The next demo is Symposium. So this is Symposium. Let me see if it's running. Has a nice UI. So there's already like, I have a persona pack or schedule or persona packs. Let me see if it will show. Working with the Wi-Fi. Yeah, so I have a developer team. So they're running on a schedule. So they're enabled. So they're running every few hours, and they're continuously running and doing things. Or you can have like just a one run of like, for example, getting this one is still running because it's on a schedule. So it will do a run on that. And the YAML files look like this. That one for Symposium, basically you have something like, this is an agent run, and this will run OpenClaw. So you can see here, like, it's a task, that OpenClaw, like, is running on whatever schedule that you have, every 30 minutes, every 15 minutes, every hour, once a day. And it's going to use Bedrock. I use Anthropic through AWS. Bedrock, which is an offering that we have. This is using Sonnet 4.6, and it's going to run. So if I apply that, it will run this will run once. So that's the idea, that you can also do it in a schedule. And the last one is the, let me see if I have time for that, is the, I'll play the movie because I'm running out of time. So it's the Crow agent. So basically this one is, the agent that I created from one single YAML file, but it deploys all the components. It deploys the front end, the back end, the 2 MCP servers, the RDS database, the workload identity, and this is the UI that is, I give it like some commands to execute and do that. Here I have Crow has a web UI that we're working on it. Let me see if I can find it. But the YAML looks like this. For Crow, this is basically how it looks like. I have an agent, Crow, have v2 because I was working on it. So you can specify that you want to create a agent. So I'm creating my own agent as a CRD without writing any Go controller or anything, and specify what is the model. So it's me deciding what is the APIs. Basic tier, because I'm going to share the RDS database to lower the cost. The MCP servers that I want to use, and also compute. So I'm not going to share compute. But if you want to see one of the unified RGDs, this is the unified RGD, how you're going to write it. And then this is the kind of like wrapping around the K-agent MCP server to make the status available here. So now I have an MCP server that has the status available. I think that's it. We go back to the slides. Follow me on LinkedIn. The slides will be available in the schedule, and you have access to the link. So let me know outside if you want to talk more. I'll be happy to learn what you're building with Kubernetes and agents. Thank you.
I'm head of the security research group at IBM, and I'm here with one of my colleagues, Monrajo. And we're here to talk about hooks, not hacks, modular enforcement for MCP agents. And when we come to think about it, one of the issues that we have is that agents effectively are a security risk. I like to actually tell everyone to treat your agent as an insider threat to your organization. And far too often as an industry, we tend to look at the user and the user's input in the prompt and treat the user as effectively the malicious agent. But far too often, we're actually being shown that the agent itself should actually be the thing that's considered to be untrusted. So a couple of examples here. We have Replit, which is a coding assistant, which was given some excessive privileges Everyone's probably heard the story where it deleted a production database and then went and started lying about why it had actually done that or if it had done this. But not only that, we have other instances where the agents themselves can be not prompted by the user to perform malicious actions, but could be indirectly prompted through anything it pulls into its context. And this could be through web searches, it could be through documents you provided, it could be through GitHub issues, or in this case here, it was through a calendar invite. So by simply sending an invite or sending an email in the EcoLeak case with Microsoft, you could actually prompt the agent to abuse its privileges, to leak data, to perform malicious actions, and so on. And so what we really need to do is treat the vulnerabilities that the agents actually represent and be able to control their excessive agency within the system. Now, the general problem or observation we had is that there's no single point of enforcement, and there's no easy way to actually do this. Guidance typically has been telling people that you should be adding different instructions to your prompts, you should be adding guidelines, you should be giving positive examples and negative examples. But constantly adding new instructions and expecting the model to always do what you want and expecting more powerful models to solve the problem is effectively aspirational security. It's not going to solve the problem. It's not doing enforcement. It has no way to enforce integrity or confidentiality. And it really just does not work in practice. So the other thing that we need is that we need some form of security and controls that are composable across the entire stack where we can do enforcement. One thing that we found when we talk to people within IBM who are building agents, when we talk to people outside, is that we cannot find two teams that are building agents effectively the same way, that are using the same stack. People can't agree on the libraries that they're actually using to build their agents. They might be using different models or different proxies to get access to the language models. They may be using different protocols and so on. And so it makes it really difficult to have a single consistent way to actually provide enforcement. And we originally tried doing that, providing a single secure library, but we found that since there was such diversity, we had to take a completely different approach. So we need to make sure that whatever we do is going to be enforceable all throughout the stack and actually hooks into the right places. The other thing that we found is that there's a rather large spectrum in terms of policies. When people tell us they want their agent to be compliant to some form of a business policy, they have an extremely difficult time defining what that actually means. Sometimes that can be something that's very stylistic, like I want the agent to always speak in professional language, I want it to ask nicely, it should always ask the user for permission, it should stay on topic. You might want an agent that only talks about HR instances or only talks about economics. You don't necessarily want a chatbot for a fast food restaurant to write Python code, these types of things. You might also have policies that state how many times the agent might actually retry something. These might be performing operations out of order. You might have different restrictions about the parameters you can actually send. But again, it's an entire spectrum. And so what we have is, depending upon the type of policy that you're trying to enforce, there's a different place within that stack where you actually need to be able to do that enforcement. So the stylistic ones that might be done at the prompt layer, anything that's going to call a tool, again, you could actually do that at the MCP layer where you can do these pre-tool hooks. And anything at the very bottom, you might actually have to do the enforcement, for example, at the infrastructure. So one of the things that we've done is we've created what we call CPAX. So this is hooks for enforcement to actually create the control plane. So this provides us the ability to do interception, to do access control decisioning, and then even potentially transform the payload to make it compliant and allow the actions. So what this allows us to do is add hooks, for example, in your LLM proxy. Those hooks can then call a plugin, which we have with a standard message format, which we'll describe. Those plugins can do any number of things. They could be guardrails, they could look for PII, they could be coded for different stylistic requirements. We can also inject the hooks directly into your agentic framework, for example. Make sure that it's the agent is on topic. We can do tool filtering, prevent different tools from being called. We can actually recover and repair if there is an error or the response is in the right format. And then anytime the agent is actually going to talk to another agent or a tool for something like MCP, we can put that in a gateway. And so there we can do any of the different access control, authentication, authorization, using those as standard protocols. And one of the really nice things that we'll be able to show is I might have a plugin that is doing a guardrail, for example, at the LLM layer. But the MCP server might be returning prompts. I might want to actually use the same prompt injection detection to make sure that the prompts that I'm getting back from my MCP server or the resources don't have any malicious data in them. So CPAX effectively is giving us these standardized interception hooks, which we can actually then add our different plugins. So we have a simple little example here that kind of illustrates that. So you can imagine you have an input. It's going to go through a couple different layers through your agentic stack. It'll make an LLM call, where we can have a hook that determines whether or not it's on topic. We'll look at adding guardrails, detect prompt injection, and so on. The response might come back with a tool bind. We're now going to make a tool call to MCP tool. Well, we can apply a policy, like an OPA policy there, to make sure that that is compliant, that this user is allowed to perform that action, and they have the right credentials. The response that's going to come back, we now can actually look at that. Is there any malicious content there? Is there sensitive data? Is there PII? You can then have plugins and tools for doing redaction. And one of the things this does is this allows us to completely separate the agent and the agent development with the actual policy enforcement. Because one of the things that we've absolutely observed when we do interactions and work with other teams is that many agent developers will actually try to put security policies and enforcement directly into their agents, which is very useful and very nice because at least they're understanding that there are security problems and violations, but they aren't experts in that field. Then they're going to inject bugs and they're going to inject vulnerabilities, and there could be things that we can exploit. The other problem is it doesn't make them portable. And so if you have an agent where you've actually hard-coded the policy directly into your framework, like LangGraph, now what do I do if I have to then translate that and move it to a different organization, a different company? Can I run the same agent in New York and Texas and California and Europe? And you probably can't. And so by abstracting away the creation of the agent, where we have the hooks, to the actual implementations of the plugins, we can actually now allow us to create new hooks, or sorry, new plugins with new policies and update it. So using the same hooks that we had, we can now add identity claims. We could validate a JWT token and use that. We could update the OPA policy, maybe make it one that is GDPR compliant, and so on. So these hooks and plugins allow us to talk about the mechanism effectively over the implementation. So we have predefined plugin hooks for the entire MCP protocol, pre and post hooks, for example, for things like tools, resources, prompts. We have HTTP hooks and identity, so any authorization headers we can actually get and process over those. And these are independent then of the plugin implementations. So we'll have different plugins for doing things like identity, for doing prompt injection, for doing access control, for doing things like rate limiting, adding a human in the loop, that can all be added completely separate without having to redeploy your agent necessarily. So I think one of the things I want to do is show.
Yeah, we can quickly show a little bit.
We're going to show, I think, the tool definition.
Yeah.
You have it here.
Yeah. So if we go here to, yep, you want to take it over?
All right. So just as a quick example, so this is our repository where we have the definitions of the hooks. I'm simply going to show off the one for tools, where we have our predefined payloads for both pre and post hooks for any time you make an MCP tool call, which defines all the different parameters you'll actually have. We have defined what the payload looks like, and we'll go into a lot more detail there about how you can actually extend it. But what this does is it gives us different classes for MCP or messages, for example, for language model, for doing things like chat completions or response API, that you can then reuse and code your plugin implementations against those. So that, I'll hand it over to Fred.
All right, thanks, Ian. So essentially, effectively, what those payload types are, they are the contracts that you can use to define your plugins or your decision points over in your MCP flows and other agentic flows that you might have. So we define a number of them as a library. By the way, CPAX itself is installable Python package that you can use to define your hook system. So it's a lightweight library that enables you to define this control plane, the hooks, and you do that once, and then you're able to then also define with the APIs that we provide, the plugins, it's decision modules that you can register to those hooks, and then drive decisions like blocking or transforming data or logging and doing other things, right? So it's a security-oriented kind of a library that allows you to build those extensible middleware, frameworks, whatever you are creating, essentially. So in a nutshell, CPAX plugins, as I mentioned, enables the separation between enforcement, remediation points, and the decision about discontinuation, transformation, and so on. The anatomy of a plugin starts by, for example, subclassing our plugin class. Those plugins can be configured completely via YAML, which is a nice thing. So CPAX provides a dependency injection pattern. So once you instantiate CPAX in your, for example, gateway or agentic framework or application even, you instantiate the manager reads the configuration and basically instantiate those plugins for you. But this is how you define them programmatically. So a plugin, subclasses plugin, so this is a rate limiter plugin. Each plugin can have one or more hook functions. Those are the things that are going to be attached to those hook points in your execution flow, and they're going to be registered there. And what the call site or the hook site is going to do is going to prepare for each of the plugins the payload type, the context type that is passed along. The context is a way to share state across hook functions. And then inside your hook function, you have some logic, right? Decision logic about continuation in this case. So you're going to be able to return a plugin result that's going to say, hey, I want to stop this if this happens, or I want to continue this. And if you stop, you can provide a reason, a violation that you can leverage to provide diagnosis and, failover or recovery and all those things. So we showed you that we provide as a library a number of payload types that you can reuse to actually uniformly define those mediation points, but you can also customize new ones for your particular needs. So usually the way you do this is by defining a Pydantic. It's basically it's a Pydantic model. It's a plugin payload that has a few features. It's a frozen Pydantic model, and the plugin manager in CPAX wraps that plugin payload as a copy on write payload. So when we pass the object to the plugins, effectively we pass a copy on write wrapper so that the plugin cannot modify it directly, so that we can control the side effects when we have data transformations. So there's a lot of little things in there that is given for free, but that's what it is. So here, for example, we're defining an email payload. We have a recipient, subject, and a body. And you can also define the result. And the result, as you can see, is bound or parametric type to the payload as well, because you can return the modified payload that the plugin may generate that you're going to then update in the model on return. So once you have those, you define and register them to the hook system, and you implement your plugin. So here you have your email plugin, you have the new hook type that you define, and the definition logic. And finally, how do you wire this into your gateway, into your framework, into your application proper? Here, for example, you have your send email function. So all you need is to import the manager. The manager, as I said, is instantiated once. It can be deployed as a singleton, or you can deploy per tenant. There's some variations there. But in a nutshell, the manager has already read the configuration, the YAML, has instantiated those plugins, has registered them to the different hook points. So then when you call invoke hook here, right, and the email pre-send, and you have created your payload and context, what is going to happen, the manager will orchestrate the execution of your plugins. So plugins are executed in priority order, so you can define priorities. They can be executed sequentially, in parallel. Some plugins can be fire and forget, meaning that you dispatch them and you forget, things like that. And then upon return, you can define your continuation logic, right, and also side effect mutations and things like that. So architecturally, this is more or less like CPAX integrates into middleware, frameworks, and so on. So you have, for example, your agentic flow, your input, issues a request, for example, to MCP gateway. That's the example we're going to demo today. In this gateway, we have a series of hooks, in our case, MCP hooks, so pre and post to invocation, pre and post prompt fetching, pre and post resource fetching, and things like that. And those hooks are going to invoke, via the manager, the plugins that we have registered to those hooks. Right? And like I said, the manager does a lot of magic for you. It takes the configuration, instantiate, and register those plugins. It defines the logic for allow block and modification, and does the copy and write isolation for you. There is a capability model. I'm not going to go into the details, but you can define the authority that you give on different fields over to the plugins. And the plugins also, as I said, you can have metadata that describes if they're going to be sequential because you need synchronicity, or concurrent, or fire and forget. We also have a special payload in CPAX. We call it the common message format. This is basically an abstraction, a message-oriented data abstraction that allows us to basically represent different types of message-oriented middleware and protocols that you might have, right? So there are so many different types of chat completion, inference protocols out there. MCP itself has tools, and so you can basically use this as base essentially representation for us to pass on to our plugins, such that your plugins become reusable and portable as you implement them across systems. And one interesting thing that we do is that we did this not try to supersede or replace different specifications there. We actually look into the specifications and create this for our internal consumption. So basically, when we factor the payload for our plugins, for your decision modules, we factor into this format such that we can also make it security-oriented. So there is extensions. These extensions have a capability model, and those extensions capture standardized attributes that you can use for things like attribute-based policy enforcement or decision-driven processes that you can drive in your plugins. So that's it. And we have examples of implementations for LLM proxies, MCP constructs, and so on. So what I think we've laid out so far, and I'm going to go into a quick demo, is that the hooks that CPAX provides gives you kind of the control plane. It allows you to have full mediation across agent executions, middleware, whatever you have instrumented hooks or CPAX hooks, right? So this gives you this transactional kind of pipeline. On top of that, we have data abstractions that allows us to communicate context into the plugins in a way that allows you to define decision modules that can be ported across implementation. So like Ian was saying, secret redaction that can be ported across agents and middleware, or access control policy that can be done in the same way. It also gives you the ability to define access control policy that follows, especially for OPA and CEDAR style policies, attributes that are now normalized, so that you can have some sort of decoupling from whatever domain specific or specific protocols that you're using under the hood in your implementations. And on top of that, like I said, you can have attribute-based policies. So hooks, they need policies to drive decisions, and those policies need well-defined context to be quality. So that's what we have here. And we have different types of access control plugins shipped as part of, for example, Context Forge, where we actually built a full instrumentation of CPAX into, which supports CEDAR, OPA, and I'm going to be showing here a small attribute policy that we built on top of OPA that also adds side effects, things like deny, tainting, and so on. So I'm going to go into a quick demo, but before I do the demo, let me just set the stage here. So this is an HR agent that allows you to pull use cases like this, compensation for a person and send emails and things like that. These are built on top of an MCP gateway, which in this case is an open source MCP gateway called Context Forge that was created by IBM. Those are the hooks that we have. Those are the plugins that we have registered to the hooks. Notice that in addition to your typical guardrail style plugins that detect prompt injection and things like that, what I would like to point out is this kind of concerns that we are trying to address. So for example, extracting identity claims from your JWT token so that we now can connect roles, right, and authority that a user has to particular authorization or permissioning logic that we can have in an attribute policy. We also have things like being able to mask results based on roles. So if someone has the HR role, you might want to reveal salary. If someone doesn't have the HR role, you might want to mask. I'm going to show how this actually works. And interesting also that we will show is that those plugins, the execution of these plugins can be connected through state. So you can actually track information flows. So we're going to show how this little attribute policy can set taints in the flow here, and then track the data flow execution, and then check for those things, and then permission or non-permission. And prevent things like, write down, for example, send PII out to an email or things like that. So that's, in a nutshell, what we're going to be doing. So if I go here, and I hope you can see what I have here, I'm going to start the quick agent here. So that's a very simple agent built on Olama here and Quen. And what you can see, the first thing, as I connected to the MCP gateway, and I can quickly show you here the MCP gateway. That's context source, that's the UI. I have the gateway here in the middle. I have those 3 plugins enabled, so I have identity resolution, identity delegation for token exchange, and I have the attribute-based policy for authorization that's enabled. I have my HR tools here enabled, and I have my agent connecting to this gateway, right? So I'm gonna basically, as I connected, I hit that identity resolution hook, and you can see here that Alice is basically a software engineer. From the JWT tokens and the claims, I know there's no HR role, there's no PII access, and she has no permission to see SSN from the user, things like that. So if Alice posed this question, you can see here that it's calling the get compensation tool. The agent will try to retrieve that. But because of the policy and the roles that Alice has, you can see that the employee ID is massive, but you see no information about salary. It's all redacted, and no SSN and so on. And you can see here how, for example, this policy is defined, right? So first, in order for you to be able to access anything, there is a global policy that says that it has to be authenticated. But prior and after that, there are additional policies that guard, for example, how the inputs are formatted, additional predicates around what has to be done before the get compensation tool is invoked. And if those things hit, then things are denied. In this case, there is no issue in returning this response to Alice, but notice that because she doesn't have the HR role or the VSSN role, those things are redacted to her. Now, if I switch to another role here, I'm going to switch to the user Bob, and I pose the same question. Because Bob, as I hit the identity resolution, has the HR role, is PII enabled, and can view SSN, it will have a different response, right, from the system. So we'll be able to see the salary, we'll be see the bonus, and also it can also even say, and can ask for the SSN to be included, and because it has that role, then it should be able to see the social security number from Jane. Now, what is interesting, I talked about information flow. So because this policy here has side effects, and we can track state via context as we pass and cross over different tool invocations, you can see here that on success, because I returned this information here to Martinez or Bob, I have a side effect, and this is like a general session tracking, very simple example that I'm showing. But notice that you could actually prefix this with additional predicates and predicate this on other and more complex constraints. But here I'm tainting this information, this session, so that later I can actually decide and make decisions to deny other actions that the agent may decide to do based on that taint. So what I'm going to try to do here, I'm going to say, hey, send an email with this info to, I don't know, manager@example.com. So you can have those kind of interesting generic policies that you can see it's calling, but it's red here, but it's actually a CMF. It's a attribute-based policy denial that says, yeah, the user does not have permission to forward and send compensation details via email, and blah, blah, blah. So this is the kind of things you can do. You can actually connect via removed hops or transactions, policies that enforce things like writing down or reading up, so like enforce confidentiality and integrity properties in your system. So that's in a nutshell the demo. And I think the takeaways from this is that in a lot of ways, security today breaks in production for agentic systems because we choose the wrong enforcement points, right? Some people are, like Ian was saying, a lot is it's an over-reliance on natural language guardrails and other things, when in fact what you need is a comprehensive composition in terms of where you actually place your enforcement and remediation control plane. Another important aspect is identity is often lost across multiple hops, and being able to not only resolve identity, extracting the claims, exchange those things at different points is very important. Tools tends to be overprivileged, data flows are invisible, and what we are trying to do here is unearthing those data flows via taint tracking, and policies tends to be inconsistent because you have very heterogeneous data abstraction. So that's another thing that we try to address with CPAX. So our take on this is that by defining standardized and easy to instrument hooks and adding the ability to define decision modules, plugins on top of those hooks with well-defined context for those policies allows us to fix this without having to rewrite your entire systems. So hooks make enforcement possible. Policy makes it usable, and the context helps us make them correct. So what I showed you today here, and Ian and I showed you today here, is built on top of open source frameworks. So CPAX, like I said, is Apache 2 and fully open source. It's a self-installable library. We currently support Python. We have support for plugins in Rust, and we are in the process of also supporting a core in Rust. And Context Storage is a fully open source and used in production MCP gateway, which leverages CPAX for pluggability.
Question on the taint tracking. Is this purely based on the hooks, the plugins choosing to attach a taint label, or do you have a way of actually, say, annotating like an MCP tool itself, saying this tool returns PII, or this tool accepts PHI, or directly
So we've actually done both. So we actually have tried to extend, submitted a SEP to add coarse-grained taint tracking labels to MCP so it actually return those. I don't think it was well received. One issue is that it would be kind of coarse-grained. Others have actually tried to propose that maybe actually have the tool itself could actually return that as additional metadata. But it is something that we've done. We've got other examples which said, okay, yes, this tool will always return things with these kind of different classification labels. And then we've used that both for taint tracking for information flow, but then also for integrity. If I go and read something from Reddit, I don't want to go and then do a very sensitive operation. We actually want to drop down. So we've kind of done some demos in both cases. It would be pretty easy within our language, though, without support within the protocol itself, and say anything that comes from this tool immediately gets tainted. That taint is something that we could add either in the gateway or the plugin, and then we could actually propagate that through the system and take action.
Yeah.
Yes. Oh.
Just to follow up on that, can that be turned off metadata on tool calls, responses, like the meta field?
Yeah, you can.
Yeah.
Yeah, we didn't show that, but you can actually predicate. So you saw how the expression language has a column and it has a predicate and expression before it. You can make that a condition of, on metadata.
Is the agenting standard or normalization model that you have extensible?
Yeah.
If people want additional attributes, yes.
Yeah, you would subclass,
yeah.
But yes. So everything subclass from our plugin payload, which is very simple. It's basically setting a frozen tag and adding the permission model and the copy and write. But yeah, you can extend it. And sorry, go ahead.
We've also been extending it and abstracting it for other frameworks, for other tools, for other protocols, things like that.
We have done a full, we showed Context Forge here because this is an MCP conference, but we have in research a generative programming library that we have in the open source. We define 19 plus hook types with very different use case. We're talking about like LoRa adapters, kind of, engaging different capabilities for generative programming. So yeah. So this is not strictly for MCP, so you can really do for anything. But we do provide, as Ian was discussing, we try to, for things like that are already standardized, MCP, A2A, identity, we try to provide well-defined data types for you from which you can further extend if you want to.
Yeah. And for some of these like tool calls are pretty pervasive. So you have them in MCP, but you might also have them in your direct framework. And so you can reuse that hook, reuse that payload, all the plugins would then be compatible. So part of this is not constantly reinventing your security controls, your security mechanisms, security implementations. So we define the hook points. You have someone else who takes care of the actual implementations and the policies of those modules, and then they can kind of plug them in wherever it's appropriate.
Yeah. We should use this opportunity to talk about Pulse AI and how we're trying to bring this into as a public discussion, right?
Yeah. So one of the things, if anyone hasn't heard, the Coalition for Secure AI is an Oasis open group with lots of members. Founding members were Google, Anthropic, IBM, we've got NVIDIA, Dell, Cisco, all sorts of other companies. And there's a work stream focused on agentic security, which I co-lead with Sarah Novotny. And one of the things we're trying to do is look at things like this, define agentic control planes, define models, how do you secure agents throughout the entire development lifecycle. And we're hoping to have something like this that actually can work as a standard. So our message payload, we think, is actually compatible with Async, so it'll be extensible there. And we would love for people to be able to adopt it and build on it. And then we can make our plugins and our security implementations kind of portable across the entire stack.
I like the LSM analogy, and the hooks seem really composable, but I'm wondering if when, like a hook enforces a policy, does that make its way to the client, or does it just remain at the gateway?
It goes back to the client. I mean, you saw the plugin violation. So you can actually have well-formatted diagnosis that goes back to a client, for example, that explains the reasons. And
that comes through like just the meta or the response, I guess?
Yes.
Yeah.
Yes.
I think in Malay you did instruct, validate, repair
Exactly.
loop.
So, of course, this is outside the scope here, but in generative programming, there is this instruct, validation, repair loop. So when you are basically during the generation, if there are errors that happens, you can recover from it and basically repair. So when you can also do that via plugins. Like plugins can inject diagnosis via those violations, and then this can be factored into the IVR repair loop. So you can do these kind of things as well. So it doesn't have to be over the wire. It can be also part of your framework, right? Those results that you get back. So yeah, but anyway, plugin results are standardized in the framework, and they have a violation object when a plugin makes a decision about denying and things like that. Yeah. In Context Forge, in the gateway, the way it's implemented, the violation is returned back as part of the JSON response, so you know. Yeah. Another thing that, sorry. No, yeah, I was going to say, another interesting thing is that you can standardize telemetry and observability. So a lot of, in Context Forge, they use that a lot for sending hotel payloads in a standardized way. So those plugin violations or results violations, they can also be standardized that way. Very useful for you to parse later. And
also part of the fire and forget class.
Yeah.
For the policy language that you have in the constructs, as you have multiple plugins in the chain, how are those referenced within that policy line? I assume that you just would add new stanzas to accommodate additional plugins? Or?
Right. And policies can be attached and can be routed based on different conditions. right? So they can be attached to they can involve different sets of plugins. They can be also different sets of tools. So they're logic for you to filter.
So you have conditional logic.
Exactly. Yeah. We are building a new version of this conditional logic that is based on routing. So it's going to be more object-centric, so you'll be able to condition things a bit more dynamically. Right now, our policies, the conditioning is done via configuration is static. In the next version of CPAX, you will be able also to modify those things more dynamically, so via control plane, for example. Yeah, so those things are coming up. Yeah. Well, I really appreciate you guys staying here. Because we thought that we were going to have a round table here today. So this is more than I expected, to be very honest. So thanks for you. Yeah.
Thanks, everyone.
Yeah, thank you. Yeah.